Not yet. Okay. Do I need to turn? There we are. Hello, hello. I think you can all hear me now. Yes? Any reaction? Can you hear me? Yes? Yeah. Okay, you can hear me. I think you can hear me. All right, so welcome to Privacy in Cosmos live in Amsterdam. It is very exciting to see you all in person. This event is brought to you by the Zero Knowledge Validator, and the media partner on this is the Zero Knowledge Podcast, my other entity that I work with. And I mean, this is very exciting. We've done 3 online. This is our 4th, and this is the time that we get to see you in person. This is the first time I'm doing public speaking in 2 years, so it's also weird to see faces, but very good to see faces. So I'm happy to see you, all of you.
So this, hello. So this event was originally supported by the Cosmos Hub. We made a proposal about a year ago, and this, for context, was just before the full launch of IBC. And the idea was to get funding for 4 privacy and zero knowledge focused events in the Cosmos ecosystem, and to run those 3 online, and then this final one in person is kind of the finale of the entire series. And after each event, we've summarized the reports online, and you can also find recordings available on the Zero Knowledge Podcast YouTube channel of all of this. And again, everything today will be streamed to that channel. Yeah,
and I think we're going to share that link on our Twitter. So it's at ZKValidator if you want to check that out.
So a little bit more about ZKV and what we do. On the right, you can see all of our team who are here today. If you need anything, reach out to us. We're also actually looking at the moment for a researcher to join the team, as well as a project manager. So if that might be you, get in contact. We support privacy and zero knowledge research, and our mission is really throughout all blockchain ecosystems to support those and champion them. Privacy is often a topic that isn't spoken about as much as it should be, and is kind of underemphasized sometimes beside other things. And we want to really be the advocate for that, to push it to the top of the agenda. We do that through participating in governance on different chains. We also support emerging teams in all sorts of different ways, from funding and also connecting them with researchers, other people who may be able to help them to launch sooner. And we also launch all sorts of initiatives to help promote and fund ZK Tech. So a few of those initiatives.
So yeah, this year, actually, starting last year, we did an event called ZK Hack. That was a 7-week on the first time and 3-week on the second time workshop series with puzzle hacking. This was a great way to bring new people into the ZK space. We also have just recently completed, but not yet published, the Open Legal Working Group first report. So we basically surveyed a lot of ZK teams to find out what are the legal pain points, what are maybe opportunities. You'll be seeing about that. You'll be seeing more about that soon. And we just recently wrapped up the second ZK Tech Gitcoin side round, where we actually got a chance to get funding directly into the hands of the people building ZK, especially early stage projects.
So aside from that, we also run validators on Cosmos, Osmosis, and very temporarily Evmos. Hopefully watch this space. And we're also running a Cosmos newsletter. That's been going now for just over 2 months, but really growing very fast. Definitely recommend checking that out to stay up to date with what's going on. And we produce some other educational research, which you can find on our blog, and also several other reports.
And that newsletter is cosmosnewsbyzkv.substack. I know that's pretty intense, but it's a good one, so you might want to check it out.
So in terms of this event, the reason why we really initially wanted to do this a year ago is that privacy really is the next frontier for Web3, for adoption. It's something that's needed, given especially recent events in terms of protecting people's privacy on-chain and off-chain, but that isn't getting the attention often that it deserves. And it was very clear from what was going on in Cosmos a year ago that it was really on the verge of an explosion of activity, all sorts of people looking to launch privacy-focused chains, zones, and applications, but these weren't yet getting the attention we thought they deserved, and we really wanted to start to highlight what was going on in a way that allowed people outside of the existing Cosmos ecosystem to really see what was going on. And so the idea was to bring together people working on this stuff inside Cosmos ecosystem, as well as people working on privacy and zero knowledge outside of it, together into kind of one series of events and start to see what came out of it. And it's really clear, kind of a year on, that there's a lot more that's very visibly going on in the ecosystem. I think this event, compared to the very first one, we can see how many teams are now building things and all the exciting stuff that's happened, which is just really amazing to see. And these are some of the teams who are going to be speaking today. And whether you're watching here in person or on live stream, there's going to be a whole series of amazing panels and talks about everything that's going on.
So a little bit of housekeeping about the theater. So we're in the main stage right now. There's a side stage where we're getting your coffee. There's also this networking room with tables. We have a lunch room, which is closed right now, but will be open, obviously, for lunch. And downstairs, we have kind of this chill-out, spacey thing going on, and there will be some bean bags, and you can go hang out there. I know a lot of people are maybe a little bit tired after the week of real-world crypto, if you were there. So, yeah, you can get a little rest. Also, I don't know if everyone is aware of this, but there's actually going to be a dinner later tonight, right here. So you could, I think the event ends at 5, and the dinner starts at 7. You can actually hang out in between if you want, but you could also head home, come back, and we're going to attempt intergalactic karaoke. I have not done karaoke in a long time. I don't know about you, but we'll give it a shot. This is something people maybe are curious about. This is the Wi-Fi. There is a sign just next to the bar in case you don't get this already set up, but yeah, guest at tobacco, all small.
So to kick us off today, our first talk is going to be from Billy, talking about sovereign interoperable privacy right here. We're then going to have Zaki talking about navigating the cosmos, and then Federico talking about Evmos Tokenomics. We're then going to have a break, and afterwards we'll have 2 stages going. There's also going to be one through in the other room next door, which is going to be, it's a really nice area. So stay tuned for all of that. And with that, I think we're ready to kick off.
Yeah. Let's invite Billy to the stage. Welcome, Billy.
Thank you very much. Thank you for having us. Good morning, everyone. I know it's early, so try to make the talk very simple, friendly, lots of emojis. Don't be frightened by a very long title, Sovereign Interoperable Privacy. Let's get started. So quickly about me, my name is Billy Rennekamp. From Louisville, Kentucky, the home place of, yeah? Hell yeah. Home place of bluegrass music, thoroughbred racehorses, and bourbon whiskey. So if you'd rather talk about that today instead of cryptography or crypto, come find me. I'm the Cosmos Hub lead at Interchain, so I lead the development of the Cosmos Hub. Previously, I was developer relations at Tendermint, did a lot of work prior to that in the Ethereum space on bonding curves, NFTs, did web development, and a background in electronic art. So again, you know, we have a chill-out zone. Come talk to me about any of that. Independently, I have an NFT gallery called Folia.app and a generative NFT project called Clover's Network. But today I want to talk about the Cosmos philosophy and why it really makes sense for building especially privacy-suited blockchains. But what is the Cosmos philosophy? Oh, wow, we've got the Android emojis. This is going to be exciting. So Cosmos is all about sovereignty and interoperability. And I'll go into more detail about exactly what that means and why it really works. But before that, I thought I'd give a little bit of a tour of some of the other philosophies from other blockchains. So Bitcoin you can think of as in some ways doing well on the sovereignty front. You know, they do one thing and they do one thing well. And so that means that they have sort of, everybody's sort of on board for the purpose of this blockchain. You know, it's just meant to be a store of value. It's gold. What's missing here was the little emoji with the British Guard. Because as sort of like solely focused on one thing, they are quite insular. They don't really care about the rest of the world. They say, this is the only blockchain that matters, this is the only thing that matters. And so interoperability, bridging to other blockchains, you know, interoperating was never really part of their goals. So they do sort of well on the sovereignty part. You know, it's their blockchain doing their one thing, but they really fail on the interoperability aspect. Ethereum, you know, they do a lot of things. They try to make everything happen at once, which is great. You know, you've got like a stadium where you can all get together, and when you're all in the same space, it's really easy to interoperate. You know, you have access to smart contracts from smart contracts, atomic transactions between them. But this doesn't really scale. I mean, you know the sort of disaster zone when you have a stadium that's filled with too many people, how bad it gets. And the other problem with that is that unless you're in the stadium, you don't really have access to the other people and the services that are happening there. And when you try to scale that, you get overcrowded block space. And the missing emoji here, of course, is the gas canister. That's sort of the fallout that what happens when you're all trying to do the same thing at the same time. Whereas Cosmos, we try to hit the sweet spot of sovereignty and interoperability. And quickly, I'll talk a bit more about sovereignty. So sovereignty means that you have sort of an application-specific blockchain. It does the one thing that you want it to do, and it does that really well. You're not sort of dictated by the other users on your blockchain who want different things from you. And Ethereum, of course, back in the Berlin hard fork last year, all of these Aragon smart contracts broke because they changed the hard coding gas costs for one of the transactions because it was just one user amongst many. And they thought, yeah, this change is going to be better for everybody, but if you're a small fish in this pond, you kind of get wrecked. Interoperability, of course, is when you have an application-specific blockchain, you don't have shared smart contract zone in which everybody sort of has immediate access to each other. And so you need to create a protocol, which we have as IBC, in order to talk to other blockchains. So this little diagram, you can sort of see Bitcoin kind of has sovereignty, lacks interoperability. Ethereum lacks a sovereignty. Everybody's trying to do their own thing, but they're using the same space. They do OK on interoperability as long as you're inside of their walled garden, whereas Cosmos presents and promotes sovereignty as well as interoperability. Why this matters for privacy. Sovereignty is a stand-in for privacy. When you have sovereignty, you can change your blockchain in any way that it needs to, and that's especially relevant when you want to introduce privacy to different levels of the stack. So you can think of the Cosmos SDK as this modular framework that's separated between the application layer, the consensus layer, and the networking layer. If you want to add privacy to the application layer, you're able to do all these sorts of fun things that we see from different projects talking today, like Penumbra, Anoma, Secret Network, and Nym. They're able to sort of design their blockchain to have the features that they need specifically. They can customize it, so it meets the needs of their application. It's application specific. It does just what they need. You can also add privacy to the consensus layer. So there's ongoing work at Osmosis to add encrypted mempool so that you can prevent minor extractable value. This is where you have the transactions themselves are encrypted until they're included in a block, and only then do they get decrypted. So you don't know what the other transactions are inside of the mempool. This sort of modularity allows you to make changes at each level of these stacks, so you can introduce this kind of customization. There's also networking, where Nym and Penumbra have different aspects of cloaking or interacting at the network level, adding cryptography, and Celestia doing, God, I just forgot the word, erasure encoding. Not exactly at the networking level, but relevant to that sort of aspect of the stack. So altogether, Cosmos' sovereignty plus interoperability. Sovereignty being a stand-in for privacy allows you the customization to sort of build your application-specific blockchain to your needs and your users' needs. So how does that look here? It's modular all the way down. Just a bit of an overview. How do we achieve this? The Cosmos SDK is the application framework where you can see the stand-in for the Cosmos Hub. It has a protocol between that and the networking level called ABCI. And so this is a separation between what your application does and how the consensus is achieved and the networking operates. And because all of these separations means that you can make changes at one without having to make changes at every single level. So it allows you to jump in just where you need to, as well as IBC. IBC, we have a talk later today as well. There's sort of a possible future development introducing zero-knowledge proofs at that level as well. So each of these pieces are sort of ripe for targeting and elaborating, extending, and adding different privacy capabilities. And then, so this is the way the world works right now. You can jump in and do any of these sorts of things. But what I'm really excited about coming next that offers another sort of interesting configuration is interchain security. So interchain security is basically a separation of concerns from the validation and block production of your network from the application layer. Interchain security means that you can take a blockchain like the Cosmos Hub and use the same validator set there. And the way that this works is basically every blockchain, looking back to this set, uses ABCI to communicate with the consensus layer. ABCI says, hey, who's allowed to produce blocks on this network? Inside of the application state, typically you'll see proof of stake module that says, oh, I've got a bunch of stake representing these different validators. They're the ones who are allowed to produce blocks. That's great. But if you don't want to build your own validator set, you don't want to worry about that part of your application. Say your application is extremely focused on just one very specific thing, and you're like, okay, I don't really need a token for this, or hey, I don't really need to introduce this whole validation system or recruit all these people to operate it. You're able to use the same validator set of the Cosmos Hub, use the staking module of the Cosmos Hub that says these are the ones who are allowed to produce blocks. And instead of using ABCI to talk to your own state machine that says these are the validators, you use ABCI to talk to the Cosmos Hub's set of validators. They're the ones who are given permission to produce blocks on your blockchain, so your blockchain just does what it's supposed to do at the application layer. That's interchain security. That was kind of fast. Do we have any questions here? Please. Yep, exactly.
What if you had, so the follow-up question is, what if you had your own blockchain and you wanted to actually maybe not share default validators with the Cosmos Hub, but like have multiple instances of your own chain to share validators? Would that also be enabled more easily with this separation of instances? I mean, I don't know those plans the first time.
Yeah, actually, so that's...
Really? Can you repeat the question?
Yeah, so the question was restatement of basically interchain security, but the question was, if I have my own blockchain, can I have multiple instances of my own blockchain with the same validator set? Is that kind of...
Yeah, being able to have validators work on both instances of the chain.
Being able to have validators work on both instances of the chain. Yeah, so we like to say there's two ways to scale a blockchain. There's vertical scaling and there's horizontal scaling. Vertical scaling is where you basically make changes in order to increase the number of transactions per second. You know, there's all sorts of tricks, bells, whistles, and band-aids to sort of maximize the number of transactions per second that we've seen across the entire blockchain space. There is like a physical limit, you know, to how many transactions a single state machine would eventually be able to do, even with all of these improvements. And so at that point, we like to think that horizontal scaling is the way to go. And horizontal scaling is essentially taking one blockchain and just redeploying it. You now have two instances, so it can process twice as many transactions. However, traditionally, if you launch another blockchain, who's producing blocks on that network? You know, you need to start a whole new staking token. You have to raise value for that if you want to have the same security. And so instead of having to rebuild that aspect of the blockchain, you can replicate the validator set with interchain security. And that's basically how we're approaching the Cosmos Hub right now. So a couple of the first projects launching with interchain security later this year are projects which could otherwise be deployed directly to the Cosmos Hub. Now, one nice aspect of that is now that you have two instances of these blockchains running, you know, you sort of double the capacity for the block space. But the other really nice thing about that is that it decreases the surface area of complexity and faults on the Cosmos Hub. So if the Cosmos Hub needs to be this super secure blockchain that's never stopping running, you know, atoms need to flow all day long, how do you add more and more features without introducing more risk of, hey, maybe there was a bug there, maybe we're going to have a chain fault? You push it off to a separate blockchain. So the Cosmos Hub, all it needs to do is just export the validator set over IBC to this other blockchain. And if that blockchain has a bug, it stops, maybe something bad happens, doesn't affect the Cosmos Hub. It's able to continue producing blocks, continue shipping out, you know, this is the validator set. Once this other blockchain comes back online, it's able to get all the sort of updates and keep running. But it's sort of created fault tolerance around the sort of application state, which is a really nice feature, and exactly why we're sort of approaching it, because we do think the Cosmos Hub needs sort of the highest integrity of security, should not be introducing unreasonable risks, and pushing it out to interchain secured zones is a way to sort of be much more adventurous on the features that can go on the Cosmos Hub without introducing extra risks. And this same concept can apply to any other blockchain. It's a bit like multi-threading for a blockchain. You sort of are able to separate the concerns and maximize the throughput, as well as yeah, like I said, separate the concerns. Question from Will?
So one of the main reasons you would expect chains to continue to like launch with their own validator set as opposed to like inherit whichever one is the largest, like the Cosmos Hub?
Sometimes the validator set does more than producing blocks, and you know, I can imagine that offers a level of complexity that they might decide, oh, my validators need to be much more than just block producers. They also need to be X, Y, or Z. And when those concerns overlap really well, then I think it makes a lot of sense. Sometimes there's aspects of the token economics that really, you know, demand or make sense when you have an independent validator set. One aspect that I like that I think is going to become more visible is actually the separation of concerns for what the duty and the job of a validator is. So right now on Cosmos chains, the validators produce blocks, yes, but they're also governmental representatives. When you delegate stake to your validator, you sort of give them the ability to vote on your behalf. Now, we have liquid democracy, so if you ever disagree with what your validator is voting for, you can put in your own vote that goes against it. So you always have access to your own tokens to vote in part of the protocol. But generally, most people just let their validators represent them. And we've gotten a lot of feedback from validators that they actually feel conflicted about this. You know, they're top of their game producing blocks, running infrastructure, but that doesn't mean that they necessarily have a really well-informed decision or opinion about like the application that they're running, the DeFi protocol itself. You know, they don't know necessarily the parameters for the inflation, et cetera. You know, let them do the one thing that they're really good at, running infrastructure, and let the other people who are, you know, informed in the application perhaps be more present and active at the governance level. And when you have a separation of concerns with interchain security, you're able to sort of say, okay, Cosmos Hub validators, you're, you know, the longest validator set, you've been sort of the oldest, the best, you've made the trail, you've learned all the lessons. Like, do the thing you're really good at, produce blocks, but let's have a separate governance token on my interchain secured zone. And you're able to reproduce basically the same governance system, except for instead of being a block producer and a representative, it's just representatives. When you enable that, you're actually able to expand the set of validators on that consumer chain, is what we call the sort of chain that's consuming security, in order to have way more than 100, 200, 300, which is sort of the maximum set of validators we see in Cosmos chains today, because it doesn't have the same implications. You know, when you have massive, massive validator sets, you potentially have slower block times, there's more network congestion, but when their only job is to be governmental representatives, it can be sets into the thousands or more. Any person can say, hey, you know what? I'm really active. I really understand what this project's trying to do. I'm going to register as a validator. It's in quotes because they're no longer asked to produce blocks. They're just asked to produce governance votes. And hey, delegate to me. Let me vote on your behalf because you know that I'm spending every single day in the Discord. I'm spending every single day on crypto Twitter. And I'm really, really excited about doing this work. And what's kind of interesting is when you reproduce the governance system that we currently have, these purely elected individuals are able to charge a commission on the block rewards. They actually have a really interesting way of earning money for being active and part of the validator set. Hey, let me charge 10% of every block reward because I'm going to do a great job making this network valuable. I'm going to make sure that we continue to sort of improve it in the right way. They can get the delegations, they can earn an income for this. And all they have to do is just care about the protocol. They don't have to care about producing blocks because I think if you look around there, it's actually really hard to produce blocks. And we see protocols who are launching with thousands of validators or have goals of millions of validators. And there is sort of this question, like, can you expect millions of people to be able to run really high quality infrastructure? Because it's not nothing to produce blocks. So it's another sort of nice characteristic that comes out. But again, there are certainly lots of value in launching the traditional way. It's new technology. I think everybody's always a little bit nervous about trying things out new, but I think we're going to see a nice sort of testing ground where those new ideas show their value. Any other questions? That went way faster than I thought. I'm really sorry. I didn't get... We're on time. Look at that. Amazing. Cool. Well, thanks very much. Look forward to the other talks today and all the other projects coming up.
Thank you. Oh, yeah. Do you want to give this? All right. Next up, I want to introduce, I'm sort of not on the stage. Next up, I want to introduce Zaki, who's going to be talking about navigating Cosmos. And yeah, we found the mic for questions, just for future Q&As. Yeah, it's this little thing. Just be sure to say the question into that so that we capture it for the live stream. Cool.
Hey, thank you very much. Okay. So this is a talk that is tangentially related to the topic of this conference, which is the question of, like, how do I actually build something in the Cosmos? And I think 2021 has been an enormously successful year for Cosmos. The IBC vision finally came true, and it basically did everything we said it would for the last 5 years, which is kind of wild. And now we see lots of people building new zones, lots of people employing privacy tech. I'd say one of the things that we do the worst in Cosmos is it is extremely hard to figure out, like, how do you get all the knowledge to build the thing that you want to build? And the people who are so far been most successful at building things in Cosmos tend to be people who've been in the ecosystem for a long time, who worked at Tendermint during the, like, when we were like sort of building all the initial pre-launch things, people who are like associated with the ICF or an existing validator. These are the people who've been building in Cosmos. And so what I'm going to try and do in this talk is kind of explain how does building stuff on Cosmos work, with some goal of trying to make it more approachable to people who aren't like already in our social network of people who like can like help you navigate. So Cosmos is like highly decentralized. There is no one labs company that like coordinates all the building, that does all the business development. Like there isn't there isn't even a single organization that probably has like the entire top to bottom stack of how everything works, like in their institutional knowledge. Like everything is highly decentralized. I also think it's like very good that like it's very good for like resilience. This project is also essentially 7 years old. Like 2014 is really the origin of Tendermint and the Cosmos idea and the world of interoperable blockchains. And so typically when you're building in Cosmos, you will encounter situations where you have to like cross from like domain expertise to domain expertise to domain expertise. You can't just find like one organization, partner with them, and expect them to sort of help you. So we're going to try and figure out, like, in this world, like, how would you build something on Cosmos? These are like common questions that I hear. Like, here are a bunch of like I want to build thing. Like, I have discovered that I am at like some sort of technical impasse. I don't know what to do next. This doesn't even get into the question of like, how do I get funded? Though that has like largely become a much easier question because it's like no longer anti-consensus to fund Cosmos things. I don't think that these questions are like the only questions or like the most important questions, but like basically like from my little segment of like trying to help people build on top of Cosmos, I hear this a lot. The other thing about these questions is they don't tend to have one answer. There isn't only like part of this whole thing about sovereignty, interoperability is there are like very many answers to all of these questions. Like, I want to write an application that interacts with IBC and like want to do it like relatively quickly. Like, you could write your application as a Cosmos SDK module. You could write your application as an Evmos smart contract. You could write your application as an Agoric smart contract. You could write your application in Rust on top of CosmWasm. And like, these are all answers. How would you decide? How do you like decide in this trade-off space? So why? And I think there's like to go even further down the rabbit hole as to why, before I try and answer this question, is the way Cosmos achieves decentralization is we decouple research, implementation, and go-to-market at like a sort of very profound level. If you think about, for instance, the life cycle of IBC, right? It was most of the core research was done at like Informal and the Interchain Foundation, going back to like extensive research on Tendermint light clients. Then implementation again was like split up among multiple organizations, and then go-to-market was basically done by osmosis. So like, that's a very unusual pattern in the technology industry. It's a very unusual pattern in the blockchain industry, and it like represents like the fundamental decentralization of Cosmos. And like while the story of like decoupling research, implementation, and go-to-market for IBC or like for ICS for like token transfers over IBC is basically done, we are still like, there are many ways in which this like is in an intermediary state. So like the auth-z functionality, for instance, which lets you delegate account functionality. Like the implementation is done and shipped, has go-to-market is still like in its early stages, and there's like various validators like figuring out UIs and stuff like that, and eventually someone is gonna nail it. I think there are some things like interchain staking where we're trying to do a very sort of tightly coordinated go-to-market, but that's more the exception than the rule in the way Cosmos is like builds. So you as a builder should not feel like you have to start at the beginning at the research stage, or that the people who are doing research on something like ABCI++ are going to do the go-to-market for it, because like historically that's not how things worked. So you as a builder should feel comfortable jumping in at any stage of this process and being like, hey, like I see you have been researching this stuff, I will work on an implementation. I see you have built something, we could work on, I could do a go-to-market. This is a sort of unique thing that exists within the Cosmos ecosystem, where you can grab these pieces of open source technology that we all build. We are all basically fully committed to building in the open. There's very little in Cosmos that is like tightly siloed in some private repo that you have to like ask permission. You typically like see what it is that we're working on and jump in. So yeah, this is the. Okay, so the other thing is Cosmos has a lot of documentation, like tons of documentation. Documentation in source code, documentation in the Tendermint spec repo. You know, there's like a 20-page IBC spec. But I've basically seen very few examples of people succeeding in this ecosystem self-onboarding through our docs. Like the docs serve a purpose, but this is not like, you can't do this via documentation. So one of the most powerful things to have in Cosmos is mentors. There are a lot of people, like basically I would describe the like standard way things get built on Cosmos is people find mentors who have like domain expertise on the things that are providing like, who can help them with like architecture, help them with the trade-offs of like, do I build my thing as a Cosmos SDK module, a CosmWasm smart contract, an EVM smart contract? And this is very much like the nature of Cosmos. So how do I find a mentor? And this, I think, I'm gonna try, like this part of the presentation is an attempt to like sort of like kind of list people who would help with like different mentorships and like sort of different technical verticals. It cannot be a comprehensive list. I almost certainly forgot someone. Like I just put this together in the last like 2 days. Also, I'll probably give this talk again. So it'll get better over time. But like there are a lot of people sort of sitting in this area of the room who like know how to build stuff in Cosmos, and you know you should take advantage if you are sort of not in the tent right now to like meet these people, build relationships, because they'll also be the ones to help you find like so yeah. People who have been building in like the sort of core Cosmos community have been working on this for something on the order of 4 to 8 years. So there's like a huge amount of context that like has been built up. Like they're basically like the only blockchain projects that are as old as Cosmos are like Bitcoin, Ethereum, and Cosmos. Like we've been at this for a very, very long time. Okay, so like what is the general process of working in Cosmos? The general process of working in Cosmos is we set up a shared Slack or a Telegram group or a Discord. We like try and you find one person who kind of knows the sort of Cosmos landscape of people and expertise, and then we try to like kind of like bully, invite, invest, do deals, like do business development, and then we sort of allocate that, and then we start to have regular calls about like a given project. Like there's some regular touch point that gets built up. Everybody hates more calls, but like this seems to be the best way to like maintain technical momentum over years. So there are like generalist Cosmos experts, and it's like when I say generalist Cosmos expert, it's people who have some familiarity with like almost all of the pieces of Cosmos. Again, not a comprehensive list, but like, you know, this is like, it's very, very helpful to like have access to the generalist Cosmos experts. And like, if you kind of look at like what is going on in Cosmos, there is a lot of like, there's a lot of kind of trying to like get access to those people, find who to talk to. In order to sort of be a generalist Cosmos expert, you probably have to know a significant amount about how Tendermint works. You have to have like significant Cosmos SDK dev experience, and you need to have a significant amount of IBC experience at this point. Otherwise, you're really not going to be able to help. But the generalist Cosmos experts are kind of the, just sort of like the sharp end of the spear. And frequently, like, they also are sort of overloaded by like the sheer number of projects that they are like helping, involved in, advising, et cetera. So this can't be the entire world. And so, you know, all of these people are very active in the ecosystems, but they also tend to have projects that they are like playing like executive level roles in, and, you know, people are busy. So yeah, I'm gonna give people's like some combination of names, handles. Like, it's hard to navigate the space. You can definitely find me online if you actually want to be like, hey, like, how do I get in touch with this person? The Cosmos SDK is a little bit different because it is much less dependent on mentorship. There are a bunch of sharp edges to the Cosmos SDK, especially around like how do you upgrade from like one version of your module to another version of your module. But like on the whole, it's mostly just like a process of sort of learning as you go. IBC, on the other hand, is an extremely complex protocol where there's an enormous amount of domain expertise, and people are able to pull off like crazy stuff. You know, getting like when like Juno was restarted, in order to update the IBC channels, you had to pull blocks from like the pre-crash version of the like pre-security vulnerability version of Juno and the post-security vulnerability version of Juno, and like push them over an IBC channel to update all the IBC channels and like revive the osmosis like token trading for Juno. And like the ability to like understand how like all of these pieces fit together is extremely domain specific. I think like building new IBC application protocols, interoperating smart contracts with IBC, doing IBC state machines that are not based on Tendermint or the Cosmos SDK, all of these things, huge amount of domain expertise that is like slowly being built up and slowly being disseminated into the world. There's still like a lot of like missing pieces, but like help is available. Until recently, I would say, until basically like maybe the last few months, I would basically say that building a non-Cosmos SDK Tendermint app was basically like not something that was like something that was a well-described process. It's a thing that a lot of people are interested in because they want to bring code that was written in like other ecosystems. They want to write their application in Rust. They want to use advanced cryptography. It's becoming much more approachable to do this because you have like Anoma and Penumbra building with open source repos and like being able to see like how they are solving all of these problems, and it's actually becoming like much more likely that someone could succeed. Bridging is like another sort of huge topic. So you want to reach like virtually everybody who builds in Cosmos kind of comes to this question of, hey, like IBC is great. The IBC ecosystem has many billions of dollars of assets, but it is not everything. I want to be able to talk to Ethereum. I want to be able to talk to Avalanche. I want to talk to all of these other things. There is a huge amount of like enormously complex stuff going on in the bridging space in Cosmos, and that's another sort of very tricky piece to like understand. Do I use the gravity bridge? Do I use Axelar? Do I use Gravity Bridge? Do I use Axelar? Do I use Wormhole? Like, what is my bridging story going to be, and how am I going to interoperate beyond the IBC world? Enormously complex topic. Definitely requires mentorship. Otherwise, you're just going to like stumble over the same problems that like many other projects have. So you're interested in building on Cosmos. You don't know, what do you do now? So like the best things to do are to like DM people, find people on Telegram, find people on Twitter, tweet about it. I think I follow like basically every account that has ever tweeted anything interesting about Cosmos. Like you can DM me, will help. I do read cold emails to Occlusion, hello@occlusion.io. Probably don't respond to them as much as I should, but I definitely read them. And I'm sure there are lots of other ways to like get in touch with other Cosmos ecosystem participants. So thank you very much.
Thank you very much. Thank you. Is there any questions maybe before Zaki goes away?
Questions?
I'm just going to throw it, so please catch it.
Nice catch.
And
No.
sorry, but that's what we're going to do. So if anybody has a question, you just have to catch the pillow.
Cool. So obviously, like that covers off a lot of the more technical, like building side.
Yeah.
Like, do you have any guide for like the more like governance-y, like marketing, BD side of like the entire?
Yeah, I could have given like a whole talk on that. I honestly think like that is like another area that like so there's like a couple of stories here. Like one is like every other part of Cosmos works the same way as the technical piece, i.e., there isn't like any central entity that does anything. Like our most effective marketing channels are like a random swarm of like awesome YouTube people and like Twitter influencers who have like built organic communities of sort of like cosmonauts. Like Strangelove and CryptoCito like do like regular like YouTube live streams. In general, like getting like into that community is a great way of like communicating to the faithful. From a fundraising point of view, there's like most crypto funds have like are like fairly positive about investing in things in Cosmos because IBC worked. And so like it's generally easy to do that, and like sort of general crypto PR. There's also like a lot of overlap in like PR firms that a lot of different Cosmos projects work. So like, you can get intros and be like sort of in the same network. So, yeah.
Cool, thank you.
I'll do, I guess, one more question.
Yeah, sorry. So thanks. So if the goal is to keep, well, let's say to scale the ability to support new projects that are building, do you imagine it as basically keeping this general model of mentorship, but adding, going from like 10 to 1,000 of these mentors and sort of experts who can help, or would you expect that at some point it'll need to switch to some other model for like incubating and supporting new chains?
I'm kind of fairly bullish that like we're going to be able to like scale this way of doing things. Like it like works well. Like a big part of like what is I think glorious about Cosmos is also that there's like we designed a system that like doesn't have the gatekeepers for making big changes that like other ecosystems have. Like you can just like build a project, permissionlessly connect to the IBC network, like build your own marketing channels and like do stuff and like bring value and attention. And you can, if you want to like build a new, more advanced version of Tendermint, you don't have to like even talk, you don't have to convince the Tendermint team, just like build it and like connect it to IBC, and like people will be like, oh, that's awesome, and maybe people will upstream like your stuff. I think this like sovereignty plus interoperability model is very amenable to this like kind of like organic expansion, and all we have to do is like sort of like take like make sure that we like are steadily turning every like successful builder into like half a dozen more mentors, and we can just like organically scale to like the ends of the earth. So thanks, Will.
Okay, one more round of applause for Zaki. And now we're introducing to the stage Federico Kunze-Kulmer.
Hello, everyone. Welcome to Privacy in Cosmos. This is not a privacy-related topic, but it's more about how the Evmos token model works and how it can be used to create incentive alignment across different actors, which include also privacy decentralized applications and also privacy-oriented validators and users, of course. So today I'm going to talk about the problem context, but this talk should be more about like EIP 1559 and incentive alignment across different actors. So what is EIP 1559? This was this massive effort by the Ethereum community to try to solve all the user experience problems that users were facing regarding transaction fees and gas costs. And there was also like economic benefits and security implications of this functionality, but basically it was trying to create a fee market so that the transaction fee was more predictable for users, and so you don't have to wait for additional confirmations or like multiple times, multiple blocks when suddenly there was a sudden increase in the block space demand. I'm not going to dive deep into the EIP 1559 because that's like another topic, but I'm going to explain now how it works at a higher level. So before EIP 1559, the fees and the block rewards were going straight to miners. So the total of the gas price times the gas limit was going to the miner itself. But after EIP 1559 was introduced, the fees itself was split between the base fee and the priority tip, and only the latter went to the validators. And they were still receiving the block rewards, but the base fee was burned as part of these economic benefit that was creating like a deflationary model. And of course, the miners were not happy and they went all against the developers. And so there was this massive drama over early 2021 where miners trying to like create different threats against the developer community and the whole Ethereum community to do a 51% attack and effectively like hard forking Ethereum. And yeah, like even Vitalik created a blog post. But in the end, they were more or less right in the sense that a lot of the Ethereum was effectively burned, and if it wasn't for EIP 1559, then those Ether would go straight to their bags. And of course, when you're messing with someone's bag, they're of course gonna get a little bit anxious about this functionality. And on the other side, there was like a huge push from the Ethereum core development teams to how to improve EIP 1559 to like widely adopt EIP 1559 because of all the UX benefit that it brought for the different users. There was even like core development teams and dApps that were pushing for this like I support EIP 1559, which was a result of like this situation between like the different miners and also the developers. So going back to the original model, like one of the main problems here was that miners thought that the core like developers had most of the powers, as you can see here, like the how miners saw Ethereum. But Ethereum is actually a big community of not only developers, but you also have like decentralized application developers, DeFi users, holders, and in the future there will be stakers, also miners and core development teams. So in reality, developers are only a small part of the entire Ethereum community, an entire community, as we can see in different projects nowadays. So they weren't really incentive aligned with the project because, like, other than the foundation, there's no sustainable long-term model for how to create alignment for the different teams developing on the protocol. So the question is, like, can devs do something to create these incentive alignment between all these different actors that I showed before? And that's why on Evmos, we're introducing the novel dApp Store mechanism. So the dApp Store is basically a decentralized marketplace where you have dApp developers and users that meet together, and instead of burning the base fee as traditionally is in EIP 1559, you're basically splitting that between the developers that are building constantly on the protocol, and also the validators in this case for Evmos. And the priority tip is still going to the validators, same as the block rewards. So this effectively solves the incentive alignment and creating alignment between different actors that were previously in conflict in other ecosystems, and how to create alignment with the entire protocol. So in this case, for Evmos, core development teams, decentralized application development teams, and miners, or in this case validators, will be incentive aligned to the long-term success of the protocol through this fee split mechanism in the dApp Store. So going back to the other part of the community of users that we have, how do we incentivize now all the users that are interacting with the protocol? And there has been this running joke on Twitter when you basically have a sudden spike in the gas price. So like the easiest way to deal with this is just create another EVM fork. And you create a new EVM fork, you start developing new applications, you basically fork some of the blue chip applications in other ecosystems. You create a DEX, you create a bridge, you create some lending platform, whatever. And then you maybe have a DAO to fund some of the development teams, etc. But in reality, there's no sustainable long-term incentive program that is not one-off, that can create alignment between the users, developers, validators, and that is sustainable in the long run, that ensures the success of the project. And there have been multiple attempts to do this. So we can find Avalanche Rush, Polygon DeFi for All, and DeFi Summer. And BSC also had an incentive program that is basically trying to attract new users to provide liquidity for all the DeFi applications, but it has certain limitations. And the limitations of these DeFi incentive programs is that they're not sustainable. It's only a one-off. So one-off program that basically allocates $100 million for incentives, but it's usually also not community-owned. So they're only the foundations are choosing which of the decentralized applications are eligible for these incentive programs. So sometimes are not transparent. How do you know what are the requirements for your application to be in this incentive program? And usually, the biggest problem is that it doesn't really reflect the traction of these decentralized application projects and the adoptions of them in the layer 1 protocol. And also, TVL, as we know, doesn't reflect that there's a growth of users. So that's why on Evmos, we created these novel usage incentive programs where it's directly proportional to the utilization of each protocol, where in every epoch that creates new tokens, those tokens are split between the staking rewards, the team investing, the community pool, but they're also 25% allocated to user incentives. These user incentives are creating incentives for the users that are interacting with the smart contracts. And I'm going to explain that now how it works. So the workflow here is that we have developers or users or any or any user of the Evmos ecosystem that can create an incentive or register an incentive through governance. Say, for example, I want to incentivize this little contract. I'm going to use Diffusion as an example. I'm going to incentivize Diffusion to get like a 5% of all the newly minted tokens from this 25% that I mentioned before, for a period that is allocated every week for a duration of 6 months. After the proposal gets approved and voted on, every transaction that interacts with the diffusion protocol and the diffusion application will start collecting gas. And these gas will be accumulated in these gas pools, where at the end of each week, you will basically calculate each of the pro rata shares of the total gas that you spent in these contracts compared to the total amount of gas that was spent during this period, and then you're going to distribute the Evmos rewards. So basically, just trying to summarize here, how the Evmos token works is basically creating like a positive reinforcement cycles where developers and users propose usage incentives to more growth to their decentralized applications. These incentives drive users and rewards with Evmos tokens. Then the users take these rewards and spend these Evmos tokens in the decentralized applications and services provided in the Evmos platform. And then through the dApp store mechanism and the free split mechanism that I explained before, developers earn half of the transaction fees for each of the transactions that are targeting their contracts, further incentivizing the development and the growth that allows them to create a sustainable long-term funding mechanism, and then you create more proposals, etc., and then the positive reinforcement cycle continues. So Evmos, and going back to the original community and how the Evmos ecosystem works, Evmos is trying to create incentive alignment for all the different users and validators and decentralized application and DeFi users in the entire ecosystem. So for example, the Evmos holders or Evmos stakers will be able to stake their tokens or LP them. Like the DeFi users will have the user incentives. The decentralized application developers will have the dApp stores, in addition to the grants and community pool, which can also apply for core development. And also the miners, or in this case, the Evmos validators, who have the transaction fees from the dApp store mechanism and the block rewards. So Evmos is trying to create an incentive alignment between all the different actors in the entire ecosystem to ensure a long sustainable growth and in the ecosystem. So developers, validators, and users are going to make it. Thank you very much.
Do we have any questions? Okay, so
Sam?
thank you. Oh.
Hey.
Hey, Sam.
Are you worried that this is going to be a disincentive for gas optimization?
Can you elaborate?
Well, if developers are getting a cut of gas revenue, then you could basically, launch an Aave fork or something that's just like gas disoptimized, basically, in order to get more revenue.
That could be the case, but usually, so half of the fees are also going to the validators, and there's also the base fee can also be changed through parameters. So instead of being a global as an Ethereum that is not changed via governance, we're also introducing the base fee that is, instead of being set in the blockchain state, is can be configurable. So if the base fee is already high through our governance proposal, it can be decreased so that that also decreases the sort of like the fees that are being burned, that before were being burned and now are split between the validators and the developers. So if someone tries to, I guess like if the entire community of Evmos decentralized applications try to not be gas optimized, like the community could just like lower the base fee.
Okay, thank you very much, Federico.
Thank you very much.
And now we invite you for 20 minutes break, so enjoy our cookies, our coffee, and see you here in 20 minutes for Anoma's presentation. Hi there, we're going to start very, very shortly. There's one change. So the talk that was supposed to be in a side stage, we moved it here at 12:30. So no worries, everything is on schedule. You're not going to miss anything. So we're going to start in 2 minutes. Sorry? Is she ready? Yeah. Okay, so I give you the mic already, and I'm going to introduce you, okay? So welcome back after the break. And now welcome to the stage Fatema Shirazi from Anoma.
Okay. I'm going to talk about privacy today, but I hope the title will convey the message that I want you all to take home. It was inspired by No Man is an Island. I guess you guessed that. And I wanted to explain that privacy is complicated and that we should collaborate more together for better privacy. The talk is going to be about, I'm going to have some introduction on what privacy is, why I think it's complicated. I have a bit of a review of existing privacy enhancing solutions in the blockchain space. I'm going to talk about what type of privacy they provide and how they could be improved. The talk is not about saying that any solution is bad, but just to explain to you how it's complicated and it's important to understand that complexity. At the end of the talk, I'll explain what the problems are from my point of view and what we can do. So why should we care about privacy? I assume you all care about privacy. That's why you're here. It allows people to choose what type of information is revealed about themselves. And it's important because knowledge about personal information allows abuse, it allows discrimination, it prevents people from participating in the society freely in a democratic way. So it's important. Why is it complicated? I had to add a picture of a bicycle here in Amsterdam. And the point here is to show that even if that lock is the best lock that humankind can make, this is not secure. I hope you all agree. Even I could lift this bicycle and run away with it. And the lock is amazing. Let's assume the lock was done by, I don't know, NASA, whatever, the best people on Earth. But this is just, security is more complicated than just having a solution, a very secure solution. Generally, security deals with confidentiality. It deals with integrity and authentication, while privacy deals more with our social interactions, our activities, because it's hiding personal information. So it's a bit more complicated than some security properties. And it's important to look at solutions from a multidimensional way. In this picture, you see that one dimension is the lock. The other dimension is what is the bicycle locked to. And that part is completely ignored. So if you just look at solutions from one dimension, a lot of them seem amazing. But the reality is they are not really secure. It's just an illusion of security. And to add also why I think privacy is quite complex is it is connected very much to our daily lives. It cannot be achieved in an isolated way like security can. A lot of privacy is about hiding your activities among activities of other users or even fake activities that you could make up. But this is very expensive and it's very difficult, it's very cumbersome. For example, we are all awake at certain times of the day. Waking up at 3 a.m. and sending a message just to have a fake message sent, this is cumbersome. And what is to be added to privacy is also it's connected to our family and friends. And they might not care about privacy that much as we do, and they might find this too expensive or cumbersome. So that makes, from my point of view, privacy even a bit more complicated and difficult to achieve than security. In blockchain, normally in blockchain, at least traditionally in the past, blockchains were supposed to be, or people thought of them as private. But what they really were, like Bitcoin or Ethereum, is they had pseudonymity. So you have accounts that are not associated to your personal identity, but it is a single account, and everything is transparent. The problem with that is if you use it carefully or no one is looking, it could be okay. We don't know who Satoshi Nakamoto is. And it's pseudonymous. It's not great privacy, but we still don't know because it was early days, no one was really looking, there was not that much activity. But as soon as you start to have activity with a pseudonymous account, this is going to become sooner or later broken. An example of that is you can have an account in Bitcoin, Ethereum. As soon as you send something to Kraken and you have KYC and your passport picture or something, game over. You send it to someone that the FBI can get to or some government, again, game over. So there is a lot of ways where maybe if you do one transaction, pseudonymity is okay. If you want to do it on a daily basis a lot, it's almost impossible to be enough. So what we have in traditional blockchains, we cannot really count on the privacy. You can get lucky, maybe no one is looking, but the chances are, if you use it a lot, you're not going to stay private. So I hope that I have convinced you that pseudonymity is not a great idea for privacy. Before I start to look into existing solutions, I wanted to explain to you what the attacker model or the adversary is. Because there is no, from my point of view, there is no absolute private, like it's not 0 or 1. You're always secure or private against a certain definition of what the adversary or the attacker is. And the example of this is like the door. The door here is secure, if you lock it against some sort of adversary. Is it secure against a tanker? No. It's not going to be secure against every type of threat. And depending on how good the door is, it will keep out different types of adversaries. So it's important to understand that complexity. One thing to take into account is who your adversary is in terms of how widespread they are. Is it someone who just locally has access to a transaction? Is it someone who can have access to everything? Is it the NSA? So the reach of the adversary is different. The other question is whether the adversary is poor or resourceful. How much are they willing to spend? How much money are they going to spend to attack you, or how much money are they going to spend to analyze information to find you? And something that is very relevant here in blockchain is memory. This is often not talked about in security and privacy circles, but I think it's very relevant for blockchain because a lot of the privacy solutions here are about short-term memory and long-term memory. People consider things that are not on the blockchain to be private, but the reality is you're just not having it there for someone who has a very short-term memory. So someone who cannot, remember what happened yesterday, of course, if it's not on the blockchain, then fine. But if someone can remember anything that has happened, then just the fact that it's not on the blockchain is not going to be enough. So whether your privacy definition is not being on the blockchain or not, or your privacy definition is never being anywhere on the internet, that's a different, is a distinction. And the last one is being a passive adversary or active. So you see there's a lot of nuances in what the threat model is. So let's go to the first solution that I found. I have never used many of these. And I want to emphasize that this is not critique on any single solution, but rather really showing to you the complexity. So mixers. The idea of a mixer is that you, instead of sending a transaction directly from a sender to a receiver, you're sending it a bit around. You send it to fake accounts that you created, and they're sending these transactions around until it goes to the receiver. And hopefully, no one knows that all of these fake accounts in between were your own. They will think that these were other people, and it will somehow disconnect the direct connection between the sender and the receiver of a transaction. It is private for a very, very weak adversary. So your adversary has to be really, really weak for you to consider this pretty private, because maybe one time you can do this, but if you do it a couple of times, with chain analysis, this is not so difficult to break. But it's one solution. Another solution are off-chain transactions. The idea is that you have some sort of settlement on the main chain. All the microtransactions happen off-chain on a different network. So here I have examples like Lightning Network. On Bitcoin, you can have a settlement between two users. They lock 200 worth of Bitcoin, then they go off Bitcoin. They do a lot of transactions back and forth, which is not recorded on Bitcoin. And in the end, they come back and settle the rest, what is left over. So what you achieve here is that on the blockchain, on the Bitcoin blockchain, there is really not much information about all of the activities between these two people. But that's really what it is. You're not really private against a strong adversary. You're private against the adversary that only can see Bitcoin, and that's it. Like their computer only sees what happens on Bitcoin. And here I wrote in the problems that a local adversary that sees what is happening between these two sender and receiver can easily find out the connection between the sender and the receiver. And another point is, and I didn't bring this up in the previous slide, but is timing correlation. And this is quite big in the privacy community. You identify people based on timing. It's metadata. There's a famous quote from a guy in NSA who was saying, we kill people based on metadata. We don't need to know. Just the fact on when someone is sending what. If you do it long enough, you can identify, based on who is awake when you have activity, you can identify who is having a relationship with someone else. So timing correlation in this case is still possible. Another solution is Monero, which is a very elegant solution. The idea is instead of having one signature that is identifying the identity of the sender, you have group signatures. So you have 8 people who sign something. So each one of these 8 people could be the signer. The signature does not identify which one of the 8 people has signed. This is okay if you do it once, and if the composition of these 8 people also makes sense. But I can give you an example. Maybe there's 8 people, 7 of them are from Vietnam, and 1 of them is from Switzerland. The receiver is also from Switzerland. It's not so difficult to guess that probably the guy who sent from the one Swiss person in the 8 people is the one that signed the transaction. So is it a bad solution? No. But is it perfect? The group size is too small. Depending on the diversity of the signers, depending on how often this has been used, this can reveal information. The other point about this, different than the Lightning Network, the off-chain transactions, here the whole history is on the blockchain, on the Monero blockchain. So you can look really into this, look at the signers of each one of these group signatures, and at some point it should be possible to identify some people. They do also, in Monero also you do not hide any timing signatures. So again, based on activities, based on when you're awake, when the receiver is awake, there is a lot of conclusions that one can make. The next solution is Mimblewimble that has been deployed in Grin, Beam, and Litecoin recently also. The idea with Mimblewimble is that you aggregate transactions. It's very similar like going to a restaurant, and when you pay, you put all of your money together and then pay the waiter at once. The waiter doesn't know which money came from who. You're aggregating transactions from different people and then just give the collected transaction to the blockchain, which is cool in the sense that it's also reducing the amount of transactions that are recorded on the blockchain. So it's a scalability also solution. The problem that Mimblewimble has, though, is that collecting these transactions, so collecting these bills, has to be done in a way that the waiter is not seeing them. If the waiter sees who is putting money on the pile, then really you're not achieving much. And the same is with Mimblewimble. The network layer where these transactions are collected has to be designed well. And if these transactions are, just broadcasted, which they are in some cases, then you're secure against someone who has a very short memory and does not remember what was broadcasted and only sees what is on the blockchain. But you're not secure against someone who can remember, oh, I have seen these transactions before, and then later on they were added up and put on the blockchain. The last solution I have to review is Zcash. It is also very elegant, very nice solution. Zcash uses zero-knowledge proofs, and the idea is that the sender, receiver, and the amount of the transaction are not visible. It has a transparent and a shielded mode. Basically, in the transparent mode, you're very similar like other blockchains. In the shielded mode, the sender, receiver address, and an amount of transaction are hidden, which is very cool. So I really like Zcash. Though there is still some problems that also Zcash has. One is network layer. When a sender is, the timing that a sender is sending something and the receiver is having any connection to Zcash, this is not hidden. What Zcash suggests is using Tor, but it is not integrated in the protocol itself. The other problem is that there is no hiding of timing signatures. One can have transparent, funds transparent, and then put them in the shielded pool, and then remove them again, and there is no delaying between these. So if I have 2 users, Alice and Bob, they both shield, then they do the transactions, they unshield every time, they do that at the same time. At some point, it's very clear that these 2 people are exchanging transactions with each other. And this is, again, not so difficult such conclusions are not so difficult to make. So what are the problems? The main problem I see is that often in the blockchain world, people equate using a tool as we have solved privacy. And it's just not that easy. If you use Tomato, you don't have Bolognese. There's more complexity. There is more details that you have to take into account. If you just use layering signatures or just zero-knowledge proofs, this is not solving the solution only. You have to look into the whole dimensions on other details that you're adding. The other problem that exists is that there is not really a standard for threat models or solutions. All of the solutions that I presented to you, they were really designed for different types of adversaries, for different types of needs. But these are not really standardized. So for the user, like let's say my mother or my dad, who are not privacy experts, if they would they would use any of these without really understanding what the difference between these solutions are. So I think we need more standards for both threat model and for solutions, because otherwise, for the user, it will be very, very difficult to know what solution to use. And the last part is that solutions are not compatible or complementary. A lot of solutions are solving very nicely sometimes one part of the problem, but then when new people come on board, they do not build upon that, but create something new. And I understand that. It's cool to create new things. It's not so cool to go fix other things or complement other things. But we have to remember, as an adversary, you attack the weakest link always. If you want to get into into a room, you don't go and try to crack open the most difficult door that the room has. You will go through the window, which is open. So ignoring the dimensions and solving something is just giving an illusion of privacy, but for an adversary, you're not really doing much. This is more of an illusion of having solved the problem. So what do I think we should do? First of all, we should identify complexity. We should acknowledge all the problems there are, the needs that the users have, the whole stack, whether it's wallets, and I wanted to add information about wallets, but I thought that's a whole new presentation. It would be too much for 20 minutes to talk about. So wallets, the blockchain, so many parts of the whole stack have to be taken into consideration. The second part that I think is important is to have privacy as a goal and not have using a tool as the goal. So the same is, again, when we talked about tomato and bolognese. The question is, do you want to make bolognese or do you just want to use the tomato? And this is something that you have to have in mind. So privacy should be the real goal. The other point that I think is important to improve the privacy of the whole space is simplicity and understandability. So we need to make solutions as simple as possible. We also need to make them as understandable as possible for users. The next point is privacy loves company. Privacy is often about hiding in the crowd, hiding among other transactions of other users, hiding your identity in the forest of all other users. And that's why it should be easy for users to participate in these tools, because the more users you have, the more privacy the rest of the users are going to have. And the last part, which I hope is one of the big messages that you're going to take home, is collaboration. I would really, really, really wish for more collaboration between blockchain, projects in general, but definitely privacy, blockchain projects that care about privacy. It's important to have compatibility with each other, to work on standards, to improve things. And the last slide is about the project that I'm working in the moment. How is Anoma trying to improve? Sorry for the red. I hope it's not too much of a contrast. Compared to, so what is Anoma trying to do? We are trying to work on we are working on a multi-attitude pool. The idea here is to allow users to use similar technology like Zcash does, but with multiple assets. So allow users to also enjoy interoperability. The next point that we are working on is design of incentives that also take into account privacy. So normally incentive design focuses very much on economics, on incentivization in terms of security, but for us, privacy is a big factor there too. We are working also on end-to-end privacy, and this is looking into privacy for the whole stack. And this is something that also came up in a presentation before. We are using the IBC standard and are working on private bridges, and mainly to allow users from different types of chains like Penumbra, Namada, Anoma, and Ethereum all to be in the anonymity set, which basically makes the forest bigger and makes the crowd bigger and hides users more. So that's it. I hope that you all take home that we should collaborate more and we should get into the complexity of privacy. Thank you.
Thank you very much. Before we release you from this stage, do you have any questions?
Was everything too difficult or too easy?
Yes. Could you maybe highlight some of the end-to-end privacy things that you're doing?
The privacy?
Yeah, within the end-to-end layer, like networking and mempool and stuff like that.
I did not hear.
You mentioned that you're also addressing privacy end-to-end.
End-to-end,
Yes.
yes. So what we are looking into is integrating, looking into the network layer privacy and integrating it in our technology. We are also looking at privacy at wallets, which is basically where the users are interfacing the most with the blockchain. And something that we are also looking into is delays, which is the timing signature that I was talking about. So yeah, we're trying to really look into, starting from the user, on the blockchain, anything on the way, where are places where information can be leaked.
I guess I'm just interested in how does the private bridge design work and like.
Oh, that's a good question. I have not been involved with the private. Do we have Chris here? Maybe you want to, because I have a private bridge in mind, but it's not the other design that do you want to?
Yeah, I can give a quick answer here. So the tricky part in private bridges in the IBC context is balancing these competing goals of providing fault isolation, which IBC has in ICS 20, by metering supply transferred across the bridge. So it's like basically one blockchain has an account on the other blockchain, and you can stop the other blockchain from sending back more assets or other kinds of state transitions that you didn't originally send to it or didn't originally authorize it to do. But as soon if you have, say, Zcash-style sampling circuits on multiple chains and just do zero-knowledge proofs for your IBC cross-chain transactions, that's fine, except that now you no longer have a way to meter supplies. You don't have this fault isolation. So in order to preserve this fault isolation, we need some kind of encrypted computation that allows us to keep this counter, say, of how much supply of a particular asset has gone from chain A to chain B, while not revealing it. Because if we revealed it each transaction, that would, of course, break privacy. So we're specifically looking into a solution that uses basically limited additive homomorphic encryption. So when you perform a cross-chain shielded transfer, you can add to this encrypted counter and test this encrypted counter when you perform a transfer in the other direction never goes negative, meaning that more assets are never sent back than you originally sent, but without revealing anything about the value of this counter or the value of individual transactions. So it's mostly a cryptography problem to try and get these two constraints that we want to satisfy.
Thank you.
I think we all said thank you very much once again. A round of applause for Fatuma. Now, on the stage, one of our hosts, Will.
Fantastic. So next up, we've got the first panel of the day. So I'm going to ask our lovely panelists to come up. This is going to be a Validator Roundtable panel discussion. And so we've got 4 validators on stage, but actually I know there's other validators in the audience. And so the the topic really here is about what validators are and what their role is to play in the Cosmos ecosystem. I think 2 years ago, there were major questions about whether it would even be economically sustainable to be a validator and what it would end up looking like. Some of those answers we've had over the last 2 years, but we know there are major changes continuing to come for proof of stake and validation, particularly here with, earlier we had the talk from Billy about interchain security and what that might mean for the way that zones and security is done in Cosmos. And we also have the evolution of liquid staking in many different ways. And so those are some of the topics we might touch on. But before we do, I think we can introduce everyone on the panel. And so first of all, just quickly to introduce myself, I'm Will. I'm one of the founders of Zero Knowledge Validator. We run around 10 different validators on different chains, and particularly are focusing on privacy and how that can grow the value of different blockchain networks and trying to advocate it for it at every level. One of the sort of really exciting things is that at the moment we're on the cusp of quite a few privacy-focused zones or chains launching, and so we're really getting ready to support those at their launch. But Elizabeth, maybe you want to start with introducing yourself.
Sure. So my name is Elizabeth Barnes. I work with Figment as a senior protocol analyst. I've been doing it for about a year and a half. And Figment runs over 60 different 60 validators on 60 different networks. But we've been participating in Cosmos for a very long time, particularly with governance and also with the infrastructure. So.
Yeah, and I'm Xavier Megan from Chorus One. I'm the head of research and ventures at Chorus. So Chorus, we've been pretty sort of, I guess, contributing back to Cosmos for many years now. We're one of the first, I guess, playing in the very sort of early days of the incentivized testnet back in 2018, I believe. I've been at Chorus for a year now, and yeah, very involved with like new networks that are launching in Cosmos and analyzing these networks.
Cool. And yeah, my name is also Will, and I also run validators under the name of like Binary Holdings. We're a bit newer to the space, but we run things on a bunch of different chains, and yeah, producing blocks and stuff.
Fantastic. So Elizabeth, maybe it would be really useful. I think everyone has a different view on what role a validator might play on different chains. But from your point of view in Figment, what do you see as kind of the most essential role that validators play other than providing security?
This is a really good question. A lot of people are asking this these days, actually. So other than providing that security, providing our infrastructure, like the other role that we see validators playing is participation in the community. Being a good steward and owning the network is important. As we're seeing, I think, different types of validators come about. So you've got, staking as a service, what Chorus One and Figment and among others do. But then you also have smaller validators who aren't as focused so much about the service part of it. I'm thinking here of Strangelove, Inquisition, these sorts of things. And then, with this interchain security model and new types of governance, you have validators that aren't providing security, but they're still providing that governance aspect of it. And so as we get different types of validators, I think the role that validators currently play in terms of providing security, participating in governance, and then just being good representatives and having the calling of decentralization and this forward-thinking look will now kind of separate into different roles, into different ways that way.
Will, would there be anything you'd add there in terms of different roles that you think are important, or would you echo most of that?
Yeah, I definitely think like echoing a lot of that. To me, like validators are just like very like hyper-engaged community members. A lot of what the roles of validators are is just kind of like finding ways to actually like contribute and give back to like the communities of like all these different projects and whatnot. To me, it's like the actual like process of like running a validator, like the infrastructure and whatnot. A lot of that I think is very like commoditized and like fungible. It shouldn't matter like on the protocol level, like who produces blocks. Like one block produced by one validator is the same. It should be the same as like a block produced by another validator. And so a lot of like the differentiating factors are just like how do people actually kind of contribute outside of that, and kind of like what sort of value do they add in the kind of like broader scope of things. And so in a lot of ways, what a lot of validators have kind of differentiated into and kind of like specialized in, and a lot of like finding their niches in are things like, okay, people are going to make like block explorers, people are going to make like host like public RPC nodes, host like database snapshots, make like dashboards, like staking interfaces, do some of the like Auth-Z stuff of like auto compounding and whatnot. And so I think it's like a lot of just kind of like being able to find a niche for things, and being able to kind of like contribute back to the communities for a lot of these things.
So I think both of you have mentioned governance. Zave, in terms of Chorus One's approach to representing, let's say, like stakeholders and people who are staking to different Chorus One nodes, how do you make sure that the opinions of delegators are being listened to, as opposed to, or do you think that's an important sort of aspect of it?
Yeah, I think I've got a sort of classic response here, which is, of course, we use the Telegram. We have a community channel where if there's ever a controversial vote, we'll sort of send that out to the community. But I think what's interesting is that, many people think about the community, which is, of course, very important. But then the people who aren't voting in the community, you take their vote in Cosmos especially. And so what happens is, like internally at Chorus One, is that if there's a controversial vote, we'll actually vote ourselves, like inside the company, what we think the vote should be. So you have the people, the delegators, which of course matter a lot to, what they want, and you have to listen to them. Otherwise, and one of the powerful things in Cosmos is that if you don't listen to your delegators, they're going to let you know about it, and they're going to send their stake elsewhere. So you have to be really responsive to the delegators, and then if they're not responsive themselves, then you have to make sure there's internal consensus for what you're voting on.
So on the kind of more recent controversial, like Juno proposal, for example, how did each of you, and it's kind of an open question, how did each of you handle that internally and externally in terms of how you voted and how you communicated it?
Personally, like I just love the fact that like this proposal was made, partly just because it really just gets the community like engaged in things. Like the actual thing itself, I think is kind of wacky, but like just the fact that this kind of proposal kind of like you see this kind of like in all the different kind of like community channels of things on like Reddit and Telegram and Discord and whatnot. Like people are just kind of like losing their minds over it. And so to me, like I would love to see people propose more things like this, just in the sense of like things that might be controversial, stuff like that. Just because I think kind of like as a community, kind of like working through some of the issues for that kind of like makes it stronger afterwards. And so yeah, definitely would love to see kind of more things like this. In terms of like the actual thing itself, I don't know. I think it's a bit of a slippery slope to be able to kind of like take like tokens away from people. I think it probably should have been figured out in the airdrop stage of like when like where things should go to. But yeah.
So we had a whole bunch of different Slack conversations. We try to keep things in like one thread so you can follow the conversation, but what happened is this proposal came out and everybody saw it at different times, and so we had all different sorts of conversations happening, and we ended up having 2 really long threads about it where like the majority of the folks from our protocol team participated, and other members from marketing chimed in, and we had a very robust conversation about Juno 16, which is really awesome to see for us. And we had the discussion about what the proposal actually was doing and the long-term effects of it, of immutability and these sorts of things. And then we also had an internal discussion of how we were going to vote on it. So it was really cool to have the juxtaposition of like both what it actually means for the protocol, what it means for the future, and kind of what we as an organization were going to do about it. Eventually, we did submit our vote, and we posted it up online. We said, hey, this is how we're going to vote on this, and here's why. And so that was for our delegators. And we also have a Telegram channel where they chime in with their opinions as well. And then we also share that with our clients as well, so they understand. And we provide avenues for them. If they disagreed with our vote, they can always go in and change it.
Yeah, and I think Figment did a really good job with how they communicated their response for that proposal. For us, it was again an internal conversation, and I think the majority said no. But just sort of thinking of this proposal, so I'm quite good friends with DeFi Times, who of course have the Friends Validator in Cosmos, and they're very community oriented. So Chorus One, we voted no because we didn't believe that we just thought it was against sort of what crypto is about. And then DeFi Times guys, they're very community oriented, and they really listen to the delegators, and they're a bit more maybe retail as well. I mean, you never know, but. And they voted yes, and then now they're sort of somewhat scared of the legal ramifications. And so I think I was also speaking last week with JK from Stakefish in a podcast, and he mentioned that he could see like much more controversials coming to Cosmos. Like I think this will be the first of many. So for better or for worse, like one of the beautiful things about Cosmos is the governance and the democracy. So yeah, I expect to see more like this in the future.
Very interesting. So I think the kind of next topic really related to how validators is sort of linked currently with governance is interchain staking and interchain security and the ability to kind of share in different ways security. First of all, like between with existing validator sets, almost exporting their security to new chains that might want to launch, but also sort of links to liquid staking and how that might also impact the way that chains can share or interact with validators. For example, liquid staking from Osmosis being used to potentially provide security on multiple other chains using AMM pool tokens. How do you expect this to impact, first of all, like your business models and also the way that you interact with new chains over the next few years?
Personally, like I think a lot of what is interesting is just a lot of these new chains when launching and whatnot. The validator set kind of like when those kind of come out is kind of like an experience sort of. It's like the process of actually just like launching and whatnot is just like this whole kind of thing. Especially it's interesting opportunities for new people to come in and kind of being able to participate and whatnot. And it's kind of something where it's like people that might be kind of like a fan of whatever specific project, but maybe they're not kind of like as in tune with the broader like Cosmos ecosystem, for example. This can be like an opportunity for them to actually kind of like participate. And so I do think kind of like there is a place for these things, and kind of like, I don't know, like interchain staking and whatnot is great for a lot of things, but it can kind of like take away that opportunity from some people for some things. And so to me, like I do really appreciate kind of this whole kind of like process of like a new chain launching and kind of this whole process just like coordinating a bunch of validators to kind of like do things and whatnot. But I also see kind of like the flip side of this of like new projects launching, people wanting to maybe not necessarily having to cultivate their own like validator set for things. This can be a lot more easier to actually just launch, and just because that launch process kind of sucks and is very hard to actually kind of do and coordinate a bunch of people and whatnot. And so I think there's like pros and cons to it, and it's definitely something, it gives more options to people like launching to be able to choose kind of what they actually kind of want to do there. So yeah, I think it's an interesting new kind of primitive for people to use for building.
Yeah, I think for us, maybe more focusing on the liquid staking. So, of course, Chorus One, we've been researching this for many years now, and we were a Genesis validator of Lido for Ethereum. We then built Stake Sol, which is Lido for Solana. We then were ideating a lot in the last year about liquid staking in Cosmos. We now have Vish and Roya who are here, and the Quicksilver team who are building out, this liquid staking zone in Cosmos. So I think it's really exciting. I think, there's massive potential for Cosmos. A lot of what Quicksilver is building sort of attacks many of the flaws of Lido itself, just using the model of Cosmos with, the proxy by governance and everything else, and all the other features. Like the UX, I'm sure will be a lot smoother, and that's like in due part due to Kepler, for example. So that's just one side, of course, which is liquid staking. I think you'll see in the next year or two liquid staking in Cosmos. There's, of course, Terra already exists, which Chorus One is involved in as well with, B Luna, which is massive on Anchor for those that use it. But I think, Q, Atom, and Quicksilver assets in the next year or two will really take off, and that will surprise many people. And then in the interchain sort of security side, I think that's going to really improve I guess like you don't have to bootstrap your own validator set anymore. So what I can also sort of foresee in Cosmos in the next year or two, the last few years in Cosmos, it's been like executing IBC, chains bootstrapping validator sets. It's taken a bit longer to go to market in Cosmos, but like some of the networks I'm seeing now in Cosmos, also the core developers in Cosmos, what they're building, I think the next year or two in Cosmos is going to be much more about scaling and in a secure way, and I think that's really exciting.
Yeah, I'm really excited for interchain security because of this way that validators will no longer have to run the infrastructure if they just do the governance. When we talk about what community is, it's not just people like sitting behind a screen in a forum. The community is much stronger and it has a much stronger coming together, I think. So if that's the case, and then we'll have this interchain staking, what this allows is individuals, like genuine community members, genuine token holders that may not have, they may not be whales, they may, all these things, they can have a much larger say in governance, and specifically with governance votes. We're not really sure what the long-term effects of having these infrastructure providers govern a protocol kind of the way that it's been going. Traditionally, when we think about who makes decisions on a protocol, it's usually infrastructure providers, validators, miners, these sorts of things, because they either have the capital or the technological expertise to make those decisions, right? Either through voting or through implementing a binary. So once we have this interchain staking, now the core decisions can be made by a delegate. And so that kind of flips the tables, and it's a new model for token-based governance. So I'm really looking forward to seeing that.
I think that's a really interesting differentiation compared to now. But I mean, of course, there are other ecosystems, actually Polkadot being kind of one of them, where you do have a bit of a separation between validators and governance. And we may then see some of that come into the Cosmos ecosystem. And it's unclear at this point whether that's a better model. I mean, obviously, validators are big stakeholders, some of the biggest stakeholders, and have a lot of involvement. But separating it in some ways it definitely was going to change the environment. So I think we've got one more question before we open it up to questions from the audience. So have your questions ready. But specifically, actually, I think for Chorus and Figment, how do you see your kind of responsibility in not becoming too large? Obviously, you're also running staking as a service. So how do you balance that with trying not to have too large a stake as a validator and therefore compromise decentralization of the network?
Yeah, I think, of course, this is an important issue and one that we care about deeply. I guess for a network to be decentralized, it can't just be a few core validators in a cartel. I think one of the things with liquid staking we're seeing right now, actually, especially with Lido, for example, on Ethereum, if you've been keeping up with Twitter, there's some backlash with like the Lido validators, which is about 20 of them, because the staked ETH is going above almost 50% now. So it's really on us as the validators with higher voting power to make sure that the validators with less, like we can maybe translate skills to them. We can sort of guide like mentorship. Zaki mentioned it before. Like I think a lot of the small validators that I talk to, the infrastructure is sound. Like I'm sure the infrastructure is the same as Chorus One. Sometimes it can be a timing thing. So Chorus One has of course been around for a while. So you would expect these newer people to come in and it would take them a longer time to get the delegations. But then it's about like helping them to receive delegations through connections or through telling them what worked for us. So it's like sharing what worked for us to help them with their communities, build their own brand. Like, you have Binary and these newer guys, Friends Validator, CryptoCedo. I mean, they're all fantastic, and we want to see them all thrive and support them in the best way possible. So I think one of the nice things about Cosmos is that it's like really co-opetition, not competition. And so like, you have Figment and Chorus, and we've been around for a while. And of course, we're on many networks like Solana and Ethereum as well. But in terms of Cosmos and also these other networks, it's not in our best interest to keep it centralized. So I mean, we can't say, please delegate. I mean, you could say maybe like delegate away for us if we have too much voting power. But normally we don't go above 3% on average. And so if you think of 100%, that's not very much. So, we're way below the threshold where it'd be a problem.
Yeah, I generally agree with that. I think the new kind of coordination that we're seeing between validators is really cool, and having this shared knowledge between, like, we're not really competitors, we're collaborators. And so seeing those relationships evolve is really beneficial for the protocol and also just for the field of validators, as we see more and more individuals who pick up the skill because it's a way to make revenue. It's a business model. The more competition, the better, because it's not competition. It's just more people to collaborate with.
Fantastic. So, okay, it's time now for any questions here. So, yeah, starting over from Billy.
Here we go. Thanks for the panel so far. I have a question. So I like to think of validators as sort of sharing the responsibility for operating the network. But I'd be curious to hear your all's thoughts on the responsibility of the validator for sharing the liability of operating the network, especially in the context of privacy, where there's probably more potential to butt up against the law or be liable for operating networks that might have anti-money laundering violations. Similar in the idea of operating networks as a security. Like Ethereum launched and the SEC said it was not a decentralized network, it was a security, but it's now sufficiently decentralized. And like how committed you all are to standing in the way of the law to protect the operation of a network. Like, is that part of your core business model? Do you do research on that? Do you do like advice from lawyers? Like, how much of that is in your mind space?
Maybe I'll start off on that. That's actually something which is a topic the Zero Knowledge Validator actually did an open legal report on earlier this year. It's one of the key focuses because there are obviously a lot of people who are worried about that. It's not a unique problem to validators either. In Ethereum, roll-up operators may have some very similar concerns, and the kind of potential implication of money laundering if you are the essentially kind of facilitator of transactions on especially a private network are pretty major. I think a lot of people are sort of betting or sort of hoping for this scenario where we can say these networks are provably decentralized enough that it doesn't matter who's running, like, there are enough people running these nodes that you can't necessarily say that any single one of them is sort of operating it and running it. That's still to be tested, of course, and I think there are certain jurisdictions where actually some clarity has been given as to the fact that by running a piece of software that's open source, as one of many, you are not yourself providing this network, but that is something which I think most validators should be worried about. And I would be interested to hear if the other panelists have done any sort of research or taken any advice on that question.
I was going to say, definitely it's an interesting thing just because right now I think we're still kind of just early in the global kind of like legal regulatory kind of clarification on a lot of these things. But I'm excited for like things to kind of settle down a little bit more just because right now I think a lot of, like there was a framework by which people can launch projects and people could actually run things in infrastructure in like a compliant way, more or less. And right now it's like some things are clear, some things are not. And I think as we kind of move towards more clarity on things, it's good, but like at this current point in time, people just kind of bear a little bit more risk in terms of the liability that they have and whatnot. And I think for like a lot of people, it's like the risks of this, the rewards actually like participating in these things, actually like helping projects launch and being a part of a lot of these things, the rewards from that like outweigh the risks of potential kind of like legal viability there. And that's kind of like where I think a lot of people sit there. But I'm excited for things to maybe be a little bit more clear.
So Chorus One, we're a little bit more institutional. So of course we do work with lawyers sometimes, not all the time. But if the risk is significant enough for us to be like, is this something that for us as a company, it's worth us participating? We would consult with them. So if we think of Cosmos networks like Anoma and Nym, normally when we look at these networks, there's like in very small text, like small risk, there might be a regulatory problem here. But I would say, like us as a company, we tend to not think about like what the regulator might do. We tend to just operate these privacy networks because we believe in the privacy networks. And then if something happens, we would like then look into it. I would say though, like research in this area, we're of course partnered with Zero Knowledge Validator as well, and we really love the work that they do in privacy. And so we're lucky to be around people that are doing great research in this. Plus, in Chorus One itself, we have some great cryptographers that sort of aren't working necessarily on cryptography right now, but if anything was to happen in terms of regulation or anything like that, to be more redundant, I guess we would put these guys and girls onto a project like this to make sure that we continue to operate nodes. It's not, at least I don't believe we have any intention, if any regulation came to stop running nodes, we will work with lawyers, we'll consult, we'll also work with cryptographers to make sure that we're still supporting these private networks.
I don't know if I can speak directly for Figment in this instance, but I can say that it's regulation is one thing that we've been paying attention to, and we're looking forward to clarity in the law and working within that.
Thanks for the panel. A little bit of feedback. So I believe all three of your validators white label, and it's a little bit of a kind of murky area. I kind of only know what associations and which projects you're white labeling for through conversations. What responsibility do you feel your validators have to indicate the degree to which you're white labeling, the percentage of the network that you have under your control, and how do you see this evolving? Are there going to be standards set where you're at least kind of indicating which validators you are white labeling for?
Yeah, so this is something I was just talking about on Wednesday. So I think this white labeling is another type of validator, and you've got staking as a service. You've got public validators that way. You've got smaller ones, and then you have these white labeling ones. And this is just something I just started thinking about. So I'm imagining there has to be, or there might be, some sort of potentially a KYC by the protocol in the future. We kind of see this now with some of the top validators. So Terra does this. Once you submit your identity, you get a little blue check right next to your name. And so some block explorers record that and do that. But the question is, if you're supposed to remain self-sovereign, why would you KYC validators in this way? So I think it's going to come down to self-regulation, I think, because you want these things to remain open and permissionless. So if you KYC a validator, you don't want to say that you can't be a part of our set or anything. So yeah, this is an ongoing conversation that we've been having, and I'm really interested in hearing other people's thoughts on it.
Yeah, I think it's a fantastic question, actually. I think even for us and for many people, it is definitely murky in terms of how much you should disclose or not. Yeah, I think, I guess at Chorus, the way we think about it, 'cause I think sometimes we think many years in the future, we think that there will be significant competition between validator white labels in MEV. And so I guess, of course, if there's one validator that takes much more MEV than another, I think that could be a problem in the future, because you'll get much more yield as a white label if you go to this validator, or if you get maybe you get delegations in some way. So I think in a sense, for us and in general, perhaps MEV and centralization around that is even more of a problem than white labels. So at the moment, we do disclose some of our white labels, maybe not all of them, but sometimes it's I think something with white labels is the agreements. So maybe the stakers themselves don't know they're staking with some white label node, because it's hard to tell. And maybe there could be some more transparency on if a node is white label or not. I think the community eventually will start talking more about that. But I think people will be surprised to find that even those that do run white labels like Figment or Chorus, even then the market share isn't outrageous. Without giving many things away, if I look at Cosmos versus Ethereum, I would say the stake and delegations in Cosmos across all networks is much more decentralized than something like Ethereum, for example.
Yeah, and also I think this whole like white labeling process and whatnot, this kind of goes to what I was saying earlier of kind of the actual infrastructure part of validators is it should be like pretty commoditized and like pretty fungible. And to me, that's kind of like what the white labeling part is mostly, is kind of like being able to just outsource the actual running of infrastructure to somebody else. It should still be kind of like up to the responsibility of the people that are actually like using the white label service to either like disclose it or not, or use that as a part of kind of like their communications for how they want to be represented in the community and how they want to maybe like attract delegators and whatnot.
So I guess there's kind of like two parts to this question. One is on the general theme of, as validators get more delegators and get into the top 10, how should they be responsible for ensuring the decentralization of the network? And one example that comes to mind when I was thinking about this question is that there was a recent proposal on Osmosis, which was trying to redistribute staking rewards across all validators to try and incentivize people delegating with lower ranked validators. And actually, if you look at the votes, you can see that the delegators with a higher share are obviously saying no because it goes against them. And actually, the highest ranking validator to vote yes was Binary Holdings. So here is like a clear example of where kind of validators have directly used their power to vote against something which would benefit lower ranking validators. So how can this be reconciled in the networks that you operate on?
Personally, like I would love to see kind of like a framework for where like staking rewards or just kind of like rewards in general are kind of like done in proportion to the amount of like value add that like a validator kind of like gives to things. And right now, at least, kind of like I don't think the current way of like voting power in like delegations and whatnot are like definitively representative of like how much actual kind of like contributions like someone gives to a bunch of these networks. There's a lot of things where it's kind of just like, even kind of like for maybe like smaller networks and whatnot, a lot of the value that people give are just like being in chat rooms, like answering questions, participating in discussions, like making things, kind of like giving things back to the community and whatnot. And I would love to see kind of like a framework where we can like reward people kind of like based on some of those things. And this is like a very subjective and like not very like quantifiable thing, but I would love to see kind of like a framework where we can actually kind of like support people based on like contributions and whatnot. I think like partly proposals kind of like this are like in a good direction towards that. Right now, at least, I think kind of the way that kind of things are represented in terms of like voting power and whatnot is partly just like branding and marketing and a lot of things like that. And so I would love to see just like better ways to support like smaller validators, better ways to make things kind of like more sustainable and kind of redistribute a lot of kind of the wealth that people are getting, just to have like a more sustainable community like as a whole, I think.
Yeah, I think if we think about the Polkadot staking mechanism, I guess like nominated proof of stake, they do try and do this a little bit where it's like they want everyone to have a similar sort of reward and different stake. And I think if you make the system too complex, sometimes it gets very confusing for the validators themselves. And I think that's one of the core negatives of Polkadot, is that it has this system actually. And so, you know, when it comes to, I guess, trying to distribute some of the rewards to the lower validators so they might get more and they might move up the ranks so it becomes more fair. And also the voting system, I guess, comes down to governance as well. So one of the great things about Cosmos is that you might have validators like, you know, Chorus, Binary, or Figment saying, no, we don't want this because we want free market, for example. However, if it's how much, I think you should leave it to the market, and the market is the community. So if the community really thinks that the small validators should be given more of a chance than Chorus 1, for example, they can change their vote and say, like, you know, screw you guys, or they can redistribute their stake to the lower validators. So I think, like, us validators, like, maybe it's in our best interest, I'm sure, to vote against this proposal because, you know, we have our business and our own operations and cash flows. But the community is up to decide anything in the market, and I think, you know, that's one of the great things about Cosmos. So, yeah, who knows in the future what that will hold.
So historically, in the past, Figment has actually, when we've gotten a majority stake on a network, we've actually redelegated some of those tokens, similarly to like a foundation delegation program. We did that with the Graph about a year ago now. So one thing you said is that it's within validators' best interest to like vote against these proposals that would redelegate stake like this. And it is if you're coming from like that free market standpoint of get money. But if it's not within the best interest of the protocol, then it's not within the best interest of validators. And if we want to move if we want to move from distributed models to decentralized models, personally, I would really love to see validators continue to have a redelegation program where they redelegate their tokens to other smaller validators who either contribute significantly to the protocol somehow or apply for these sorts of programs. I would love to see that continued decentralized stake happen.
One more question at the back.
This is a quick question for Course One because I'm really interested in liquid staking and the game theory behind how liquid staking derivatives can start to proliferate on the dApp ecosystems of all these like general purpose blockchains. Have you thought through what the long-term effects of stake derivatives might be on the security of proof of stake networks, especially if stake derivative tokens start really efficiently tracking like the rewards and the value of the underlying base asset? If their proliferation as like a token of exchange starts to increase and potentially unseat like the base asset, like what kind of weird attack vectors would you kind of see in a proof of stake network where staked ETH, staked like other tokens on Cosmos start to get more popular?
Yeah, so I think like our vision has always, and I think many people in crypto's vision has always been to have the staked asset to be, have more TVL or whatever, been across all DeFi apps as opposed to just the asset itself. Because if you think about the staked asset, that's of course being secured by validators in the back end plus earning yield. So it's like good for both parties, the user and also the validators in the back end. And so, like, I guess I sort of mentioned it earlier, but when you talk about Lido, for example, I think there's like 20 to 25 validators there. So going back to that point, I guess it's not a problem because these are great validators. And the thing with Figment and Binary and Chorus as well is like, we have a reputation ourselves. And that's one of the great things about proof of stake is that the security of it itself. So Lido's different because there's a smart contract and you hope that they can merge properly. But right now they're getting a significant amount of stake, maybe 50, 60%. And so staked ETH is, of course, in Aave now and DeFi applications like that. And I think everyone wants this to be like the base asset. And so, of course, shouting out Quicksilver again here, one of the great things about liquid staking on Cosmos that's going to come out in the next few months, which is really exciting, is you get rewarded for choosing validators that are securing the network in a better way, which is really unique to any liquid staking that's ever come out before. And like they call it permissionless validator sets in Quicksilver, so like recommended research. So the security in Cosmos, I have no doubt it'll impact in any way. I know there are some people in Cosmos like Sunny that think a bit differently about it. And also with superfluid staking, of course, is another great thing in Cosmos. You can't really do it in other ecosystems, which has its own sort of trade-offs, I guess. But I do think in general, what we hope at Chorus at least, I believe, is we hope that many new networks launching and also networks that already exist will try and move to this liquid staking asset because it's integrating it into different sort of applications, etc. Because that on the back end is staked. You're not like you get liquidity, of course, with Quicksilver, for example, but it's also staked. So it just makes the whole user experience much better. And in our opinion, at Chorus at least, it also secures the network in a way because like people aren't going to take it in and out, withdraw it, like redelegate. It's just secure with a validator set that has been, I guess, chosen in a way by the delegators themselves and community of Quicksilver. So yeah, I think it's going to be really interesting. I can't personally forecast exactly what it'll look like, but what I am sure of in Cosmos is that like Quicksilver is a really elegant solution to the security of liquid staking, and it'll be, in my opinion, more enhanced than Lido is right now.
I just want to add to that I think, what we've seen from Ethereum and other examples of liquid staking now is that it's an inevitability. The market is going to push for it because it's more efficient, because it has all sorts of other benefits. And so in any chain now, including the Cosmos ecosystem, I think we have to kind of accept the inevitability of it and therefore design ways to make it as secure as possible and combat any negative effects it might have. For example, making sure that governance rights and other things can still be attached to it and that you have a decentralized set. But I don't think there's any future anymore where you can imagine trying to stop it happening, because it's going to happen through whatever mechanism, because it's just so much, there are so many benefits attached. I think that's probably all we've got time for. It's now lunch, which is going to be served downstairs. And when we come back, there'll be some more talks here. One of the talks, which was going to be on the side stage earlier, is going to be here now, which isn't in the original schedule. So we'll probably resume slightly earlier than we would have done after lunch at maybe time to be confirmed, 12:45 or 1 o'clock, back here.
That on? Oh, just quickly, the lunch is actually in this room, not downstairs. Oh yeah, and there's a lot of merch around. I'm actually rocking the ZKV socks, which are pretty cool. There are 2 styles, so check them out.
Thanks a lot.
Hello? Good afternoon. We hope you enjoy your lunch. And we are about to start the next round of talks. The first one is from Fraser Edwards from Checked. So let's come on in. Yep.
Hi. I'm Fraser from Checked, and we created the Trusted Data Economy. And the title of this is Zero Personal Knowledge Ledgers. So did a bit of a riff on kind of the title of like today, but with a focus on how not everything needs to be on Ledger. You can do things off. And actually to, I think it was Anoma's point earlier, there's a lot of benefits from a privacy angle. So this is us. So probably key people to call out from here, like myself and Anke, used to work together at Accenture. I actually led a project here with the Dutch government doing digital passports using SSI. And then Alex also has studied here and did loads of SSI with the Dutch government. So what we'll be covering really quickly. So SSI or decentralized ID, they're kind of used interchangeably. Some people hate one term, some people hate another. They're fine. But kind of focusing on what does it look like, and then kind of how is it different to other privacy projects, which may have been talked about today, and then get into kind of maybe what we're building, and then hopefully a Q&A if we've got time. Originally this was scheduled for 30 minutes, so we'll see if I can rattle through a bit quicker. So easiest way of saying SSI/DID is just, not your keys, not your data. Sorry, not your keys, not your coins for data. When we kind of came into the Web3 crypto space, we kind of assumed that everyone would know what SSI, decentralized ID, is. We pretty much just found tumbleweed. No one knew at all. Despite everyone having this really big focus on anonymity or pseudonymity, and generally on having ownership of whatever you're dealing with. And this is kind of shifting kind of how data is used at the moment to how we argue it should be used. And really the big difference is instead of centralizing around organizations or companies, you're centralizing around the individual. So even though you've got the term decentralized ID, really it's centralized around the user. So following that whole design principle of user-centric design, that's basically what this is. But the best way of really describing it is to go through some use cases of how this could potentially work and what we'll be building. And cool. So everyone probably in this room has been hit by a scammer at some point, or been contacted maybe by a fake exchange, maybe by a fake BD rep, or maybe even someone pretending to be a team member just to try and get keys off you. And one of the things that we'll be end up working with partners in the coming kind of weeks and months is actually skipping past this whole NFTs for identity thing and issuing credentials out so they can prove who people can prove who they are. But very much not building this around one central entity and not necessarily doing KYC. So this doesn't need you to register with a passport. It doesn't need you to kind of go through the an onboarding process. All it needs is someone with a reputation, whoever that is, to basically attest to who you are. So for us as a company, the fact that we've been through Outlier Ventures Basecamp is a good tick in our box. The fact that we invested in by Ignite is another thing we can point to and we can prove. And we can build up kind of reputation for both the company and the individuals who work for it without needing a centralized kind of orchestrator of all of this, like a LinkedIn. And the upshot of this is basically anyone can start proving who they are to each other without a central authority. But also, as we kind of get onto later on, without having to write anything on chain. All of this stuff takes place above the top of the ledger, with really only the core capabilities on the bottom. Probably a cooler example though is actually making gaming kind of portable. So this is the ability to purchase avatars, shift them, shift experience, shift reputation, and basically bring those between games or ecosystems or metaverses. So this could be we've kind of blogged about this a while ago, but this could be something as daft as the Charizard that you grew up with and created across Pokemon Red all the way through to the latest games and raised. Suddenly you can take into Super Smash Bros. And it has a unique character set, but it's also something you've created and had a relationship with for years. it also extends to like being able to prove avatars match the real life kind of person if necessary. Like obviously a lot of people online want anonymity, but we're also starting to see people where they are a public name, like they're well known, they have a profile, and they're going to start presenting in the metaverse, and they need to prove it's them who is doing it. So a great example is like some CEOs or like bands, blah, 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 are starting to do addresses in like metaverses. And they need to prove that it's them, and it's not a deep fake and not someone faking their voice. And so there's kind of wrapping all this up again and providing like proof that an individual is who they say they are and have that ability. And this is kind of, we published this before the EU kind of position paper came out recently. But this is looking at like if you were to start adding on privacy preserving kind of reputation or kind of KYC onto DeFi. And we know that there's people like T-Grade and others that are kind of looking at this as well. But what this effectively allows for is like you can register, get KYC'd, and we've basically got this idea where someone can spin up a pool, they can set kind of entry criteria for that pool, and they don't need to record really anything about the individual. All they need to know is that they have passed certain criteria. So in this kind of scenario, you'd be able to have someone create a pool that excludes the US entirely, so they know that they would never need to worry about kind of the SEC coming after them. They may be able to set a policy where you have to prove you're over 18. You don't need to give your date of birth, like your address, your name, anything, but all they need to know is that you are over the age of 18, which you can kind of prove with a mix of like SSI, which we'll be building out, and also zero knowledge proofs, which have been spoken about as well. Oh. So if I go kind of just wrap these up, like these were just a few examples of the kind of stuff that we'll be building. But the kind of the bigger impact of this is like SSI across just everything. So one of the best impacts that this is probably going to have is it should just get rid of passwords. Like if you can authenticate to a strong level using data that you hold and do it in a privacy preserving manner, you can effectively eliminate passwords out. And we're starting to see like some of the bigger companies, so Avast Antivirus bought like an SSI company recently. The company they bought, Nym, one of our investors, and they're looking at like how they might build that into their wallet. And kind of that's very much like off in the future, but like they've got such a scale that if they go after this, they could just eliminate like passwords entirely. And that also makes it like single sign-on. So I imagine, again, most of the people in this room have had to create like a huge number of accounts for various stuff recently. I'm finding that whenever I go to buy anything, even if it's once, I'm having to create a full account now, which is pissing me off no end. And it'll kind of basically get rid of that as well. Like if you can immediately register, transact without having to enter all of your personal details, like the user experience is going to be so transformative. And I think one of the current frustrations I had was I had the KTDI demo on my phone. Obviously don't anymore, having left the project, but like I've seen what this can look like, and it's so slick. Like it's very hard to kind of go back to the current world where like things are clunky, you're entering your details all the time, where you've not had to before. So this is where we get into the meat of it, and like how this is different to some of the other like privacy and kind of portability projects that you'll see. So this is where we're kind of contrasting against like maybe the likes of Secret Network, and kind of when I can't remember who it was who was speaking about like tumblers, that kind of stuff, and how this is a bit different. So yeah, this is the main kind of thing. So personal data does not hit the ledger. So there are various different ways of implementing SSI, but one of the kind of primary aims that we go for is personal data just shouldn't be on the ledger, and it really doesn't need to be either. So the whole point of this basically is if you're putting data on the ledger, as someone spoke about earlier, it's correlatable. Like you can start unpicking like who's writing when, even if you can't necessarily read the data, you can start tracking people across the network. And if you can start kind of breaking the encryption, if that does happen, you suddenly just expose a load of personal data that really didn't need to be there in the first place. So that's where we get onto like what's called in SSI, the trust triangle. And basically what this is doing is using decentralized PKI, which I won't go into too much detail on, but like basically keys on ledger, so that when data's issued and data's received, like you can actually verify that data without any of it needing to be written to the ledger at all. So literally across this, you've got like someone issuing data to an individual, that individual shares that data on, the data was originally signed by someone, and then the kind of person who receives that can go back and check that the signature on that data matches who issued it. They can check kind of the reputation of who issued it, but they can also check that all of that data was kind of encapsulated, encrypted, and hasn't been tampered with as well. And again, all of this without hitting the ledger at all. And this is just in case anyone wondered what kind of a DID on the left-hand side, left-hand side of this was. It's basically a decentralized identifier. And kind of there's a really technical kind of jargony thing on the left-hand side. But a much easier way of thinking about it is like a car registration plate. All it does is uniquely identifies the car and tells you who owns it if you eventually trace it up. But the key thing is, like, these are typically, the ones on Ledger are typically companies or organizations. They don't need to be kind of individuals, and they shouldn't be individuals. Like, there's no kind of need for that at all. And there's some pretty major benefits to this approach. One of the biggest things is much higher system throughput. So I think someone spoke earlier about like you can like horizontally and vertically scale networks, and the beauty of this is because we're putting less on Ledger. Actually, when we do scale vertically and horizontally, we get much more out of it because there's so much less on there in the first place. The other part when we're kind of looking at stuff like IBC is we get a lot easier interop with other networks, even outside the Cosmos ecosystem. And that's because kind of the primitives on the ledger are so kind of much more simple than other networks, say, that you can actually replicate them across ledgers. And because all the data is also moving across ledger, as long as each one is contactable, you can start routing stuff kind of across ledgers. That's one of the kind of core aims of SSI is across the entire stack, having interoperability, so you're not locked into one provider. We're not just creating like a different data silo to a Facebook or a Google. And probably the final bit is like the really key bit, which is extremely privacy preserving. So like with no personal data on the ledger, like there are so fewer attack vectors for this. Like you can't watch like signing events on the ledger because there aren't any with regards to personal data. You can't look at the two parties involved because that's not there. Like suddenly you're really restricted into like, you've got to literally be either one of the companies or the individual involved in that transaction or speaking to them directly to get anything out of them. And that's one of the really, really big focuses of like the SSI ecosystem as a whole, like is eliminating privacy leakage. Like it's very much come from a like privacy focus, like we want to get as far away from the Facebooks, the Googles of the world, and very much back into like giving people back that control and giving people back their data. And to focus on that kind of that last point again, so drilling in even further, like even though the data is going off ledger, like you can still combine this tech with stuff like ZKVs, so zero knowledge proofs. So even when the data's off ledger, you can still restrict the data even further and make it kind of much more privacy preserving. So like a really good example for this, and there are many where this tech, I kind of gave one in the DeFi side, like makes sense. But for example, like loads of people will have bought booze or cigarettes at some point and used their driving license or passport to kind of justify their age, especially when people are going into nightclubs. Like obviously you used to just flash an ID card, they barely pay attention to it and you'd walk in. But now there's a much more focus on like people scanning them, they're checking them against databases and all that kind of stuff. And if you think about it, all they really need to know is, are you over the age of 18? Like that's it. They literally need to know that the ID matches your face and you're over 18. And that's where this can get to. Like, not only can you have the data routing off ledger and no privacy, blah, 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 you can also restrict what's being shared. So you can really drive it down to just 2 pieces of data and not even kind of your date of birth. So the creepy guy who's like the bouncer on the door of the club doesn't need to know anything about you. All he needs to know is that you're allowed in. So then in the final kind of bit, I'll just move on to like what we're building and how it fits with kind of everything we've gone before. So basically, like myself, Anchor, and the rest of the team have been involved in like various projects in SSI across like the last 4 years. Like we built some pretty cool stuff with like a couple of governments, like National Health Service and a few others. So But the same thing kept on happening. Like, everyone loves the paradigm, like everyone loves the like privacy preserving side of stuff. But the thing that was really holding it back was like making money. Like, if you're going to take data out of like a centralized silo that people monetize, you have to replace it with something. Like, you have to give some revenue that kind of covers it off. So what we'd repeatedly hear is like, oh, this is really cool. The user experience is amazing. How does this commercially work? Like, how does this replace advertising revenue? How does this replace like the service fees that I get? So we're focused on like building a clear incentive model for the entire SSI ecosystem. So the example here is KYC. But what we're effectively doing is like when that data is issued and whenever it's used, there's going to be like a monetary value that's transferred. And all of that is like it's blinded, like no one involved like outside of the ecosystem can see, no one outside of the transaction can see. But what it does mean is that whenever that credential is reused, the person who issued it in the first place gets paid, or the individual gets paid. So an example might be if you use your passport, you can kind of get paid back for this. But the key thing here is really, it just incentivizes the entire ecosystems. And our theory is basically that by kind of incentivizing these ecosystems, you can start pulling all of this together and start interconnecting them so data moves across. And really for us, the massive upshot for this is there are hundreds of thousands of these ecosystems. And yeah, so it was the right slide. So, and this is maybe where we're slightly different to other projects as well. So rather than trying to build like a vertical stack, like we are focused purely on the network layer. And what that means is instead of trying to build like up into wallets, up into like specific use cases, what we're actually doing is working with like 30 or 40 of the SSI partners around the world to build on top of the network. They already have clients, they already have use cases built out, so we just need to make them more successful at what they're doing and then help them branch out into new markets. So I think originally it was time for more questions, but I just got the like, we're running short on time from Agnieszka. So I think we start, and then at the point where I get tackled off stage is the point where we stop. I've got 1 minute. So yeah, if there are any questions, more than happy to answer. If not, that gets us back on time, I think.
It doesn't work. Oh, no, it works. Okay, so did you also look at, you could also like monetize your own data with this? Is that also something you're looking at?
Yeah. So if I go back really quickly, you'll notice like there's a flow back to the issuer, but there's also flows to the holder. So like we know that there are lots of companies focusing on like monetizing individuals' data. There's been loads of experiments with this, and typically you don't make that much money. Like it's 50 quid for literally everything about you. It's not a lot. At the same time, like there are definitely benefits to it. One of the best examples we could see is like in e-commerce, like there's loads of fraud, tons of it, and it's all basically credit card fraud. And one of the things here is that like there are loads of cashback sites where you get click-through revenue for going through ads, like Top Cashback and similar ones. And you could basically do the same thing where if you do like, you can use SSI to do like a one-click kind of checkout experience. And at that point, it's probably worth rewarding someone for one, dropping your fraud rates, as well as like simplifying and having less fallout in the checkout process. So like, it's probably marginal, but it's still definitely worth doing. I think we're kind of not like going headlong into it, so it's something we'll enable. And probably the thing that I should have said is like, we're not dictating. The way we're going to build this all out is effectively provide tooling across the ecosystem. So we'll just build the tooling and then let the ecosystems and the industries and the clients figure it out. So we're not going to specify, but what you've described really could quite easily come around by someone just deciding to go and build it on top of the rails. Great question, by the way.
Thank you very much. Thank you, Fraser. Just a quick reminder that we also have a side stage. So in 1 minute, there's going to be a talk from Xavier from Chorus One, and I know some of you expressed an interest in it. So if you want to leave now to go to the side stage, that's the time. Thank you. And next one on the stage is Max Hampshire. So here you go.
Where's the, there it is, brilliant. Thank you. Hi everyone. Oh, bit sensitive that. There we go. So hi, I'm Max. I'm the Developer Relations Officer for Nym. And what I'm going to be talking about today are anonymous credentials on the blockchain. So I'm going to be talking about our Coconut credentialing system and our Nix smart contract platform. Now, if people have heard about Nym before, then most of our communications recently have been very much focused on our mixnet. So I am going to go over that in this talk as well, and then I will talk about the credentials and the blockchain very much kind of in context of excuse me, what they do to actually support this mixnet, as well as the kind of fun application level stuff that you can build on top of it. So, what's our mixnet? The mixnet is a multi-purpose mixnet. Basically, it provides network level anonymity for any kind of network communications. And the way that we built it, it prevents traffic analysis by adversaries like the NSA, which is something that existing privacy solutions such as Tor are maybe a little bit weaker against. I'm also going to talk about, like I said, Coconut. Coconut, on the surface of it, basically just allows third-party apps to anonymize any arbitrary key value pairs. So quite similar to what was just discussed with SSIs, we can basically have stuff like users dictating whether they actually reveal part or all of a credential that allows them to do something. And then finally, I'm going to talk about Nix, which is our blockchain. And basically, Nix is our Cosmos chain that we've been using to host our CosmWasm smart contracts that have been keeping track of both the Nym token as well as looking at the rewarding system of our mixnet over the past year, the testnets we've iterated through, and now the mainnet that we launched last night. Before I jump into those, I think I'll talk about the justification for why Nym actually exists. And it comes from this basic premise that the internet, as we currently have it, is broken. The internet wasn't made with privacy in mind. We've had privacy features kind of bolted on in a relatively ad hoc way over the last couple of decades. But none of these solutions can basically defend against the kind of global passive adversary that stuff like the Snowden leaks showed were monitoring the internet. Metadata is leaking, even if you're using something like Signal or a private, privacy-preserving cryptocurrencies like Zcash, you're still leaking metadata as to, when you're sending transactions, what your IP address is, and all of this can be used to de-anonymize you. VPNs and DVPNs essentially move the necessity of trust from you to them, and like I said, even Tor can't actually defend against adversaries that can monitor the inputs and outputs of the entire network. However, Tor and Signal and the increasing popularity of them since Snowden basically shows that there is actually a massive demand for privacy. But both Tor and Signal, and this has become really apparent during COVID, really relied on a lot of public donations. That kind of has dropped off in the last couple of years, when really that kind of funding should have been scaling. So our solution is the first of its kind in that it's the first incentivized mixnet that we know of. Other mixnets have existed, MixMinion being probably the most famous of them, probably the one that Satoshi, whoever they or the multiples of they were using to send emails into the mailing list that we all know and love. And the mixnet, like I've said, I'll skip that. The first network component. So how does the mixnet actually provide this metadata protection and data anonymity? Much like Tor, when you route traffic through the mixnet, it's multiply encrypted and it goes through multiple hops. What this does is it unlinks the origin of the message and the destination. Each of the mix nodes, as well as the clients that are communicating with the Nym network, however, also push cover traffic, right? So dummy traffic into the mixnet and are constantly passing it between them. One thing I should also note, when your data leaves a Nym client, it's encrypted in the Sphinx packet format. So it's the same packet format that Lightning uses. And it's chopped up into identically sized packets as well. So now, if we're looking at the traffic, what we actually see are identically sized, identically encrypted packets that are also hidden in the crowd of kind of dummy traffic that's being sent around. So you can already see, just from these steps, something like traffic analysis attacks become almost impossible to perform. On top of that, as data moves through the mixnet, there's a variable timing delay that each packet that is applied to each packet before it makes one of these hops. Again, as soon as you have now a crowd of identically sized, identically encrypted packets, all of which may or may not actually be being fired in order, stuff like traffic analysis attacks becomes almost impossible. And the scalability of the mixnet is something that has become very important and is also something that the incentivization that we have with the Nym token, which is the utility token kind of powering the network, allows for. So Tor, at the moment, has about 6,000 nodes. It's had 6,000 nodes for a while, and it will probably have 5,000 or 6,000 nodes for quite a long time. However, you don't always need that many nodes mixing traffic, depending on how much demand there actually is for the network. So we're actually able to scale and shrink, more importantly, the network as required. And here is a kind of a high-level comparison of the kind of network stuff that you can see if you're able to observe from a user to a service or a user to a user with these different networks. So with a VPN, you can still see traffic coming out. There's no timing delays. There's no, the size of packets can also give a lot away about what that data might actually be referring to, and then used to de-anonymize you. Similarly with Tor, packets can also be de-anonymized like this. Whereas with Nym, if you're actually able to observe the network, all you're seeing is identically sized, identically encrypted packets flying around. There's not that much you can start to infer from what the relationships between the user and a service or a user and a user might be. And yeah, this is just a slightly more detailed explanation there. So now the mixnets, now I've kind of gone over the mixnet, let's dig into the maybe more Cosmos related side of this. And this is also stuff that we haven't really been talking about too much publicly yet, so I'm excited to share it all with you. So what are coconut credentials? It's basically our cryptographic signature scheme that produces privacy-enhanced credentials. And users basically will pay Nym tokens to our validator set to create these credentials for them. The kind of conceptual change that we think is really, really important to highlight with this is it shifts the question of authentication with the credential. And by credential, you could also think of something as simple as like a JavaScript web token, as a contrast maybe. Instead of asking who a user is, when you want to log into GitHub, it wants to know that you're you. With a coconut credential, it shifts that question to, does this person who actually has this credential have the right to take the action they're asking? Does this person have the right to log into this GitHub account, this email address, take part in this KYC? The way that credentials are actually created, so they're blind signed. And what that means is that if I approach our validators, I ask them to create a credential for me. Instead of saying, hi, I'm Max, could you make me a credential that would allow me to log into GitHub? What I would actually provide them with is a zero-knowledge proof that I am actually able to take this action, so they don't know what it is that they're signing. So even the validators are not actually able to start de-anonymizing the people who are asking them to make the credentials for them. They're also re-randomizable. And what this means is that if I produced a credential for someone that, for instance, had the same identifier, if that was used over a period of time, you might be able to start to de-anonymize the person who was using it because again, it's leaking metadata. Maybe you can see what time they're always using this credential or what IP address it's coming from, something like this. Re-randomizability means that you can reuse the same credential, but the people who you're presenting it to are never able to make a link between the first or 50th time you might actually be presenting the same credential to them. The The actual generation of these credentials as well is split between our validator set. So each one of them will only be producing a fraction of a single credential that they're blind signing. That's also re-randomizable. So again, as these characteristics pile up, you can see that we're really starting to break a lot of the potential for de-anonymization with their use. And yeah, like I said before, they're selective disclosure credentials. The example that came up before with checked, with if you're having to prove that you're over 18, then yeah, all you have to do is prove that you're over 18. You don't actually have to say how old you are, nor do you have to show, where your ID is from or anything else about you. And the final thing I want to highlight about them is that they're ultimately it's a very generic credentialing scheme. And what I mean by that is that even though they originate from our validator set, they can actually be used for essentially any application that require a login, an authentication, or some kind of proof. So I've been using the example of logging into GitHub, but you could also think of proving that you've paid for a VPN service as a way of logging in, as opposed to providing your credit card details, your password, your username, or anything else that requires a proof. The current status of our Coconut credentials are we have implementations in both Go and Rust. These implementations are interoperable between each other. We are currently working on modularizing this code and turning it into a Cosmos module, which means that all Cosmos SDK chains can utilize it. But the code is in a usable state right now. It just will become a lot easier to integrate in the immediate future. That said, if you do want to start getting, go ahead building with it, reach out to me, and I can talk about how that might be made possible for you. I've touched upon a few use cases when I've been quickly going over what the different aspects of credentials kind of allow you to do with them. But some of the important ones that I want to highlight are, obviously, over the past 2 years, there has been an increased amount of surveillance just because of needing to constantly present either vaccine passports and there has also been a lot more kind of scrutiny, crossing borders, going into places, all of this. So we actually built a proof of concept of using Coconut credentials to create a privacy-preserving COVID passport, which basically, instead of me showing a COVID passport that, as well as my vaccination status, would say, who I am, where I'm from, all of this, all it does is it shows that this person actually has the right to cross these borders because they are operating within accordance to, for instance, like Schengen COVID travel laws, right? But you could use a Coconut credential as a replacement for essentially any kind of DID or ID system. Privacy-preserving KYC, also another example that came up in the previous talk. This is something that a lot of people who are both people who are developing applications wanting to actually have KYCs is creating a lot of overhead for them to have to, for instance, make sure that they don't distribute anything to Americans or airdrop anything to people from certain jurisdictions. You can basically then instead run your KYC through a process of people have to present these credentials that someone else has showed that they don't fall foul of any of the rules that you're not allowed to do. But you can apply this to currencies, data access, both like database access, but anything else, voting, all of this. One of the things that is a little bit further in the future, but I think something that could then actually be incredible for the ecosystem, to bring it back to Cosmos in general, is that we are a Cosmos SDK chain, we are IBC enabled, but we need to work out how to tackle passing Coconut credentials between IBC enabled chains, how you could maybe generate one from the osmosis side, all of this. And within Cosmos, this is just to kind of aid interoperability within the ecosystem and kind of boost everyone up. But when you're looking at chains like Ethereum, the actual crypto that goes on underneath the creation and the use of Coconut credentials is unrealistically expensive to run. I believe someone in our team, out of interest, did try and do Coconut credential generation on Ethereum, and it's over the block gas limit, so kind of impossible to use at that point. And once we've kind of done that, we could start getting Coconut everywhere else. So maybe we could get Coconut bridges on the horizon. That then leads me into the third kind of main network component that Nym has, and that's our Nix blockchain. The reason that we called it Nix was because the MixNet network is called Nym. The blockchain was kind of becoming increasingly prevalent, and we wanted to just disintermediate the two and make it a little bit less confusing. Also, Nix is one of the names for the Greek deity of night, and it's just cool. So what is Nix? Nix is a fairly standard Cosmos SDK chain, IBC enabled, and we also have the ability to upload and host CosmWasm smart contracts on there. And the reason that we've maybe been a little bit quiet about that up until recently is that a CosmWasm smart contract has actually been the thing that's been keeping track of thousands, and by thousands, I think our previous testnet had over 6,000 mix nodes. So thousands of mix nodes, gateways, stake delegators, all of the currency rewarding system, and everything that went on between those people. And we've been kind of keeping this quite low-key just to see how it would work, but it's worked flawlessly through all of these mix nets. So it has a, it's scalable and has a massive throughput, and is also incredibly reliable. The reason that we're also presenting Nix like this now is that we've decided to allow anyone to actually upload smart contracts and use Coconut on our chain. So we've basically decided to make Nix a kind of an open smart contracting platform that people can then join the Nym ecosystem on the application level with CosmWasm smart contracts if they want to build like that. So why? Why would you use Nix? One of the earliest talks today was, talking about really discussing like the plurality of chains that we have in the Cosmos ecosystem, the ability to even kind of upload apps and then rely on the validator sets of the main Cosmos hub. So with all of this possibility there, why would you decide to host your application on Nix? The first reason is the network security. We have a very, very good validator set. We have very strong network incentives for the investors behind Nym to keep this chain running and keep it secure. The second reason is that even though I've kind of just talked about our plans to modularize and maybe bridge Coconut, it is going to be debuted on Nix. All the new features will be rolling out there. And so anyone who's really keen to kind of start immediately accessing it it's a good place to be for that. And finally, the kind of privacy community that we want to start building. Nix is the home of the smart contracts running the MixNet, and privacy-preserving apps will be in good company there. They'll also be able to utilize having Nym as a base currency if they want to use that as well, and just take advantage of the general network effects of being part of the Nym ecosystem. And like I said at the beginning, I'm the DevRel officer. So for developers, Nym has basically taken a shift now. We launched mainnet yesterday, as I've said. So now we've been really focused on infrastructure for the past year or so. Now we want to get people building. We want to get people using these applications. Our grant program is going to be rolling out soon. So if building on Nym sounds interesting to you, keep your eyes peeled for that. Also get in touch with me. Oh, and yeah, finish my last point as well. Get in touch. So I'm Max at nymtech.net. I'll be around. I'm also in our Keybase and Discord. So reach out.
Thank you very much, Max. Do we have any questions? I actually don't see. Oh, yeah, the box.
Oh, it does. Yes, it does. Hey, thanks a lot for the presentation and the work that you guys have been up to. So I actually have a question with regards to the credential scheme, you've already mentioned that verification on Ethereum is pretty expensive. I wonder how does the proof generation looks like in terms of efficiency and how practical it is to generate those proofs on constrained mobile devices, etc.
So on mobile devices, well, our the proof of concept that we did for the COVID passport, that was actually building everything on a phone. So very little latency is all I say. It's very usable, even at this kind of like POC level. If you're doing this in a desktop setting, then you shouldn't really notice too much lag with the actual, the initial ZK proof that you're using to facilitate the blind signing when you actually ask the validator set to create this credential for you. There's very little latency there.
Cool, thanks.
I think it's actually time. I want to say congrats. You just launched yesterday.
Yeah, thanks.
Congrats, Nym.
Apologies for being slightly frazzled because of that.
No problem.
Yeah.
All right, next up, we have a bridge panel. So I want to invite the panelists to the stage. Oh, really? I don't know. I haven't done one of these on stage in a long time. Nice. Oh, you brought your bag on stage too, cool. All right, so this is the bridging panel. Obviously, bridging is a massive topic at the moment. I'm currently on the podcast actually doing a series on bridges. I've had Deborah and Sergey on so far, although your episode comes out, I think, in a week and a half or something. But yeah, I think to start off, let's introduce ourselves. And I know, Chris, for this particular panel, I'm going to ask you a lot of IBC questions, even though you're actually now at Anoma. So why don't we start with you, Deborah?
Yes. Hey, thank you so much for having me here. And I'm really honored to be amongst so many amazing builders. And also thank you, ZKValidator, for putting on the conference. It's been great. My name is Deborah St-Pierre. I am the CEO and co-founder of Althea, which is a decentralized routing and meter billing platform for distributed or multi-entity broadband networks, which sort of led us to needing a bridge between stable coins in the Ethereum and EVN ecosystems and Cosmos. So Althea is also the kind of driving force and team behind Gravity Bridge. So Gravity Bridge is a neutral, decentralized bridge that's purpose-built to support the Cosmos ecosystems, blockchains, DEXs, and projects.
Very cool.
I'm Christopher. I currently work as co-founder of Anoma, which is a occasionally ill-defined, very large set of protocols for coordination, privacy-preserving bartering, privacy-preserving transactions, and a whole lot of other things. I worked previously as architect of the IBC protocol, and I must say, I grew up in Oregon. I had shitty internet. I've never met you in person, and thank you for solving a real problem.
Nice.
Hey, everyone. Great to be here, and thanks for the invite. So I'm Sergey. I'm a co-founder of Axelar. My background, distributed systems, cryptography. Spent a lot of time kind of designing various protocols, standardization of standards like BLS signatures and so on and so forth. And sometime as a faculty at the University of Waterloo, and now we're working on a secure transport layer for Web3 with Axelar.
Very cool. Chris, I actually want to, as you were doing your intro, I had this question that came up. So you work at Anoma, like now, you're now co-founder of Anoma. Is Anoma in any way an interoperability project? Do you think of it that way? Is it a bridge in a way?
I guess I'm not convinced that interoperability will be a separate component of projects.
Okay.
Writ large. That's how I would answer that question.
That's very...
But certainly we want to use and contribute to standards such as IBC.
Very cool. All right, so I think to start off, I think actually this speaks to this idea of bridge philosophies. Let's maybe start there. Each of you, I mean, IBC, Gravity Bridge, Axelar, have different philosophies potentially. So I'd like to explore what those are. Kind of what are you setting out to do specifically with each of these I'm going to say bridges for now. I know we have different ideas on what the name of these things are, interoperability zones or something like that, but let's just use bridges, or bridge technology. But yeah, what's the philosophy of Gravity Bridge?
Oh, good question. And
what's the goal, I guess?
Right, and first of all, I'd like to also share that my co-founder and CTO Justin Kilpatrick really did a lot of the design and did the technical lift of the bridge. So I'm here representing sort of the business aspects of it, and I hope that folks will find that kind of interesting as well. So when we looked at designing the Gravity Bridge, we wanted something that was going to be simple. It was going to be reliable and secure because we were looking at our end users, which are other Cosmos blockchains, DEXs, and other infrastructure in Cosmos. So with that in mind, we sort of looked at basically. Let me kind of back up a little bit here. So basically, looking at the user case of other blockchains, you don't really want to think about your bridge, right? I don't want to have to think about whether it's operating. So we wanted to make something that, number one, other blockchains didn't have to think about, was always going to work, was very practical, was gas efficient for their end users as well. In fact, with Gravity Bridge and the batching technology, we're able to get sends as cheap as 1/8 of a cost of a normal ERC20 transaction. And we wanted it to be able to be simple enough that we didn't have to have an upgradable contract from the Gravity .sol or the Ethereum contract, so that makes it very secure, but expandable in that functionality. So we spent a lot of time really getting those fundamentals right. It's not a lot of bells and whistles and flashy things, but it just works and you don't have to think about it.
Cool. And one thing about it is, it's primarily focused on connecting Ethereum to IBC, right? That, it's sort of this one to many, many to one, would you say? Is that the primary goal of it?
Yeah, I think, we want to do, EVMs, right? We want to do things well, right? And then iterate on that process. I think, to Chris's point earlier about, maybe interoperability is part of the innate future. I think that may be the case, but for now, we're at, we're at a situation where we want to do things, get that user adoption. It really is focused on what works now and what's needed now.
Cool. Okay, IBC. If you're going to put on the IBC hat for a moment, what is the philosophy of IBC? What does it do? What's the goal? What's the goal of it? I mean, I think most people here know, but...
Sure. I mean, I would relate the philosophy of IBC to, at least for me, the philosophy of decentralized infrastructure in general, which is to allow those who are using a system to also control it. Of course, those mechanisms aren't perfect. I don't think we've succeeded yet. Validators and the users of a blockchain are pretty separate groups. But maybe we've made it closer than, one party in the Fed bank far away, right? So we want to bridge those gaps. And while bridging those gaps, we also, communities want to interoperate. As they control their own infrastructure, they also want to interact with other communities while in some ways, perhaps limiting the way that they do so, if interactions, that they might have with other communities could lead to harm back to their community in the future. So IBC is unopinionated about the content of those interactions, but it tries to provide a framework to allow the choice of how to interact with other communities to be deferred to the user.
And that's the thing, is it's a framework, it's a standard. It's not a zone of its own.
IBC is not a token. It's completely non-competitive. It's not, you don't have to do anything or buy anything or be anybody or talk to anybody or adhere to any, it's just a standard people can use. It's a language.
It's a language, it's a glue between the zones. So this is just sort of nice to start to see those comparisons. Okay, let's talk Axelar philosophy.
Yeah, it's been pretty simple from day one. It was to allow any user to use any asset on any chain. All right. So, and I think to get there, you have to realize, you need to have three core properties. I think one, you have to have decentralized and secure architectures that scale, right, and support decentralized protocols at the bottom. Two, you have to think about, how do I enable what I call as one-click experiences for the users, right? It's I click, my transaction goes, it arrives in application, it's executed. I don't have to think about bridging protocols or anything like that. And I think a third one is scalability, right? I think our goal from day one has been to build a secure kind of transport layer for Web3, and that includes being able to connect millions of chains and thinking about what is the architecture that's going to look like. Is it a combination of IBC, maybe other things? How do we get there? And two, being able to do arbitrary, information exchange. So not just token transfers, being able to send messages, being able to exchange, NFTs and so on and so forth. And so I think those three core properties, security, one-click experiences, and arbitrary scaling is what we're focused on.
I feel like with a lot of the bridge projects, I mean, one question that people may have is like, we have IBC. Why not just encourage everyone to have this as the standard? Are there reasons that you're thinking about maybe where this either doesn't work, I mean, I have a few ideas on that, or that you don't even want that to be the model of the future? You wouldn't want every network glued, kind of connected to every network, but rather have some sort of hub.
Yeah, that's another great question. I think IBC has a lot of the idealism that blockchains really strive for, right? That resiliency and decentralization. But I think there could be a potential pitfall here in that we could end up designing app blockchain or a specific blockchain to the need to interact with IBC rather than designing for what's best for that blockchain. And I certainly think what's exciting is we now have a lot of new blockchains sort of coming online and new bridges, and we have a multi-bridge future. That marketplace is probably going to start to inform what our ultimate IBC protocol looks like, right? But I think absent of that sort of competition in that building, we may end up designing a product that doesn't have product market fit.
I mean, so I guess just to step back, I think my first, interaction and thinking about IBC in general were like in 2018, I would say, or maybe early 2019. So we shipped the Algorand blockchain with my co-founder Jorgos, and we're thinking about interoperability protocols, right? And we kind of looked at Cosmos, IBC. I mean, great stuff was built, and we were just thinking, well, how do I adopt this to the Algorand blockchain? And while the model is great, the practical engineering hits you pretty hard in the head pretty soon, and especially for Algorand, I think we'll literally have to rewrite a lot of the consensus pieces just to make it to work. So it was really hard to convince anybody to do this, I would say, and it was really hard to allocate those types of resources and say, well, now we have to change the way we build consensus for the last, it was 4 years from the research until, until we shipped the blockchain. And so that engineering kind of hit us pretty hard in the head. So hard to scale across if you want to innovate on other things. That being said, though, I do want to decouple a little bit, and recently wrote a blog where we try to structure a little bit different layers of interoperability, right? And I think it's important to understand, there is the the transport layer of interoperability, there is a verification layer, and there is a message semantics layer, right? And I think you can take IBC, you could also decouple it in those layers and say, well, who provides the transport? What provides message verification, which are light clients for the purpose of IBC, and what are the packet semantics on top of it, right? What is the format in which we send messages? So while I think the verification pieces are pretty hard to scale, the light client, you could decouple these layers and say, well, message semantics for IBC could be reused across different ecosystems. We can code those on top of other transport layer or verification layers while still being able to talk to one another, right? And so
they're already decoupled.
I know they're decoupled. I think very few people know how to actually work with that decoupling. So and understand that piece. So, but yeah, so I think it's a. So I think it's important, to educate people on the decoupling and what we can do with it to kind of continue making advancements faster.
That leads to a question I just was thinking of, which is would it make sense to build, to not rebuild IBC, but since it's hard for other blockchains to implement it, it's mostly built to work, I guess, with the Cosmos SDK, but could it be rethought to work with other kinds of blockchains, or is that a crazy idea?
I think it's tragic that it hasn't happened yet.
Okay.
I mean, maybe it's worth distinguishing between IBC, the sort of theoretical protocol architecture that has like a spec and abstraction such as light clients, and IBC, the concrete implementation, which is easy and inexpensive in terms of developer time to merge into your blockchain in a few weeks. And the former has a kind of extensibility that the latter doesn't yet have in practice.
Yeah.
So there are great implementations of IBC available in the Cosmos SDK in Go and in Rust, but for other blockchains with other light clients, other signature schemes, even if it's sort of possible in principle to integrate that into the IBC model, if it's not yet cheap enough practically, then yeah, people may not do it. The boundary of IBC is not a fixed thing. So IBC is like just a sort of set of abstractions around interoperability, just as like TCP is a set of abstractions around sending packets. And you can come up with, say, new light client algorithms, which would expose different consensus algorithms to the IBC ecosystem, or you can come up with, I would say like Gravity Bridge, not the instance, but perhaps the protocol could become part of IBC. It doesn't, we can separate here the concern of what should the specific instantiation be now, which is a very pragmatic one, not to devalue it at all, but that has to be made on I think on the terms of like what are the conditions at the moment, who can work on this, who wants to use it, like that has to be made on the basis of practical considerations. Whereas we can also leave the path open for the topology of real commerce on the network, which the security architecture, in order to be secure, has to reflect. We can leave that topology open to future change by building the protocols as a kind of stack, which is independent of the specific like tokens and the specific instantiations.
Yeah, I just 100% agree with that, and I think that the market is really going to drive, how this moves and changes. I also think too that we all still have this fundamental like kind of tooling and node infrastructure issue that sort of is where a lot of these pain points to evolution of both IBC and bridges is kind of hurting right now.
One of my questions was about could bridges become this sort of centralized point of failure? But before I go into that, it's like the IBC world, the way that it was originally presented was very much like this mesh or this net. Is that, now that we're starting to see it in action, are there kind of still hub and spoke kind of entities forming even with IBC? Is it a perfect mesh basically? Or not?
I mean, so yeah, I have a lot of thoughts on this, but I do think you're gonna see hubs, and I think you're gonna see spokes, right? And I think it's sort of fundamental for the blockchain ecosystem, and here's the reason. Whenever you're talking about peer-to-peer connectivity, right? Look at two extremes. Okay, extreme number one, everybody's connected directly to each other. Great extreme. What is the result? The result is in the order of n² connections. Impossible to manage, right? Nobody's going to run so many relayers, nobody's going to maintain these many connections. That cannot work, right? The alternative extreme is that you have, one hub and everybody talks to that hub. Again, what is that hub going to have? 1 million connections? Probably not, right? So you're going to end up in an architecture where, there are some hubs, there are some peer-to-peer connections. How did the internet shape up, right? It's sort of, you're going through multiple hubs. On average, you take in kind of 10 to 20 hubs to send a packet. The challenge with that on the blockchain space is that every time you take an extra hop, you take an extra security assumptions, right? So you're trusting another validator set, maybe you even trusting another protocol, and those continue amplifying and amplifying. And so you end up with pretty much nothing if your packet has to go through 20 security assumptions, and kind of hubs help you minimize the trust assumptions as you're kind of moving the packets from one connection to another.
I think it's kind of interesting, though. I think it's a bit more nuanced on that because many of the validators run the relayer infrastructure, right? So we were talking earlier about interchain security and liquid staking, and then also the sort of problematic centralization of white boxing and white labeling validator sets, right? So perhaps it doesn't really look like a hub and spoke model from the outside, but really we are doing that underneath the hood, right? So I think there's other sort of, perhaps more nuanced and more subtle ways that centralization and aggregation happens across at least the Cosmos ecosystem.
Yeah, I would add to that part of the design of IBC, which hasn't really come into practice yet, is fault tolerance for Byzantine behavior, not in the sense of Byzantine validators, but in the sense of Byzantine chains within the ecosystem. And we haven't seen this yet because we operate in this nice world where we're all friends and we go to conferences and talk to each other. You know, people are irrational, but they're also kind of nice and they don't want to be rude to the guy who they're having drinks with. We're not yet in brutal competition, nor are we in like cases where there are, I mean, most of the usage of blockchains is imaginary financial speculation, let's be honest. We're not in cases where we're dealing with real world power structures who will try to subvert many of these mechanisms for their own specific ends. And I think continuing to design protocols that are tolerant in this way is extremely important, even though we're not going to see that realized for a long time. So, you know, it's not clear if proof of stake will work in the long term, considering like the practical economics of validators and like how delegators make decisions. There are lots of areas in the design space that need to be explored before we can see these things in practice.
I had a question, and I'm blanking a little on what it was. What was it?
While you're thinking that, I can actually continue the conversation. I think that it is interesting that you bring up, you know, hey, we're all friends, we all go to conferences. One of the things that's really interesting to me about Cosmos is like the ecosystems are the same, the validator sets are the same, the communities are the same, you know, we all cross-pollinate a little bit, right? So what sort of happens when we cross-pollinate with our security, right? We start to do that with, you know, liquidity. There was questions about what happens with those derivatives, right? Like, how does that actually affect, you know, I would be curious your thoughts about that in terms of like bridging or interoperable protocols too, because you know, maybe these communities start merging more and more together, right?
Staking derivatives are terrifying. They keep me up at night. I mean, in some sense, it's easy to turn anything into a fungible asset, yet fungibility is also the very property which, like, say, validators are secure only because they are not fungible. Right? If votes are a fungible commodity that you can buy, then you no longer have any kind of guarantee provided by the decentralized.
Well, and I think we're already seeing that with like things like Bribe DAO, and you know that's already coming to the ecosystem where we have to decide what we feel about it. Sorry for derailing.
No problem. Thank you, because it gave me a second to find my question, which had been actually this original idea of the point of failure. Are like bridging zones, so I think IBC wouldn't necessarily fall into this, but like a hub of IBC connections could, or these bridges, or these interoperability entities. Are they, I mean, we have examples of hacks that have happened. Oddly, well, except for the most recent one, I guess, oddly, they either get bailed out or the funds get given back. It's sort of still friendly. But yeah, what about, like, are the bridging areas, are they going to become the points of attack? Are they a point of failure for these larger networks of blockchains?
I mean, yes, is the answer. But, you know, I think in some sense it's like no different than kind of just building in Web3, right, or DeFi. I mean, I always give an example, like, okay, like early DeFi, we saw hacks because people were shipping, you know, crappy code, not auditing it, didn't know how to design things securely, and so on and so forth. And we kind of went through a couple of years of iteration until we see protocols now that, you know, even sometimes they still find, you know, find vulnerabilities. So, you know, interoperability is a new space. So I think we saw a lot of ad hoc solutions being rolled out, which hopefully will get replaced over the coming years. So I do think we can make it, you know, better, and I do think we can make it secure. I mean, that being said, I think also, I mean, we've been exploring some ways you can actually compose security across different protocols, or potentially across different paths, right? So, for instance, you can imagine that, like, I'm a protocol, you know, on Ethereum or in Cosmos, and I actually would check that like 2 paths have verified my traffic, and those are like independent paths, and only then I execute a message, and only then I sort of authorize it. So you could actually do quite interesting things to compose, make security better, remove some of those centralization kind of problems that you talked about. You do have to have very kind of strong engineering on the back end, and you know, rigorous audits and things like that.
Cool.
Yeah, I think a lot of these hacks are somewhat mischaracterized, right? So what's happening here is the trade-off between security and usability and ergonomics, speed, things like that, right? And a lot of the reason why the bridge hacks get paid back is because really those bridges aren't necessarily acting as an interoperable, neutral infrastructure layer. They're really operating, like with Axie, it was, you know, it was an Axie bridge, right? They're operating to serve some other kind of thing. So they make the trade-off for a more efficient centralized design, which then leads to the very problematic design challenges. So I think that's why it's important that that neutrality and the interoperability of that infrastructure layer itself is really important, right? And we don't make those trade-offs in terms of efficiency. And I think as the tooling and efficiency, like with Gravity, right now it's even a profitable and sustainable bridge. We're able to get gas costs down. As these bridges become better, then people will be less likely to make those choices. At least that's what we hope. But I think to a lot of end users, a lot of these security properties are just not disclosed, right? So for them, it just all seems like, well, are all bridges bad?
Yeah.
And in many cases, this isn't even really a decentralized bridge. It's, 3-person multi-sig or something.
Yeah, I mean, I would say growth incentives are dangerous. You can only optimize for one variable at once. If you optimize for growth of your system and sacrifice security trade-offs whenever those decisions come around, then eventually it will fail. It's not. The good news is that, I mean, it's unfortunate battle testing in the sense of, do consumers who are using these systems understand the security models? No. Are they communicated to honestly? No. Are there intensive organizational efforts being put into telling users like how precisely the system could fail and enumerating the ways in a way that's understandable, when doing so would be contrary to the financial interests of the organizations operating the web apps? No. I mean, but at least we're battle testing it, and there is, the question is whether that feedback will translate into kind of a collective consciousness of which sorts of system designs have which properties in operation, or whether it will be sort of warped and never really result in the right bridging protocol, such as IBC, being adopted. Really my bias there. I would say one more thing, and I promise I'll shut up.
Oh, no.
Currently, we get away with bridge designs that are basically content blind. So as in the security of a bridge, we have some formula, we have some decentralized validator set controlling the bridge, and all transactions across that bridge are treated as the same, both in the sense of we don't subject them to different confirmation times or different additional authentication through separate paths, and in the sense that to the user, we don't the wallet doesn't wait for longer. We're not changing the dynamics of what we treat as finalized or secure based on the content. I think that it's nice and it's convenient, but if we look at real-world systems like banks, of course they authenticate transactions based on content. If suddenly I wire everything in my bank account to, somewhere in Southern Africa, my bank will go, "What on earth are you doing?" Of course, finding ways to do this that are also permissionless and preserve privacy is hard. Yeah, it's very hard. But there are users could write their own sort of configuration for what to allow on their account if we move towards a more programmable account model.
Well, and I think in that model, it becomes very interesting, the community governance aspects, right? You have something like what happened with Juno, right? The social consensus, would they be perhaps censoring those transactions? The community saying, no, we don't want this, or no, we do. And maybe that's a good thing, but I do think that it's a bit, it could be optimistic or dystopian.
Yeah, transparent blockchains are a terrible idea. Stop using them. There will be authoritarian governments in the West they're already authoritarian. It's going to get worse. Do you want your financial history now to be visible in 10 years? Are you sure? You can never undo it.
Sorry.
That's about to lead me to the next thing, which is privacy, but go for it.
But yeah, no, just kind of quickly to add, right? I think to your point though, should bridges treat transactions sort of differently and things like that. I don't think, at least my philosophy, bridges should not treat transactions differently, but you can get that security at the application layer at the entrance and exits essentially, right? Because I think if bridges start doing that, I think you're going to lead into pretty bad, kind of complicated designs where you actually have to manage this complicated infrastructure layer, but you can do all of this at the application layer.
Yeah, so we don't have too much time. I want to open up to questions, but first I want to just bring up the topic of today, which is privacy and bridges. It's a topic I feel like I'm kind of constantly trying to put into the conversation, but it's clearly not a bridge topic. Privacy, I don't know of any bridges who are thinking first and foremost about privacy. That's why I was asking if Anoma considers itself sort of a bridge, because if so, you'd be the one that I could point to. But yeah, how do we think about bridging and privacy? Is it always going to be an afterthought?
So I think, no matter how much I love privacy and I spend my time in cryptography, I think privacy always comes after you get some functionality. I think we're in a phase where, we're still kind of setting up these core connectivity pipes and dealing with attack vectors. So, I think that's why people haven't thought about privacy too much yet. I mean, that being said, I think, we talked about it last week, right? And I'm super excited to kind of compose interoperability with privacy-preserving hubs or networks, right? Where you can kind of send packets, do some privacy-preserving operations within it, and take your messages or assets out somewhere else. So I think that would be the first use case where we'll see kind of privacy being composed with other ecosystems, which I think is going to be really powerful.
I like that distinction too, because I think often when we think of bridges, we're thinking about token transfer, so moving tokens from one to another. But when you start to think about bridging messages, then you can actually, you're doing something in the private zone, but it's not just that you're putting tokens in the private zone. That's very different.
You can move some part of computation or state, do some stuff on it, get the result back, and without having to bake into privacy into your layer one from day one. So you can talk to Nym, right, or some other chain to kind of get some of these properties.
And I think one of the challenges always with the bridging idea is that the way we've been thinking about it is you'd have maybe a zone or a chain where you'd have maybe a shielded private part, but in order to actually interact with the bridge, they all of a sudden unshield or decloak, as I've been trying to push in our last episode. Let's put a Star Trek reference in there. But they have to basically reveal themselves before actually moving over the bridge. And this is where the privacy is often lost. And I think this example of using the message passing part of the bridge is kind of a cool thing to think about. I don't know has it been mapped out? Is this something that any of you know research is being done on what that would actually look like? What could it enable?
Privacy on message passing in bridges? Or?
No, it's more like being able to do message passaging into private networks and doing something in there.
We're starting to do this with a couple partners, with Manta Network and a few others. So I think it's early days, but yeah, I think we can map it out.
Yeah, and I know Henry from Penumbra is here somewhere, so I'd like to hear your thoughts on that at some point.
Yeah, I wanted to add one point just earlier on the topic of general privacy and bridges. I think there's an intersection here that isn't discussed very much, which is that privacy has big implications for bridge security. Because many of if you model the attacker of the bridge, they have in order to determine what to attack, how to attack it, they need to be able to glean information about what is going on. And generally, especially, they need to be able to glean information about the content of transactions on the bridge. Is it valuable to go attack this bridge?
Yeah.
Is there a lot of funds there or transactions I could thwart or something like this? And if all the transactions are private, that's much harder. So privacy can have benefit. Of course, it also makes it harder to see, is there something going wrong? Yeah. So there are complex trade-offs. On the second bit, I would say, privacy in a complex distributed system such as the IBC ecosystem taken as a whole is in the sense that how users are using it, interacting with multiple chains, going through multiple chains, privacy is going to be as weak as the weakest link. The weakest link will be bridges if the bridges are always enforcing decloak on one side, cloak on the other. We need private bridges. We need it to be standardized. We at Anoma, let me show one sec, will try to help, and hopefully Anoma, Penumbra, anyone who wants to basically can adopt a kind of IBC shielded transaction standard.
Awesome.
I think I also think this is really fascinating, and I think over the next few years we'll definitely see this evolution. But I think one of the reasons why we haven't seen more progress on this right now is just some of the node infrastructure issues. We have to share so much information right now that the encryption overhead is even higher than you would if we could pare down and we had better tooling in the Cosmos SDK infrastructure. So and this is even between when IBC first started coming out and the failure rate versus where we're at now, I think is a testament to everyone there. But unless we, number one, sort of work on that pain point, and number two, find ways to incentivize working on that pain point, so it makes sense that relayers can run a light enough infrastructure that they're able to make money, and then I think we'll see the privacy follow that. But we have this kind of big, work to do that's kind of boring, and right now isn't well incentivized.
Totally.
That core infrastructure.
All right, I think I want to open the floor to questions if there are some. There we go.
First of all, thanks for the panel. Like, it was really interesting. And I have a few questions. One is about token fungibility. So what is your answer to like importing different versions of the same token depending on which bridge you are using? And another question I have is about bridge monetization. Like, as I guess we are approaching into a multi-bridge ecosystem, then how to guarantee the development and the continuous like management from a technical perspective of bridges, and
That's great.
and then like what is your opinion on Peggy, that is the bridge that Sifchen has been running for 1 year about Ethereum and costs?
So you have 3 questions.
That's it.
First one is fragmentation of liquidity, or like the same. This is just to be clear. It was like if you have multiple versions of the same kind of bridge token on one network. Is that
yeah, exactly. Or? It's like how to avoid to have the Ethereum version of Osmosis against the Ethereum version of another bridge, and so getting into the token fungibility groups and make sure that we are all working with the same version of the token. So let's
start with that one. Sort of this.
Yeah, I think it's a great question. It's interesting because I think, maybe last year or so before, I think there was like sort of the thought that maybe there could be like one bridge would be the standard. And, obviously that's not the future. We have a lot of great bridge teams. And so different assets is the reality. I think, certain like fungibility, Sifchain has actually really led the conversation on that, which is unfortunately not really gotten a lot of traction. But I think there's also some interesting ideas about pooling the assets too, that, with liquid staking or superfluid staking, that could be also somewhat interesting. So, we are going to have to face this reality very soon.
Yeah, I mean, I think fungibility like can be solved. I think if you decouple again like application logic from transport logic, effectively the application logic, you can have things like authorized transactions from like this bridge or like this path, and like only then they can be minted. So I think like you need to decouple. The reason we're dealing with it is because token transfer has been baked into the bridges, which is horrible. So I think you have to like separate logic a little bit and deal with it at the application layer.
Asset fungibility can be solved at the protocol layer. It just hasn't happened yet. You need two-phase commit between the 3 chains involved. Then you can get rid of the diamond problem because all of them agreed that it won't be double spent, and then you can treat them as fungible and it's safe. But it requires consensus protocol changes, and cough, public goods, infrastructure funding, cough. Those don't easily happen because we're all busy launching more tokens on different blockchains. We should all just work in one organization, and it should build one blockchain, and we should be done, and it should work.
One
protocol.
Blockchain to rule them all.
One protocol, many different blockchains, but one protocol or one like integrated set of protocols.
All right, question number 2 is about maintenance and tokens on the bridges themselves.
Yeah, the monetization of bridges in order to make sure that the bridge is sustainable from a funding perspective.
So Gravity Bridge is profitable right now. We really designed that so that the token holders could get any sort of fees that they would through community governance pass in the native tokens that come through. So that makes a really, aligned, I think, way of interoperating with the other blockchains who are core customers. And the relayers relay profitable batched transactions. So you can send transactions instantly, or you can choose to send transactions, when they're batched, and then they're relayed when they're profitable. So right now we're seeing, folks that want to spend less gas, and get into a batch transaction, they're going to be, an hour to like 4 hours, somewhere in there, and then instant transactions first go across. But right now it's working, it's profitable, and it seems to be, able to be scaled in that same way.
Yeah, I mean, I think monetization and long-term sustainability is no different from like layer 1s or other infrastructure projects. You charge fees for processing requests, and you just have to make sure you cover all the gas costs on the chains you're bridging. So you just have to kind of be a little bit careful there. But I think it's not too hard. In some sense, you actually have a lot more flexibility because you're dealing with multiple tokens and multiple networks. So you can charge a little bit more in the source. You can charge a little bit less and things like that. So you have a lot of parameters you can tune in.
I want to see if anyone else has a question, because we did answer 2 of yours. Cool.
Maybe it's kind of too new, but with interchain accounts launching, like, what kind of opportunities does that have for like executing transactions in a private way on blockchains other than the blockchain you're on? And then if you wanted to do something truly private, would you have to be in like a fully private zone and you could only then interact with other private zones, or is there actually scope to have privacy from like a non-private zone to a private zone, something like this? I don't know if anyone knows. But.
Yeah, I didn't get this.
So I'm just wondering like what kind of opportunities there are for like executing actions privately through interchain accounts, but whether there would be limitations on, as you're saying, like privacy is dictated by the weakest link. Like, would it only really be relevant if you're just dealing with fully private zones and such, or could there actually be an opportunity to have private actions executed from like a less private zone or something?
I mean, I think this is, a little bit back to the kind of conversation we had with, general message passing, and I think interchain accounts is sort of in that direction, is that you can, pass an arbitrary message to ask, a different zone to execute like a computation on your behalf, right? So as long as like, you have zones that expose this functionality, you can, you can send them information there, you can ask them to do interesting things in a privacy preserving way. So I think of interchain accounts as like a step towards that.
Did you have a question?
Is this on? Hello?
Yeah, we can hear you.
Yeah, I mean, I don't know if that question was necessarily specific to bridges. It's maybe more of an IBC question, but I wanted to ask. It seems like there's a time preference that we're starting to see in message passing. So the gravity chain, for instance, does batching on like a daily basis or something like that. And I think Axelar has some options where you could do like low time preference, high time preference. How do you see the kind of classes of user and message passing evolving, and how do you imagine kind of servicing those users?
That's interesting. Different timings.
So to harken back to an earlier presentation, so Nym earlier talked about a mixed net, right? And if you have, in this hypothetical world, which we don't live in yet, but where we have private cross-chain interchain accounts, and now all the transactions are in private, then we have the like statistical attack problem, because you can see, if you see which messages are going between which blockchains, even if they're encrypted, you can perform timing attacks. So batching helps with this. You want to batch private transactions or private actions in that way for the same reason that you want to batch packets in a mixed net. And I would say, I mean, there are like a lot of interlacing dimensions, I guess. Batching can often save on costs, but it can also provide additional privacy. And in the long run, that might even be the dominant consideration.
I think the question also has to do, though, with like these preferential treatment for like some users going faster, right?
We're kind of like treating, like we're putting everything right now under the umbrella of bridging. Yeah. But like what we're starting to see is like actually a segmentation of the market into, okay, I'm an MEV trader and I need like fast execution, and maybe so fast that I want to use a centralized bridge rather than a decentralized one. Or I'm a privacy-preserving user that has like a low time preference, and I can wait like a month for something to come out of the bridge and be fully anonymized. There's Oracle messages or NFTs versus fungible messages. Like these are also kind of segmentation of the market, and so I'm interested in your views and kind of like how this differentiation in the market is going to play out.
Yeah, I think it's a great question, and I think Gravity Bridge really sort of came from the onboarding of like more users that aren't currently in the crypto ecosystem. So that's where a lot of the thought process around batching and making cheap transactions and exposing those choices to the end user, I mean, I think is ultimately the goal of what we need to be able to do. The crypto market is still small, right? And we're going to need to be able to support institutional capital, support a larger set of real world users, and so we need to build for that sort of user choice.
Yeah, I think in some sense, like the problem is again like no different than like problems on layer one infrastructures themselves, right? Because gas fees sort of dominate in some sense performance, and so depending on how much user pays, like they'll get a certain processing time. And I think kind of bridge and bin infrastructure inherently suffers from the same problem. I mean, I think privacy here can actually help, right? And with either batching or just privacy preserving ways that you cannot front run users because you don't see what the transactions are as they're moving through the bridge. So, but yeah, I think it's a similar problem that I think just expands beyond bridges.
Yeah, I would say, how to think topologically about sort of user prioritization from a protocol design perspective depends on what we want the system to be able to provide as product level guarantees to users. And one thing we might want, like a financial system to be able to provide, or a sort of economic system to be able to provide, is quality of service for individuals taking actions in the physical world that are predictable in advance. I want to be able to buy coffee. I want to be able to pay my parents far away. I do this, roughly at this frequency. They're like real world things happening. In order to provide that, I think we probably just cannot get around the hard problem of identity. If you want to provide most people do with their credit cards or sort of interacting with economic systems, it's a few times a day or something in a predictable way. I think it's critical for UX reasons to be able to provide predictable low costs and guaranteed low latency for these specific interactions to users. They can plan their lives out in advance, and we probably won't get that without identity.
One thing you mentioned QoS, right? So this is very much that intersection between internet, though, too. So right now the carriers decide the QoS, right? So I guess my point earlier was that I 100% agree with you, but I think it does have to come back to let's make deliberate choices right now that expose this QoS to users so they have that choice.
Cool. All right. I want to say thank you to the panelists of the Bridge panel. I know we've gone a little over, but yeah, thank you so much.
Thank you.
Thank you so much.
I think we're about 9 minutes late. My apologies. We got into it.
Yes, and I just wanted to remind you as well that there is another side stage, and we're going to have a last one talk at the moment. It's going to be Stargaze, MEV in NFT primary markets. So if some of you are interested in this subject, please join us on the side stage. Okay, and now I'm going to welcome on the stage Vish Modali from Quicksilver.
Hey guys, I'm Vish. I'm one of the co-founders of Quicksilver. I'm the chief product officer. I deal with things like business development, partnerships, and thinking about the feature set of liquid staking. So I guess the term liquid staking has been thrown around a fair bit throughout the course of this event. So I guess it's now time to address what liquid staking is and what the Quicksilver solution is. So I'll high level go over what liquid staking is, the problems that liquid staking solves, the problems that liquid staking creates, and what Quicksilver's take is on all of this. So I guess to tell the story of liquid staking, it would be useful to first just high level go over what staking is. Now, most of you are familiar with this, but in most proof of stake blockchains, asset holders wishing to stake their tokens in order to earn a certain reward are required to lock their capital. This locked capital acts as a security deposit for the validator. So if the validator misbehaves, this security deposit is slashed, and that's supposed to be a disincentive for validators. Now, the concept of liquid staking is to issue a representative token on this staked position. So the representative token not only represents the staked positions, but also any rewards that the staked position accrues and any risk that comes with slashing. Now, there are many models of liquid staking that have gone around. The concept itself has been around for the last 2 years. There's Lido, there's P-Stake, Osmosis is working on their own version of it. So the concept in general has been around, but the core of it has been the same, that you have an asset which is representative, and that's liquid staking. So a good question to ask at this point would be why liquid staking and why liquid staking in the Cosmos ecosystem? And my answer to that on an economic level would be that there is this fundamental capital efficiency problem in the Cosmos ecosystem. And I think it takes two forms. The first is that in most Cosmos SDK chains, only 5% of staked assets are actually slashable, meaning that 95% of assets, though they contribute to economic security, are not actually slashable, so they can be used elsewhere. And it's this promise of being able to use elsewhere is what brings up liquid staking. I think as of today, as of this morning, this value is somewhere near $40 billion. So it's some pretty big amount of capital that is sitting in staking. The second capital efficiency problem I see is that the Cosmos ecosystem has adopted this path of high staking APRs to bootstrap economic security. Now, high staking APRs are considered to be a good thing because they bring this security to chains. But high staking APRs obviously make DeFi uncompetitive. Now, if you look at this from the perspective of an application-specific DeFi chain, they first have to give out a high staking APR to get economic security on their chain, and they also have to dish out a lot of incentives to actually be, for their product to actually be competitive with traditional staking. And obviously, this is not sustainable it's not long run sustainable for a DeFi ecosystem. But the thing is, it was never supposed to be a long run thing. High staking APRs are and were supposed to be a temporary thing, and they are. High staking APRs will come down at some point. But the conventional wisdom or the conventional economic wisdom with regards to this was that when these high staking APRs came down and stabilized, a DeFi ecosystem would emerge out of this low staking APR environment. Now, that would have been true if IBC did not take off in the way it has taken off, where it's made the entire Cosmos ecosystem or the entire IBC ecosystem into one interoperable economy. So the risk here is that there's always going to be these powerhouse projects that come out with high staking APRs, and these staked assets, instead of being freed, continue to remain locked and keep migrating from chain to chain, chasing high staking APRs. And obviously, this would starve the DeFi ecosystem or any potential DeFi ecosystem of the collateral or the liquidity it needs to grow and flourish. So it's pretty clear that there is some level of competition between DeFi and staking. And we don't even need to think about capital efficiency to reach that conclusion. Even on a user level, there is this age-old question. Do I stake? Do I provide liquidity? And sooner or later, it's going to be, do I do 10 other things? Right? And the goal of liquid staking is to remove this inherent competition and make both of these verticals function together in a synergistic manner. So far, I've made the economic case of liquid staking, right? But I think Cosmos is also architecturally in the right place for mass adoption of liquid staking and really leading the charge in this field. And I think that comes down to two core technological innovations in Cosmos. The first is the liquidity staking module being built by Zaki and the Occlusions team. And what the liquidity staking module does is that it tokenizes a staked position to produce non-fungible delegation shares. These non-fungible delegation shares are then consumed by liquid staking protocols like Quicksilver to create fungible and fungible liquid tokens which can be used anywhere. Now, the cool thing about this is that it changes the user flow of staking completely. Traditionally, if stakers had to be onboarded into liquid staking, they had to unstake their assets, wait for the unbonding period, and then deposit their assets into a liquid staking protocol. Now, two things happen there. One, they lose out on their rewards for the unbonding period. And the second thing is that it also constitutes a security risk because a lot of users may unbond in order to enter the liquid staking protocols that would come up. So the liquidity staking module removes the stickiness from staking and makes the flow of assets much smoother. And I think this would be really big in driving liquid staking adoption in Cosmos. The second piece of tech that I think is quite critical is interchain accounts. And basically, what interchain accounts let what interchain accounts lets Quicksilver do is a Quicksilver user can now control an account on another chain from the Quicksilver chain. So they can do all of the staking natively and just operate through the Quicksilver chain. And I think this is pretty important because the Cosmos ecosystem is expanding. A lot of new chains are coming out. So any liquid staking solution, a liquid staking solution cannot be built for every single chain. That would simply be not feasible. So we need a liquid staking solution which is largely chain agnostic, and interchain accounts enables us to do just that. Now, so far I've talked about capital efficiency, I've talked about how liquid staking can boost the DeFi ecosystem, and all of that, but staking also has a pretty important function other than security, which is protocol governance. And if there's one thing I've learned from Cosmos Twitter over the last 3 months is that people care about protocol governance, and rightfully so. So under the current model of liquid staking, if there was wide adoption of liquid staking or DeFi, there would be a governance problem in Cosmos because governance power would be inherited by the user's validator. In the best case, we'd have validators calling all of the shots, and in the worst case, a few validators would call all of the shots in multi-billion-dollar protocols. And obviously, this is a less than ideal situation. So now I've talked about what I see are some of the biggest problems that are associated with staking and liquid staking. Now I'll quickly go over the Quicksilver solution and reason about how we try abating some of these issues. I think the Quicksilver value proposition rests in these 3 verticals. It's capital efficiency, decentralization, and governance. Capital efficiency is a fairly straightforward one to answer. Quicksilver is, at the heart of it, a liquid staking protocol. It allows users to mint Q assets, which are liquid representative of stake positions. But the issue is not all stake positions are same. Each validator has a different risk profile. Each validator has a different commission rate. So how do we achieve fungibility? So our solution for fungibility is to socialize all risks and rewards. So all risks and rewards on per asset on the Quicksilver chain are socialized in a redemption rate. So there will be a redemption rate between the native asset and Q asset. And as staking rewards accrue, theoretically, the value of the Q asset will keep increasing. And this is how users can get their staking rewards. The second key piece of Quicksilver is decentralization. Now, we've made a very conscious design choice to use unrestricted validator sets. Now, traditionally, liquid staking protocols have used whitelisted validator sets, which is a select group of validators. Now, this made sense because these were trusted validators. You could onboard them easily. And the idea was, as the protocol grows, the validator set would eventually expand. Now, the problem with this, especially in Cosmos, is that with something like the liquidity staking module, a lot of stake could be onboarded into a liquid staking protocol from day one. So it's quite important that we go with an unrestricted validator set, because the risk otherwise is that these few whitelist of validators might end up having a disproportionate amount of stake, again constituting a security risk. So the default position for Quicksilver is that Quicksilver will allow delegators to delegate to any validator that they could do so natively. And the second thing we do to promote decentralization are these things that we call participation rewards. And participation rewards directly incentivize users for delegating to smaller, which is decentralized, and performant validators. So what we sort of believe this will do is and if Quicksilver managed to capture some substantial amount of stake, would balance out some of the validator inequities that exist in the Cosmos ecosystem. I also think this is a viable solution to the early bird validator problem, which is validators get into a validator set of a new chain early on, capture a bunch of stake, and remain to dominate. So I think these participation rewards would act as an economic incentive to balance things out and promote decentralization. The third and pretty big thing that I'm personally very excited about is the maintenance of governance rights. I think governance rights are core to what makes Cosmos chains what they are. They're application-specific chains with sovereign communities around it, which come alive through protocol governance. And if liquid staking and/or DeFi takes off in a big way, these governance rights will be lost for the users. And Quicksilver tries fixing this by having a governance by proxy module built on Quicksilver. So for every chain Quicksilver onboards, we mirror the governance proposal that happens on the native chain on the Quicksilver chain. And the Q asset holders would be able to signal their intent for the proposal. And this intent would then be reflected on the native chain. So this still gives users some semblance of participation and some say in governance of the Cosmos ecosystem. And I think what's cool with this, and this is a solution we're working on, is that especially with interchain queries, what we can also do is that if assets are held off-chain, we could still count them in governance. Now, just to give an example, if you have some atom, you bring it over to the Quicksilver chain, you bond it for some Q atom. Cool. And logically, you go put it in the liquidity pool or somewhere else. We're working on this solution which would essentially enable you to still participate in hub governance with your Q asset in an osmosis pool or in some other DeFi protocol. And I think that's pretty cool because you can't even do that with native assets right now. But obviously, this is slightly complicated to build out. Interchain queries is in a very early stage right now. And we will be publishing a full rundown of how we plan to do this pretty soon. So the way I see it, governance is a pretty prominent thing, pretty important thing for any liquid staking protocol. And I personally don't think Quicksilver can become a liquid staking hub without having strong solutions for governance and by extension being a governance hub for the Cosmos ecosystem. So I guess to quickly wrap up and conclude, unlocking all of this capital is just the first step for Quicksilver. The interesting thing would be to figure out what to do with all of these assets. If $40 billion worth of assets enter the Cosmos ecosystem, there are a lot of things you could do with it. Now, personally, I'm excited about building some sort of index on top of Quicksilver with all of these collateralized assets, but that's just one thing, and a lot of things could happen. And that's partially why we've allocated 20% of our Genesis supply to funding all of these cool projects that could be built with Q assets. Now, I guess to sort of conclude, the vision of Quicksilver is essentially to have all of these assets enter the Cosmos DeFi ecosystem and supercharge it in some ways. And while supercharging this DeFi ecosystem, we want strong communities centered around user-based protocol governance, a decentralized validator set, and a general WAGMI situation for everyone in the ecosystem. And I think that's about all I have. Thank you.
Okay.
Thank you. So you talked about this kind of like socialization of rewards for delegating your liquid stake with smaller validators. Do you mean that you would be redistributing what would be earned, like, so for example, Atom, or is that additional rewards in like Quicksilver tokens that go on top, which are then?
Yeah. So it's additional rewards in Quicksilver tokens that we give out to users who choose smaller and more performant validators.
Okay.
I think there's a question back there.
I just have a quick question. What would you say is the main difference between this and something like superfluid staking on Osmosis?
Yeah, so that's a pretty good question. Now, superfluid staking and liquid staking are essentially two approaches to solve a similar problem, and the problem being capital efficiency. And so what superfluid staking does, and the market that superfluid staking targets, are liquidity providers. So users who already provide liquidity on Osmosis can now use that capital and to stake and secure the chains and earn an extra yield on it. But the target that the market that liquid staking, a liquid staking solution like Quicksilver targets, are people who currently stake, or users who prefer to stake their assets first. And I guess another key difference of a liquid staking protocol would, as of now, would be that with a liquid token, it sort of gives users that freedom to explore different alternatives and do different things out of it. Now, you could do things like indexes, for example. Like you could have one asset collateralized by a bunch of Q assets, which are representative tokens, and then this collateralized asset could then be integrated in DeFi ecosystems. So these are sort of possibilities that open up with liquid staking. But obviously, superfluid staking has a much cleaner UX in some senses where you don't need to deal with this representative token. So I think both are pretty good solutions for and I think both will end up doing pretty well in the ecosystem.
Okay, thank you very much once again.
Thank you.
And now I would like to welcome to the stage Henry de Valens from Penumbra. Bravo.
Hello everyone. So my name is Henry. I'm the founder of Penumbra Labs, who are incubating Penumbra. And today I'm going to be talking to you about some of the aspects of the state model that I think are kind of cool and interesting. Oh, no, there we go. I'm just bad at the remote. All right, so to start off, the useful question is sort of like, okay, what is Penumbra? And I think a good way to conceptualize that is that it's an answer to this question of how do we provide useful functionality on a private ledger? So for the people who have kind of self-selected for a Privacy in Cosmos event, I think the value of like having a private chain is pretty clear, at least to this audience. But we have this kind of unfortunate situation in which, on the one hand, we have a lot of people who get a lot of use out of blockchains, and then we also have some private blockchains. And the Venn diagram between those two things, as someone who works on privacy, is like uncomfortably close to two circles, right? So how do we actually build something that is useful? And our answer is Penumbra. So Penumbra is sort of a combination of three things. First of all, we have this private proof-of-stake L1 built on Tendermint that acts as just like a private base layer for everything, has a private staking system, which has some interesting things that we won't be getting into in this talk, but you might want to check out later. And this L1 acts as a cross-chain shielded pool that lets you take any asset from any IBC-compatible chain and shield that asset and record it privately on this zone. Why would you want to do that? It's because we've also built, or by the time this launches, we'll have built this private DEX that allows people to do on-chain trading in a private way. And I think that's actually a really interesting application, because trading is a use case where privacy doesn't just have this kind of abstract sort of principled value, right? I believe in privacy, but that doesn't itself make a compelling product. Whereas with trading, you have a situation in which privacy actually has this kind of concrete, quantifiable, near-term financial value that's giving people a positive reason to use this. Okay, so maybe that sounds cool, but there's this issue. Oh, sorry. And this is the diagram of basically how that fits together, right? So you've got this big, beautiful ecosystem in Cosmos at the moment. Everything is transparent. And although there are, not just Penumbra, but other projects that are trying to build private parts of this ecosystem, it does seem pretty clear that we're not going to, just tomorrow wake up and everything is going to be private, right? So from anywhere in this ecosystem, you should be able to do an IBC transfer into Penumbra. And when you do that transfer, you shield your assets, whatever they might be. And then inside of this shielded zone, you can transact, stake, swap, market make, and all the time just have privacy by default. So this is all cool, but okay, like how do you actually build this, right? How do you go from like what would be useful to how are we going to build the useful functionality? And what I'm hoping to convince you of in this talk is that actually the biggest challenge to building a useful private system is not actually the kind of ZK cryptography or like what proof system you're using or whatever, but it's the fundamental state model. And that this is really the big blocker to building useful private systems. So as a bit of context, right? In a traditional blockchain, you have essentially like global mutable state, right? You have, here's the chain state, we get some transactions, I have a transaction, I execute it, now I have a new state, now I'll have this other transaction, execute that one, new state, and I just keep doing this. In practice, it would be kind of annoying to have to come to consensus on every single transaction separately, right? So you bundle them into blocks, but fundamentally, it's a big ball of state, and you change it. And on the other hand, if you have a shielded blockchain, you need to have a different state model that's built on composable state. So this is actually kind of more similar to the original UTXO model in Bitcoin, where instead of saying like, oh, well, we have this like big ball of global state, and a transaction can just like edit that and do whatever, we have this collection of state fragments. And these state fragments are immutable, but they're also composable. So when I have a transaction, what's actually happening is my transaction is going to say, okay, we take these state fragments, we consume them together, we're going to compose them into this new set of state fragments, and then we'll append those into this like big collection of like little bits of state. And why would you need this for building a shielded chain? It's because this is what's going to let you make the whole thing private. And the way that we're going to do that is we replace the actual state fragments themselves with just cryptographic commitments to those fragments. And instead of having, okay, here's the transaction that you can like literally apply, that transaction is going to have just a proof of correctness that these are commitments to the new state fragments that were made according to the rules and stuff. So this is all really cool and awesome and great. And so we've solved the problem. We have all these shielded blockchains, right? No. The unfortunate problem with this is that this only works when there's no shared state, right? And the problem is that whoever is making this transaction has to build this zero-knowledge proof of a complete valid state transition. And so there's two obstacles there. The first is that whoever is making that proof has to have, it's a proof of knowledge, so they have to have knowledge of what the state transition is. So there's no way that I can interact with your private state, right, without knowing what that state is. And also, there's this kind of early binding property, where the transaction has to be this totally sealed blob that completely defines, here's what the state transition is, and you can go execute it. And that's kind of a problem if you're ever trying to interact with some shared resource, because how do you know, right? If you want to submit a swap, right, you can't know in advance, like at the point that your transaction is processed, exactly what clearing price you're going to get in order to be able to kind of pre-seal that into a proof. And so if we return to our question of like, how do we build useful functionality, when we think about what kind of functionality people like to use, essentially all of it involves having some kind of public shared state. And so we can reframe this question as like, how do we allow private interaction with some public shared state? And this, the way that I think about this problem is that this is sort of the problem of shielding value flows. Okay? So what do we mean by that? We have this kind of general situation where there's a blockchain, it has some state, it's doing some stuff, right? And so there's value that's occupying different roles within that protocol, that application or whatever, and there's transactions that are happening, and those transactions are causing value to flow between different parts of this system, right? And the challenge that we have is like, how do we hide information about these individual transactions so it's not possible to see what each one specifically is doing, while still revealing information about the kind of overall aggregate state of different parts of this system. So as an example, right, how do you hide the amounts of each person's delegation, but still be able to see the kind of aggregate total voting power of all the different validators? Or how do you hide individual votes, right? I mean, you definitely want to have private voting because otherwise people are just going to like airdrop bribes to people. But you still need to be able to like figure out what the governance outcome is. The motivating case actually for Penumbra was like, how do we hide individual trade amounts but still reveal the reserves of the AMM? So there's a kind of cute paper by Tarun and Guillermo and Alex about how, like if you have the AMM before the trade and after the trade, like it turns out you can just like, plug in a formula and figure out exactly what the trade amount was. And then the last one that I think is kind of, topical here is like, how do you hide bridge transfers while still revealing the chain solvency? So these are all actually kind of like different facets of the same basic problem. And there's sort of two fundamental kind of classes of strategy for dealing this that go in opposite directions. So the first one is trying to split up flows into little chunks. And then the other thing you could do is you could batch flows into bigger chunks. What does that look like? So in the first case, right, splitting, you could imagine some user has some like amount, and they're just going to split that into some randomized sub-amounts. Maybe they have some user agent that will do this for them. And then they'll like spread those out into some like different transactions that each has like a little part. And then later they'll try and like reassemble them and just like hope that whoever's looking at the chain doesn't know statistics. So that's like obviously kind of suboptimal. But I would say that the one thing that is good about this is if you do end up in this kind of happy world where there's like multiple private chains, there is some sense in which this isn't necessarily the worst thing. Like if you tried to do this on a transparent chain, you're going to like definitely lose right away. But there's a kind of like worse is better thing in that this is like something that some individual user can do on their own without requiring any kind of protocol changes or whatever. But definitely not the thing that you want to build, like your whole protocol on. And so the second kind of class and alternative is batching flows. So here, instead of having just one user, let's say we have a bunch of these different users with different values. And what they're going to do is they're going to encrypt all of these integer amounts using a primitive that we've started calling flow encryption. So you can think of this as basically like a sort of spicy additive homomorphic encryption. And the reason to pick a different name for it is that once you start thinking about how do we integrate this into a blockchain, you come up with this like long list of like all these extra properties that it has to have in order for it to actually like function as part of a system. And at that point, it's better to have a distinct name for the concept. So we have some docs on this on our protocol spec, but effectively the flow is that once you have these ciphertexts, right, they're all additively homomorphic, so the chain can aggregate all of the encrypted values over some interval. Maybe that's over a block, maybe that's over a full day, maybe longer or shorter. It depends on the application logic and the context. But then the validators can do threshold decryption to reveal only the batch total for that whole amount. And once they have that batch total, they can use that to do some public on-chain computation. And at that point, okay, it's like, this is cool, but how do we actually use this? So if we return to this original problem that we had of how do we allow private interaction with public shared state, this mechanism of using flow encryption to do batching actually lets us do this in a way that is pretty cool, but has some interesting consequences for the state model. So we'll start off with some user who has some private input. And what they're going to do is create some transaction that does something. What it is might depend on the application, but that transaction is going to have, along with whatever else, some encryption of their input, which is their contribution to some part of the flow, of some kind of flow. Whether that's their vote, whether that's an input to a swap, whatever. And they make that transaction, they submit it to the chain, And the other side effect of that transaction is that they're going to get this kind of private state NFT. It acts as basically like a receipt for participation. So what happens when that transaction is actually processed and included in the chain? It gets batched together with some other inputs from some other transactions. Maybe this, will take some time if there's like a very long batch interval, depending on the application. But at some point, the validators will aggregate that together and then decrypt some batch total. And at that point, right, they're going to do this public computation. And the neat thing is that then you can have public outputs of that computation that get committed to the chain state. And at that point, the user who originally submitted their this transaction can use their private state NFT to effectively just like mint some new private outputs. And as part of the transition proof for their outputs, they can use the results of this public computation. So for instance, if you wanted to do a shielded swap, right, your input is like, the amount that you're submitting to as part of the trade. And the public computation is like, okay, well, we'll go and like resolve all these like batches of trades. Maybe we'll do arbitrage and consensus or some other, sick hacks, and then end up with all these clearing prices. And now everybody can just like mint their new tokens. And so this is a kind of really interesting model because it's dealing with the problem of having interaction with shared state by basically explicitly segmenting the activity into distinct phases where someone is submitting part of an entry into a batch and then later using the results of the batch computation to prepare their outputs. And as a side effect, you end up with having the chain basically execute every piece of functionality, whether that's explicitly kind of as a smart contract or part of the consensus. But effectively, every contract instead is just going to execute once per block, so you can get some considerable efficiency savings. And you end up getting a kind of neat property, which is that you have no transaction ordering. Because everything is just batched together anyway. So once a transaction is included in a block, the ordering within that block has no effect on the results of the execution. And there's also no visibility into what the transaction does prior to it being processed. And so if you think of what's going on with MEV, you're basically saying, okay, some like block proposer is going to get some like actionable information about the transaction and use that to discriminate against it. But first of all, it's not actionable because there's no transaction ordering, and second, there's no information because there's no transaction visibility. And so the result is that by design you have like effectively no MEV. So yeah, anyway, that's the punchline. I think this is a kind of neat model for how to go forward, and happy to have any questions.
Yeah, very cool project. I had a question. So if there's no transaction ordering and everything is sort of batched together, what kind of impact do you expect it to have on like pricing in AMMs for the end user?
Yeah, so there's definitely trade-offs with this approach. One is that you are kind of, well, okay, so I'll separate two things. First is like there's the concept of just like having this type of state model, and then there's also what we're going to be doing with Penumbra specifically. So in general, with this class of state model, you could still have that type of control. So for instance, you could say every input is going to set its own custom slippage limit or something, and as part of this like batch processing, you would like sort them all by slippage limit, and then the ones that were above would just not be processed. And so I don't think that there's any inherent kind of issue with this type of like just fully commit to batch processing of everything and not having transaction ordering. For Penumbra specifically, we want to achieve long-term privacy for individual trades, right? So unlike a system where it's like, okay, well, we'll encrypt transactions until they're committed, and then we'll disclose them, right? We want to have them be protected also after they're executed. And so we basically, in the AMM design, we sort of pick two different trade-off points on privacy versus fine-grained control over trade execution. And on the market taker side, we prioritize privacy. But on the market maker side, we prioritize the execution control. So all of the AMM positions are public but anonymous. And so the idea is like, okay, if you would really like to have like really exact control over your execution, then you might want to use like a concentrated liquidity position as a limit order. Or alternatively, if you're want to like stay on the market taker side, you could do something like sharding your execution into like multiple sub transactions that you spread out over multiple blocks, so that you're minimizing the sort of price risk of ending up in a batch with some whale or something.
I have a question. So thanks a lot for the talk. So in this particular model, what happens if one of the individual transactions that were batched, what happens if this transaction is actually invalid? And does that open some room for denial of service attacks?
So the really cool thing about building the chain around ZK proofs is that you can guarantee that that isn't the case, right? Because before you batch the before you take some transaction and include it into the batch, that transaction has to have a whole complete set of validity proofs that establish that it is an allowable state transition. And so at the point that the chain is aggregating these contributions, it can already be assured that they are definitely guaranteed to be correct. But that is actually a big issue, and it's one of the sort of finer points of like what is like this concept of flow encryption. One of the additional properties that you end up needing that's beyond just like additively homomorphic threshold encryption is you need to have a strong kind of end-to-end verifiability that like all of the ciphertexts were well-formed, and that all of the aggregation was done correctly, and that none of the validators like substituted a different decryption, and have this kind of end-to-end integrity of the value flow through the whole system.
Cool, thanks. Should I just throw?
Hey, thanks for talk. I was talking to Lido at one point about encrypted mem pools, and they raised an interesting concern, which was basically like opening up spam vectors. So in this case, you have no ordering within the block or like the segment that you're anonymizing, but one could potentially just flood the mempool with like microtransactions to like eat up the entire segment, and then just have like one large trade in that period. So do you have like mitigations for this kind of attack? I mean, their thesis is like MEV just like cannot be eliminated. It can only be like pushed into other kind of domains, which I thought was like an interesting perspective.
So I think it's kind of important to note that we don't actually have like an encrypted mempool, right? It's that all of the transactions that are in the mempool don't reveal any information. And so at that point, you don't have a particular concern about, at least if I'm understanding the question correctly, I don't think that you have a particular concern about denial of service attacks that is any different from just like being able to DOS a chain by submitting a bunch of like spam transactions, right? Like all of these transactions are going to have to pay a fee. And the nice thing about batching is that if somebody is like adding a bunch of extra transactions, like that's just increasing your own privacy.
Interesting. So if you're using zero-knowledge proofs for all this, are you only charging a fee, or do you have any sort of gas as well for this?
So we're still kind of like refining exactly what the cost model is going to be like, but there are fees, and what we're probably going to end up doing is having a kind of like lightweight, like So one thing I guess that is a difference is that when you have a shielded transaction with these sort of pre-finalized, like sealed state updates, on the server side, to validate that, you're not having to do like execution. And so you can just like know exactly what the cost is up front. And so we're probably going to end up with a fee model where, you know, if you add, like if your transaction is bigger and it does more expensive stuff, it has more proofs in it, like your required fee will probably end up being higher to like account for that cost. But a lot of the complex resource use problems that come from having this like on-chain execution actually go away in a shielded model because the actual state transitions are happening off-chain. And what we're left with is, so just to rewind to this kind of batch processing diagram, another thing that's very cool about only executing each piece of functionality once per block is that you get to amortize the cost of that execution over every single transaction. And so depending on which way you go, right, either that could be much cheaper, or you could say for the same amount of cost, we could do like much more like computationally intensive processing and do cooler things as part of the app logic.
Thank you very much. Thank you, Henry.
All right.
Now we're going to take a short break, 20 minutes. So see you back 15:40.
So, hello?
Yeah, exactly.
Hello? We are starting back in 2 minutes with the talk from Sergey from Axelar. So if you want to take a seat and let's get ready.
All right.
Hey everyone, let's welcome Sergey Gorbanov from Axelar for his talk.
All right. Hey everyone, how's it going? Awesome. Grab your seats if you want. If not, then that's fine. So great to be here, and thanks so much for inviting me to talk about Axelar. So first time in Amsterdam, and I was taking a taxi to the hotel, and so I learned the most important thing about Amsterdam. And apparently is that you should not go to a coffee shop because they put interesting things in your coffee there, and you should only rely on Starbucks. Following that, the driver told me that he was born in Amsterdam, raised in Amsterdam. It's the happiest place in the world, and he would never leave. So now we know why. Awesome. So hope you had some good coffee. Let's get going. Super excited to tell you about Axelar. If you don't know, and the one-liner, if you need to remember, think about secure cross-chain communication. On that note, let me quickly mention or introduce the team if you're not familiar. So we have a pretty amazing team, super proud of a lot of the folks that are working with us. The team comes with deep backgrounds in cryptography, distributed systems, kind of consensus. We designed and worked on many protocols over the years, from Algorand to kind of standardization of crypto protocols like BLS, kind of hyperledger optimizations, nuclear fusion, and things like that. So pretty deep team in the technology space, and super proud to work with all of the guys. All right, I think on that note, very briefly, I think this is all familiar to many of you, but we know that the world has gone multi-chain over the last few years, right? I think, if you look at the evolution of the ecosystem, it all began with a couple of foundational projects, Bitcoin, Ethereum. Early applications were built around those, of course. And then we quickly realized that on their own, those platforms could not scale, right? So over the years, we saw an array of other platforms entering the market. Many of them optimized for unique technical capabilities or go after specific markets or use cases. And I would say only over the last year or so, the applications now embracing the multi-chain ecosystem and thinking about how do you leverage and build on top of these newer platforms, and how do you leverage their technical capabilities, or markets that they're targeting. So lots of applications are going cross-chain these years. Now, the unfortunate side effect of all this is that the space continues to fragment, and it continued to fragment over the last year or so. And one of the reasons is kind of a lot of ad hoc solutions, in particular bridging technologies that have been rolled out to solve some of the interoperability issues that we're seeing, right? Basically, I think the way to characterize a lot of the bridging tech, it's mostly been centralized, except for a couple of exceptions. And so you see a lot of the hacks over the years where a few nodes get corrupted, or just bad and poor security models. The second problem with a lot of the technologies is they have limited what I call pairwise or one-to-one connectivity, right? So again, like the stacks have been designed and everything has been built to connect, A and B, which is great, but we're in a world and an ecosystem where we want to be able to connect, many to many different ecosystems and continue to scale, and support millions of chains, and you have to kind of design the stack from the right approach. So whenever I use one of the existing bridges or kind of think about the space in general, we kind of look at this picture, right? And I don't know about you, but I'm just hoping that I don't end up like on the bridge on the left, right? So that's the state of the art. Awesome. So what do developers actually want? Sorry. The developers want platforms, not silos, right? So as a developer, you want to pick a platform where you can build the best application for your user experience while still being able to leverage and compose and interact with all other ecosystems. Okay? And so that's what Axelar Stack allows you to do, is as a developer of your application and asset, you can make the best decision for yourself where to go without having to think about losing liquidity or losing composability. And so the Axelar Stack enables you to perform secure cross-chain messaging, asset transfer, contract calls, and anything else you can think about. The other big point that I want to kind of mention is that at the very end of it, I really don't think the users care about bridging technology or interoperability or too much what chain they're on. Okay, as a user, really what you have to do is you have an asset, you see an application, you just go ahead and use it. And so we're building the stack with the user simplicity in mind to think about what are the right layers that you have to provide and build in order to enable simple one-click interactions across the ecosystem. Right? As a user, I should be able to go and use the application, and I have to put trust in the application issuer and developer to build on the best and secure platform their application. I have to put, a trust that they're using the right interoperability or bridging technologies. But as a user, all those things, there's no way you can think about those things. And so that decision has to be kind of relied on the developers to do this. Simplicity is one of the core things that we need to get to in order to go to the next level of adoption for the blockchain ecosystem. And today, it's just horrible and painful. All right, awesome. So on a high level, let me introduce you kind of to the Axelar Stack. There are a couple of layers, but let's start from kind of the top. Going back to the premise that we wanted to start with, we want to enable applications to be built anywhere they want to be built, right? So you can go and build on Ethereum, on Avalanche, on Cosmos, on Polkadot, and we'll help you communicate with all other ecosystems through a universal set of APIs and SDKs that you can interact with. You can think of it as an application. You can call a message to a specific router or a gateway, which is a smart contract on the chain. From there, underneath it, there is the Axelar sort of transport layer and the gateway protocol that would serve the purpose of finalizing messages, routing them, executing them, kind of delivering where they need to go, and then returning the result back to the application. Right. So underneath all of this, the Axelar network itself is a decentralized proof-of-stake network. So it's based on a Cosmos SDK. So you can, anybody can join, run as a validator, participate in the consensus, and have full security of proof-of-stake model back in the transport layer itself. All right, so what are kind of some of the key ingredients of the Axelar network? There are a couple of big components, and I want to kind of emphasize that everything has been designed with the goal in mind to really be able to connect millions of chains over the years, right? And so the components are all reusable and they're all programmable. So at the very core of it, there's a Tendermint consensus, which all the functionality has been coded around it, and so it serves us really well purpose in order to agree on the state of cross-chain messages that we're processing. There is a layer of kind of finality gadgets, which allows you to connect an arbitrary blockchain with with few instructions, essentially, or a few commands on the network, right? So those finality gadgets, you can think of it, they can deal with probabilistic chains, right? They can deal with chains with instant finality. You just need to specify, confirmation heights or basic parameters, and then you can onboard the chain. There is a layer of kind of multi-party cryptography that's involved in it. Everything is pluggable. You can replace the cryptography, so you can use anything from multi-sigs, like threshold signatures, BLS signatures. You can use zero knowledge if you want. And so that serves as a building block and a component as well through the network. And on top of it, there is a layer of programmability that allows anybody to go and kind of use all these building blocks, run commands on the network in order to onboard a new ecosystem as easy as possible, right? So this is kind of at the core transport layer. All these components can be merged together and composed to make interoperability scale. All right, awesome. So yeah, in terms of the network itself, we actually started to roll it out, a couple of months ago. It's still in the early, I would say, phases of the rollout, but it's already onboarded, like a dozen of chains or so. Everything from Cosmos-based chains that can interact with IBC to various EVM chains, Ethereum, Avalanche, Phantom, Moonbeam, and so on and so forth. And like I said, because of the way the network is designed and the components are designed, it's pretty easy to actually keep on onboarding new chains and keep on adding more connections. So kind of check out axelarscan.io. It has some interesting graphics and kind of statistics about what we have processed today, but it's still kind of early days of the rollout. All right, so I'll mention a couple different functions, on the network layer, and one what I call is a universal asset transfer. So the basic idea is the following: whenever you compose in different ecosystems, some of them speak very different languages today, right? So you have Cosmos that speaks, IBC. IBC is not extended to other ecosystems yet, so you potentially have to speak either a different message format, or you have to translate one message into the other format, right? And so this is, at least for now, what we have done is kind of enable functionality to perform transfers, from many to many different ecosystems, right? So from many Cosmos chains to many EVM chains, and vice versa. And the basic kind of core premise of all this is, as more chains are added to the network, you get very strong compounding and networking effects, right? So you're not fragmenting liquidity, you're not fragmenting connections. Every new connection that's added automatically gets to benefit from all other previously interconnected ecosystems, right? So it's not a pairwise connectivity in that model. And underneath it, you have these strong kind of translation properties where packets from, let's say, IBC can be translated into packets that are readable by, EVM, contracts, and vice versa. Right, so because the translation happens at the network layer, it's all very optimized and it's all very cheap and it's all very effective and efficient. So you can program these things as well. You can, so on the gateways that I mentioned earlier, you can actually call the gateway contracts in order to send tokens. Or one of the features that we have rolled out, which seems to be very interesting for the community, is to be able to get a deposit address where you can send a regular transaction to send your funds from one chain to another. Right? So think about it this way. In a lot of the bridging technology, you have to use things like MetaMask or smart wallets in order to actually use them. Right? That limits your user base, to MetaMask or smart wallets, which is 20 to 30 million, half of them from a Binance Smart Chain. If you want to go beyond that and allow your assets to be transferred through centralized exchanges, right, through dumb wallets, and get to hundreds of millions of users, you can't require people to have MetaMask. Right, that's a very limited factor. So what Axelar can do is you can call an API to get what we call as a deposit address. And the deposit address is a function of from where you want to go to where you want to end up and what is the destination address where you want to receive your funds. Right? And this address is a regular address that can be computed to you, to which a user can send funds from any wallet, right? From a centralized exchange, from a dumb exchange. It's a regular transaction that's executed. And the reason that it's enough is because of the Axelar Network layer. Once you create this deposit address, you create sort of a path from a source to a destination. Right, so once that path is created, users can send an arbitrary transaction. You don't have to decode arbitrary, complicated payloads and smart contracts and so on and so forth. So super excited about that feature. Gives you, access to millions or hundreds of millions of users that were not previously available for bridging technologies in general. Awesome. So the second, big component of Axelar, which we're rolling out now, is what we call is general message passing. Right. So the basic idea is that tokens are great, but they're in some sense what they allow you to do is they allow you to move asset to the computation. Right. You have programs that are deployed on certain smart contracts. You're moving assets there to do things. With general message passing, you can go way beyond that. And what I can think of is you can start thinking about paradigms where computations can move to the assets. Right? And state can move flowly across different blockchains. So as opposed to having to move the tokens, you can have functionality where the tokens or the assets are residing on a chain A. They're interacted through various smart contracts, and only state about those contracts or calls is then communicated to synchronize with other applications or other application logic that could sit on different chains. So this is on the high level how this would work. High-level diagram, if you have a user would interact with what we call as a source chain application contract. So let's say you're going from Ethereum to Avalanche, you would have a contract on the source chain. The user can send an arbitrary command to the contract. That contract can do anything, in a Turing-complete world that you can think of, right? You can swap tokens, you can lock them in any shape and form. When the message needs to be relayed to other network, the application layer logic can call it to the Axelar gateway. The Axelar gateway is you can think of it as an input and output buffer or a queue to which you can read and write messages. Underneath all of this, there is the Axelar decentralized proof-of-stake network that will confirm the messages, help you process them, relay them, and put them on the destination gateways, right? On destination gateway, from there you can call any other contract with any other payload, whether or not you transfer in tokens or you just synchronize in state across of your application. So you can do all of this, and then the user can get their result in a different wallet or the same wallet, or depending on how you execute the application. So super excited about this. I think kind of in the cosmos, I think similar, trends to think about is through kind of interchain accounts, right, that allow you to send transactions from one chain to another. This is kind of going beyond that and going and interacting with EVM chains. And we're thinking about ways that actually the two can compose with one another, which I think will be, super exciting. high level, let's go beyond tokens. Let's enable Turing completeness, right, for cross-chain communication. And that's what this allows us to do. All right. So yeah, you can think about building arbitrary applications from, super apps, what I call, which is, I think, super exciting category of projects we're starting to see in the crypto space, where things like wallets are allowing users to do more and more, right? Purchasing, viewing NFTs, kind of a trading, going from one chain to another, and all of that is going to be enabled through interoperability stacks and cross-chain communication. And I think this is definitely going to be an exciting category that we're going to see in the coming years. Beyond that, you can use your imagination to kind of think what to do with this general message passing functionality. Everything from NFT transfers, cross-chain automated market makers, gaming, and so on and so forth. And we're seeing some early use cases and exciting stuff for instance, like a first cross-chain NFT marketplace that's been built by our community that allows people to, that have tokens on different chains to kind of purchase NFTs that may be hosted somewhere else across the ecosystem, right? So kind of super exciting use cases. All right, so I think I'll end it here. That was a quick talk. So if you want to follow us, check out Docs, sign up for Discord. We're always there to answer any questions, and I'll be hanging around. And I can probably, I don't know how much time we have, but I can probably take a couple of questions now at 1 minute. All right, 1 minute is good for 10 questions. Let's go quickly.
Anybody?
All right. Awesome. Well, thanks, everyone. We'll see you around.
Thank you, Sergey.
All right, so next up we have another panel. I'm going to invite 4 panelists this time around. I hope we have enough mics.
We have 4 mics.
We have 4, oh, so we will have to share one mic. Whoever's on whichever couch here. Okay.
Sorry. Wait, are we using this chat? Oh, right.
There's one. All right, so this panel is, the title is Bridging Privacy into Cosmos. When putting together this event, we felt like a lot of what we were focusing on was Cosmos with a sprinkle of privacy. There is a lot happening in privacy, and so with this panel, what we're actually going to be doing is talking to 4 privacy-focused projects, 2 of which are connected to the Cosmos ecosystem already, one of which is deeply in it, but 2 which are less connected. And I thought this was actually a cool moment for the Cosmos community to also get to know what's happening in privacy. So let's start with the project that you did already hear about today, Penumbra. Do you want to just say a little bit about yourself and the project?
All right. My name is Henry. I guess, so I gave a little bit of a brief overview of what we're building in the talk that I did. But the punchline, I guess, is that we're trying to build up a private DEX. And the thought process there is that trading is a really interesting use case for bootstrapping privacy, because it's a case where people have a financial incentive to not disclose their information. And so you could potentially change this kind of existing dynamic where a lot of the time when people build private systems, it ends up being kind of like, okay, here's our private X, right? And it does X, and it's private, and it's like kind of worse at doing X, but like it's private, and you should like privacy, and like, everybody thinks that privacy is good, so you should use our product. And like, unfortunately, I think that doesn't really work as a product. And the hope is that with trading, it's a case where privacy, thought of as kind of control over the disclosure of information, has this very concrete kind of financial incentive, and maybe we can harness people's like kind of naked self-interest to bootstrap this like private infrastructure.
Awesome.
Like, can we actually be better at doing X because it is private rather than, you know, being having some kind of trade-offs?
That's awesome. Adrian?
All right.
Maybe also mention your connection to the Cosmos world.
Yeah, hi, I'm Adrian. Yeah, my connection to the Cosmos world is I joined as the 3rd core protocol engineer on Cosmos in like 2017, and sort of built multiple companies out of the space, including a validator. And so what is ANOMA? ANOMA is a suite of protocols and mechanism for privacy-preserving human coordination in a very self-sovereign fashion. When you think of human coordination, right, that can mean very simple things, such as being able to express access control on your wallet, but it can also mean very complex things, such as on an ephemeral level, wanting to buy Starbucks coffee and offsetting the carbon cost at the same time, or on a very permanent level, being able to define that whenever you interact with the financial system, you always want to make sure that you're buying fair trade things. And ANOMA allows all of these things to happen in a very programmable and intuitive fashion. And I think maybe one of the main things here is that, well, one thing we have to realize is that we need way more information density in how we interact with the world. Right? When you think of something like an election or of the financial system, it's very an information reductive step where you sort of try to break down things into single points that you can coordinate around, whether this is a binary choice in an election or a single price for a cup of coffee. But real life is way more complex than this, and we should allow people to be able to express these like very complex preferences that they may have in relation to their environment, where when I buy coffee, I not only care about the price point of the coffee, I also care about whether it was sustainably sourced, whether the CO2 cost is offset. And yeah, this is really the idea with ANOMA, to allow very high information density to be automatically computed over, and so for people to permanently express their preferences in relation to the world in order to automate a bunch of these things, so that I can say I always want to buy carbon neutral energy, and I have to do this once, and then for the next 10 years, it's just automatically done. But I can also update these kind of preferences. Yeah, and of course, everything in a privacy-preserving manner, because as we discover, privacy is fundamentally important, because a bunch of things start breaking if we don't have privacy.
Got it. Emre?
Sure. Hi, everyone. I'm Emre. I'm with O1 Labs. O1 Labs is one of the main contributors of MENA Protocol. MENA Protocol is building a private and secure way to access Web3. It started as a, using ZK primitives as a project that has full node security with just a few kilobytes of data. So that has been live on mainnet for over a year now as a new blockchain. And now in the coming months, we're looking to enable easy ZK programmability, where anyone can deploy using super easy SDK and TypeScript ZK apps on the MENA network and be able to share their data in a private manner where they make attestations instead of sharing all of their data onto smart contracts on the blockchain. And when you combine that, super small data, full node security with this, that enables MENA to become kind of this private user data layer to any other layer 1 ecosystem, whether that's Cosmos or anywhere else. So that's what we're working on.
And maybe one thing about MENA is it was one of the first, if not the first, to kind of showcase this type of technique called recursion in ZK. I know it existed before and it had been written up in academic papers, but as far as I know, it was at least the first big-scale use of that technique, which is now being used by lots of ZK projects. All right, Alex.
Yeah, hi everyone. First of all, let me just say it's a pleasure to be here. Thank you for inviting me. It's amazing to see, I've been in the space for about 5 years now. It's amazing to see the Cosmos ecosystem just grow in the way that it has. So again, it's a real pleasure to be here and be part of this event. I'm Alex. I'm the COO of Aleo. Aleo is a platform for private applications, similar to, probably some of the things that these guys have described. This is things that potentially benefit from privacy, and I really love the way that Henry framed it. Is like you can't just, you can pound the table all day and say you should care about privacy, but fundamentally, I think all of us should focus on how privacy makes something fundamentally better or enables something that hasn't before. So anyway, at Aleo, what we try and do is take the Zcash basically paradigm and extend it to more general programmability. And I think maybe the other different thing about Aleo that I'll mention is we have a consensus algorithm that specifically tries to incentivize proof generation, and with the hopes of making it more economical, more efficient over time, and to therefore bootstrap this as a paradigm into the ecosystem more broadly and help integrate these private applications across Web3.
So when it comes to privacy projects, I feel like there are different kind of levels of how private something is. You have the model that Zcash sort of pioneered, which is to have a shielded or cloaked, as I'm going to keep trying to use, portion and a transparent portion. So part of the blockchain you can actually map like any other, and part of it is hidden. And I wondered for each of these projects, like what parts are private and which parts are actually public. This might be something interesting for people to understand. So maybe we'll go this way? Yeah.
Reverse? Yeah. By the way, is cloaked the new term?
So I'm trying.
I kind of like it, actually. It's
because of Star Trek.
Yeah, Star Trek. Yeah, I'm into it.
Cloaked and decloaked.
Yeah, I'm into it. Anyway, so I guess maybe just as a general answer to the question, there's a couple different dimensions of privacy that you might care about as a user, right? So one is you have an identity that you're using on chain, which could be your account or something, and maybe you would like the fact that you would like that identity to be obfuscated in some interaction, right? So you don't want the one of the interacting parties or an observer to know who you are. So that's kind of one dimension. And then the other is what is the interaction? Like what is the program basically being run? And maybe you would want to obfuscate that program. Like for example, if you're participating in a dark pool or something like that, there's potentially reasons, for example, trading to want to hide the fact that you're participating in a dark pool, because if you're trading in a large enough amount, or you're a specific player, say you're a large venture fund exiting a position, obviously just that knowledge alone that a program is being accessed might trigger actions that you don't want to necessarily trigger. So I think those are and then of course I guess the last thing, and since we're talking about Web3, is the transaction amounts, right? So sometimes for example, Tornado is it's the way it works is kind of more as a mixer. So you're kind of mixing the amounts that are going in. So maybe the amount or the specific data or state at which you're accessing, you might want to hide too. So yeah, I guess I'll leave it there in the desire to have it general, or do you want me to talk more about Aleo specifically?
No, so I guess the question here is, are there parts of Aleo that are transparent?
Yeah, so the model that I like and that we try and strive for at Aleo is private by default. So you can actually hide all of these various aspects. And for those of you who are curious, Aleo kind of came out of this academic work, which is ZKV, stands short for Zero Knowledge Execution, and the whole goal of that was to try and extend Zcash effectively and enable both, privacy of the individuals interacting as well as the program being accessed. I think one thing that often gets overlooked in conversations about privacy and private applications is it's sometimes very convenient to have public state which is accessed. And so, I think this is sort of, I think it has to be left up to the application developer on okay, what am I trying to do here? What parts do I want to let the user choose whether or not they want to disclose? What parts of the program state do I want to make public? And the bottom line is, I think, protocols, in my view, should strive to make that up to the developer of the application. So you want to hide everything, you want to hide some stuff, maybe there's a selective disclosure. And if you think about it, just the last thing is, if you think about it, that's exactly how our financial system works already. It's like if I send Emre a bank wire, it's not like I know his account balance, right? Or I can tell him, or I can tell the IRS, and selectively disclose what I choose to. But by default, it's effectively private. And I think this by default private, but by exception public is the paradigm which will, I think, it kind of let you have the best of both worlds.
Also, I don't mean to I'm not trying to compare you on levels of privacy. I think there are use cases where more privacy is needed, and there's use cases where actually it might be good to have either a selective disclosure or even a transparent. Anoma, what parts are private? How does it work?
you can look at this from a couple of perspectives, right? You can look at this, what is private on the protocol side, what is private on user sides. I think starting from the user, privacy by default really, really matters, because especially if you have shared privacy sets, because privacy is a public good, as in even like I benefit from a bunch of other people being private because it enhances my privacy in the system actually. So we want to incentivize people to by default always be private, because it increases the privacy set that we can all rely upon. This is also why it's like not a great model that we want to like have separate privacy sets. Like when you think on, for example, like Tornado Cash, you have privacy sets between the different denominations and the different assets. And like that heavily starts segmenting the privacy guarantees that you're getting. So privacy by default is, I think, very important. But then it also comes down to, so like users can effectively choose how much privacy they want. They can be fully private. They can decide to be fully transparent. This is, in the end, up to the user. Because for some things, you need to leak some data, right? If you, so if you're a pure execution environment, that's not as important, because you don't generally need to coordinate with other parties.
Yeah.
But for example, if you're in this model where I have like a CryptoKitty and I want to sell it to someone, or I have some Bitcoin and I want to buy concert tickets in Barcelona for them, this kind of selective disclosure where you can discover counterparties with whom to work on achieving a settlement for mutual benefit, you need some amount of disclosure in order to discover counterparties. If you say everything is private all the time, it's very, very hard to have to discover counterparties around the world, unless you say, well, we have like the protocol is always the counterparty, which is sort of the kind of AMM model.
Don't you also need it somewhat for like oracles, for like price
Right.
things?
So a bunch of other things in these systems also need to be public. And I would argue that like proof of stake, for example, it's still a fairly modern thing. There's an argument to be made that this should be public because you want to understand what the security model of your chain is. Same for bridges, most likely. Bridges are still very hacky, and it's like way easier to recover from faults if you have public state instead of private state. So I think we can think on privacy on the user side, and there we want to give people the ability to be as private as they want to be, but also to be as transparent as they want to be, because we can't really estimate the use cases that developers and end users have in mind. So we should make it very cheap for them to be private, but not force it onto them.
Got it.
And then on the protocol side, as this tech matures, sure, we can be more and more private, but sort of at certain linchpins, I think it makes sense to be public. Yeah.
Cool. And Mina.
Yeah, I'd say Mina has a similar approach where we're not super opinionated about privacy necessarily. In fact, Mina did not start off as a privacy project. It started more of as a project that kind of breaks this scalability trilemma by having this, fixed size, tiny node, and you can, scale it as much as you want. But what we're seeing nowadays is, and as well as having the best, zero knowledge primitives, and what I call our aim is to be the most efficient ZK state layer in Web3. And what we're seeing now is that, the best use cases there are about making, for Mina at least, making user data private. So instead of, if I want to use a DeFi app or an NFT app or a DAO or whatever, instead of having to make every action that I take public, or every data that I need to provide public, instead I provide attestations, whether it's about my, personal financial information or my KYC or my DAO voting rights or what I voted, right? Where, people then, can make attestations instead of sharing the data. And then also, it's what we're discovering, it's fairly easy to build layer ZK roll-up type layer 2s on top of Mina. So in fact, like a handful of developers are using the alpha of our SDK, and one of them has already started building like basically a shielded transaction layer on top of Mina for native Mina tokens as well as third-party tokens. So how I would position it is like, if you have super easy to use, powerful ZK primitives, then all of this stuff becomes much more easy to build as an application ecosystem, and that's what we want to enable, at least for the Mina ecosystem.
Cool.
So yeah, I think there's like a little bit of a contrast in that like Penumbra is like quite opinionated about privacy, and specifically like picks like a very, very narrow and like focused use case. And if we rewind all the way back to the way that you introduced the panel, there's, I think, an interesting perspective there So looking at Zcash, there's the transparent part that was forked from Bitcoin, and then there's the shielded part. And if you go back and think about the history, right, that project started at a time when, you know, a ZK chain had never been built. And also at the same time, the rest of the blockchain ecosystem was much, much less secure. Or, sorry, not private. Mature. Oh. Sorry. That is, I mean, probably both. But much less mature.
It probably became
in particular, that you didn't have, like, you know, IBC didn't exist. Like, people were just, like, talking about, like, oh, what if we could do, like, cross-chain atomic swaps? Wouldn't that be cool? And I think you had much more of a sense in which, like, each chain had to be its own universe. And I think what's interesting about the context that we have today is that the development of cross-chain mechanisms allows individual chains to have, like, some specialization for a particular use case. And so, for instance, for Penumbra, right, like, having transparent transactions is not something that we're going to do. But that's not because we believe that no one should ever do this, ever. It's because, like, you know, if you want to go and do, like, a non-private smart contract, you should, like, do an IBC transfer over to Juno, where there's, like, people that's their whole thing, right? And our whole thing is, like, this, like, private DEX thing. And so I think that's, like, kind of I think a little bit of a different approach than trying to build a more general platform. I don't think that that's sort of, I don't mean that it's like I don't think there's any, like, value judgment in there. It's just, like, a different kind of strategy. And to some extent, it's also because, like, you know, like, Aleo exists, right? So, like, there's no point in us trying to build, like, this, like, generic like ZK smart contract system, because this is already being worked on, right?
Yeah, and I think I loved how you framed that, and I personally believe that the future is going to be application-driven rather than protocol-driven. I mean, all four of us up here arguably are kind of building protocols. I mean, Henry, you're obviously working on the most specific version of a protocol, but, you know, I think the future is naturally going to go to a place where people have a demand for a product. The protocol underneath it will naturally be built to serve the product that people want, right? And I think even in Aleo, although we're building a more general platform, and I don't think that Aleo is the right choice for every Web3 application. And, you know, one of the things that differentiates us from for example, Ethereum, is we don't have a model of an on-chain VM, which in some ways is limiting. In some ways, it's very powerful, but in some ways, it's limiting. So I think it really depends on what you're doing. Similar to privacy, like you said, for some things like NFTs, I mean, for some applications of NFTs, privacy may be important, but for just, like, showing off whatever NFT you have, I mean, kind of privacy is the opposite of the point, right? You want people to know that this NFT is yours and you want to show it off. You know, and maybe that's a bad example, but I think everywhere, I would encourage all of you who are at this event and, you know, hopefully at future events and going forward to think about just these trade-offs being made at a lower level and how those percolate up to potential applications that you could or could not build. Because I think there's room, there's a massive space to experiment. And there's a huge number of different ways these protocols and products could look in this paradigm. Yeah. So yeah, 100% agree.
Actually, on this product perspective, I mean, this is something that we're doing at the protocol level, where we are building a sort of the first chain in the Anoma ecosystem is going to be called Namada, to just focus on a very narrow use case, which is multi-asset privacy for any connected asset, where it's just like you want to have a single, very large shielded pool that has ETH, that has DAI, that has atoms, that can have effectively anything that's bridgeable. At the moment via IBC, and they all just live in the single shielded pool. You can do proofs in the web browser in like 3 seconds. And you can even move an NFT into this. This is a cool thing. Like for NFTs, you currently don't have any good privacy solutions. But if you have a multi-asset shielded pool, you can have an NFT in the same shielded pool, and it benefits and it sort of inherits the privacy guarantees you get from all the other fungible assets, because to an external observer, it's indistinguishable whether you move your NFT or some DAI.
If I can add one last thing, wrap everything up, maybe sure. Not to be the odd one out. I would say, like, and this is a bit preaching to the choir, given this is the Cosmos ecosystem, but like, there's no doubt it's a multi-chain world going forward. And like every chain inevitably, whether it designs itself to be or whether it says, oh, I'm just the most general smart contract platform ever, even in that latter case, they're all going to start like naturally finding their optimal, frontier, if you will. Like, I don't know, maybe Ethereum just ends up being, the asset settlement platform going forward, right? But it's not going to be the privacy layer, right? So I think we just have to accept that, it's a multi-chain world at this point.
It actually comes with a lot of benefits to end users as well. Like if you think on building privacy tech on Ethereum, you inherit a bunch of transparent stuff that ultimately becomes a massive privacy leak for you. But whereas if you sort of look at the entire stack in an integrated fashion, you can very quickly build very good products that like deliver specific use cases for people that are hard to build in sort of a fully generalized manner.
Sort of speaking of that connection point, we did a panel earlier today where we talked about bridging. We mentioned this idea of like what happens with a privacy zone or privacy chain once it has to bridge away. And I guess like currently in all cases, the minute you take that leap outside of your L1, you will inevitably be revealing something. But have you been thinking about that as, like, are you thinking of creating extensions of what you're doing, like extending the privacy space into those bridges at this point?
The ideal thing would be to have cross-chain shielded pools. Actually, let's call them shielded soups because they're not
cloaked.
Okay.
Nobody's picking up my thought.
Cross-chain cloaked soups. All right. No, but so I mean, but this is
trying it out here.
This is still like early research, right? To get to cross-chain pools or cross-chain shielded pools. I think for now, honestly, if you start breaking, because you break linkability quite a bit. So if you go into a private ecosystem and then you go out of it, you can go out to completely new addresses. They are not linkable to your old addresses that used to go into the private ecosystem. So to me personally, I think there's not a lot of need to build super private bridges at the moment because as long as like you just sort of taking public routes between private things, it doesn't really matter the routes that you're taking are private. I mean, eventually leak some metadata, but this is sort of a problem we can worry about maybe in like 4 years from now.
Okay.
Not right now.
Yeah.
We just have to consider this, right? On the privacy side, there is the amount of privacy preserving tech out there right now is so limited. Like it's tiny. And I think we should really focus on making private applications a reality before we sort of start thinking like, how does this need to look like in the perfect world?
Right, because the default case, right, is that like a layer one like Alio, for example, could if it was connected to some other ecosystems, could kind of be effectively a mixer, right? So you could go from, let's say, Solana to Alio and then to Ethereum or something. You could it basically functions the same as a mixer. And these bridges, oftentimes the focus is just about passing those messages, and in some ways, like you need that information to be public for security reasons or just for functional reasons. But I think it's an interesting unexplored design space, because again, we're talking, all of us are kind of more privacy or ZK focused projects, but if we're talking about bridges between, say, Solana and Ethereum or something, I think it is kind of an unexplored design space to kind of figure out, could you, without kind of having an intermediate layer one protocol, be a mixer? Like, is there a way to kind of make that private? I'm not aware of anybody who's kind of looking at that, but it's interesting. It's hard.
And
bridges are hard.
Just to sort of mention something
Private
that was
bridges are harder.
It was in the. Oh, do you want to say something before?
Just as a riff on that, I think that I don't have like a lot of optimism that type of design would work out. And the reason is precisely because if you have a private L1, you can use it as a private bridge. I think having, I think that the development of a private L1 that can talk to transparent chains is going to basically obsolete the development of any kind of private bridging between transparent chains, because why would you do that when you can just go through any of the private zones?
Something that came up in the previous panel as well was this idea that when we think about privacy and bridges, I have had a tendency to think of it as cloaked, wait, I got to keep my own term going, hidden tokens, basically. It's always token transfer. But as Sergey mentioned, what if it's messages that actually have actions on those destination chains that are private? Then it's not so much like I don't know if that also reveals as much as if you were doing token transfers in and out. I don't know if you've thought about that.
I guess I think that part of the reason that people are focused on token transfers is that it's like a simple thing that people haven't done yet, right? Like in order to do like private messaging between applications, like you first have to like have the private applications, right? And we don't. So I think that part of the kind of I don't know that that's really about some kind of like narrow-mindedness or that people aren't imagining this thing, but just that it's like there's a big gap between imagining the like glorious ZK future in which everything is private and like, maybe we could build like one like private thing that actually clearly has product market fit first.
Yeah.
I wanted to add there, to Henry's point, like this is my pet peeve is also like tokens is the only thing that exists in Web3 at scale today. Like it's all speculation, right? And to build these, these applications that are about so much more than that, you do need some sort of privacy at the state update mechanism, right? Because like for example, in how Mina approaches this is, Mina is by design, is basically any chain can run a full node of Mina within itself. But what the other chain is hearing from Mina is just various state updates into a specific, application that's running on Mina. So how that state update is achieved, that's where the magic of zero knowledge happens, where like the proofs get posted on chain and they trigger the state update, as opposed to the logic running on chain and the chain determining in a transparent way how the state update happens. So I think this goes also kind of to the off-chain versus on-chain distinction, where the more you can do some things beyond the token world off-chain, the more privacy you get to preserve. There's also other benefits, such as operational efficiency. But I think that's a paradigm shift that we all need to start getting into as an ecosystem.
I think Henry has a response.
I'm not sure that I agree that it is always better to move things off-chain. But I think that there's actually there's a kind of an interesting way to look at sort of like differences between projects, and like I don't want to I'll just sort of say things, and then if I say things that are wrong, then I can just be immediately corrected. But if you think about, for instance, the way that Zexi, which Alio is built on, the model is almost like every transaction is like a micro roll-up, right? Like there's some smart contract state, and the way that the execution happens is that someone is going to execute the contract and then produce a proof of the execution and then submit that to the chain. And it's like, bundled up, but effectively it's like a roll-up, but at kind of this like arbitrarily small scale. And the thing that's really cool about that is that, right, the actual application data doesn't have to be on chain, but the problem that it doesn't really solve is like who is actually executing the smart contract. And so there's kind of two possible alternate approaches to that. One, which we're working on, is like, okay, well, we'll zoom into a very specific type of application and see how we can do some kind of like additive aggregation of input values. And then another is with Anoma, part of this was like a really cool thing that like clicked for me recently, so hopefully it's correct. Like the reason that there's like, it makes sense to have a bartering system that's built into this system is that it's like you're kind of bartering like different people's like potential state updates.
That is actually a very good way to describe this, yes.
Yeah, I think I really love what you said. And by the way, for everybody who ever wants to get someone building a privacy protocol in Knots, just ask them to whiteboard you in 5 minutes, how you would build private Uniswap. And you will see people do many backflips. Because it's complicated, right? Because as Henry's pointing out, and let's just take this XE model, right? You're taking this off-chain, you're doing an on-chain, computation. Who is running that computation? In Zexi, it's the user, right? But Uniswap is kind of built on this idea of a smart contract, which requires an on-chain VM, right? And so, you have, but at the same token, the on-chain VM model typically is the account model, and the account model is very hard to make private, right? So you kind of end up in this weird space. So anyway, it's a fascinating question to ask people, for any of you in the audience. The last thing I'll say though quickly is, I think there's a world, and what we haven't touched on yet is, I wonder if there's a world in which you can hybridize these two models, right? One thing we're looking at Aleo potentially is to have some concept of like a hybrid off-chain and on-chain computation, where you can imagine a user basically kind of almost like meta transactions, where you construct a transaction and then you forward it to some approver or some other entity that basically sequences and or finalizes the transaction. And maybe this paradigm enables you to hide the things that you care about hiding, but it still gives you this advantage of having concurrency and composability, which I think are the main advantages of an on-chain VM model.
To maybe clarify this a little bit, it's technically not the VM. It's like, so the reason why you can't build Uniswap privately is because you've someone needs to hold the state, right? And in Uniswap on Ethereum, the contract holds that state. And the reason why you can't do it privately is because the person that constructs the proof is the person that interacts with the contract, and that person necessarily needs to hold the shared state in order to be able to construct the proof. I think long term, there's actually some interesting research we can be doing, and I think some of us are already doing, around fully homomorphic encryption and how we can have shared private state for longer periods of times. And you can even think more, I'm thinking now between the message passing, right? You want to invoke some cross-chain, you want to invoke some other L1 in a private manner. What you could actually do is how long do you need these messages to be private? If it's just for front-running protection, you can just really need a couple of blocks privacy where it's encrypted before they're executed. So there's sort of a breadth of design space out there, how we can think on how do we make more and more of this ecosystem private. And ZK, zero-knowledge proofs aren't the end-all. There's a ton more open research that's probably going to take another 10 years to materialize into production-ready apps.
Yeah, I do. So I agree the state matters, but also I do think the VM does matter for a model like Zexi, right? If you're creating a proof about a state, that even if it's public, you can just put everything on chain, just publicly, just make it public data. But even then, you have these records that can only be updated by one person at a time, right? So unlike Ethereum, this is solved because every node is a sequencer, right, effectively, because they just decide, okay, hey, the mempool looks like, and this, by the way, is why front running is a problem, right? Because if you're the sequencer, you're like, that looks like a good trade, I might just take it. So this is why, again, I think that it's a really interesting kind of tension between these different properties that we're trying to achieve.
I want to bring this back to Cosmos, the other side of the privacy in Cosmos. How do you, I think in the case of Penumbra, there's very clear connections already to Cosmos and IBC, but yeah, how are you all thinking about actually this ecosystem? Is this an ecosystem that you see yourselves bridging to or working with bridging projects to get kind of connected to? And how could maybe people in the Cosmos ecosystem start to think about your projects?
Yeah, from the Anoma side, Anoma wants to bridge to everything. At the moment, by far, the best bridging tech out there is IBC. So I would really say everyone should be building IBC adapters for every other chain. People should be out there building IBC adapters for Near, for Flow, for Polkadot, you name it. Pretty much any fast finality BFT chain, someone currently should be building an IBC adapter, because that makes, not necessarily to connect it to Cosmos, but to make all chains connected to each other, because this makes the ecosystem much more composable. If you can all of a sudden do a Penumbra, Aleo, Anoma, Mina hop, because all these chains just have a common interoperability standard. This is the way I think about bringing privacy to the entire blockchain ecosystem, just by getting people to implement IBC, because it's a great protocol.
But what about an EVM? What about EVM to EVM, do you think that it should also be like Evmos to Moonbeam, or should both be IBC?
Yes.
Is that the most effective way to do that?
Yes, this is the thing. Like IBC has very little, actually, I think has no dependencies on the specific state machine. Like it has a dependency on the consensus, as in it needs to be a fast finality BFT consensus. It doesn't matter whether you're running an EVM on that consensus or some ZKVM. That's secondary. This is like any BFT chain should be implementing IBC to just talk to other BFT chains.
Yeah, in the case of Mina, I agree with that, by the way, although I know the Nomad folks are doing some cool stuff there too for EVM, but side note. In the case of Mina, as I mentioned briefly, Mina is designed to be a full node, whether you're on a client, a traditional client, or you're on another blockchain, right? So we're incentivized to bring value to every other layer 1 or layer 2 ecosystem out there by providing this kind of user data privacy layer to the other chains out there, whether that's Cosmos, whether that's Ethereum, Solana, what have you. In fact, there has been what we call a trusted ZK bridge from Mina to Ethereum that's been in progress for a while. Hopefully there's going to be some sort of a demo or an overview in ETH Amsterdam in the next week, next weekend. And that by nature is default for any other EVM chain as well. So for example, Evmos in the case of Cosmos, but then also is not VM dependent either. It's just engineering that needs to be done for an efficient smart contract verifier of the canonical ZK state of Mina. So our goal is to, basically just bring some of the unique features that we can to every other, specifically about ZK, to every other layer 1 ecosystem out there.
What would someone in the Cosmos ecosystem be able to do with that?
Yeah, so let's say you're an AMM, or let's say you're a lending pool on Evmos or Cosmos or whatever, and you don't only want to serve over collateralization, for your lending logic. You want to be able to underwrite users. For that, you need data on your users, whether it's their identity or whether it's their financial background, how much salary they're making, and let's be honest, as much as we'd like. 99.999% of the world is not using blockchain for their daily stuff, other than maybe buying and selling and speculating. So you need to be able to ingest that data in a private way, because no one is going to put their, this is how much I'm getting from my employer every month in my bank account. You're not going to put that on chain.
Unless you work in blockchain.
Well,
then apparently it's all public.
Yeah, but I personally don't think that's a viable future. So there, Mina can provide this rails where users are easily able to bring, using zero knowledge, easily able to bring in attestations about their data, whether it's their credit score or their credit history or anything else about whatever the underwriter might require. And then have that automatically settle down to, let's say, Evmos, just because it's the straightforward answer here, automatically settle down to Evmos, because Evmos would be running a full node of Mina and be aware of all these state updates. So that's kind of the end-to-end flow that we're imagining here. It's such that any other layer 1 application can benefit from this ZK attestation superpower.
Cool.
I think it's similar for Aleo, so I won't rehash all that. But I guess the one thing I just quickly want to highlight, and full intellectual credit to the O of One folks and Isaac and and the folks over there. This idea of this recursive proof, right? One of the things about that snarks let you do, aside from cloak or conceal, is compress, right? And this is about compressing a lot of state into a small proof. This is how rollups effectively work. But I think it's overlooked as a tool for bridging, right? 'Cause it enables you to take a lot of state or a current state and compress that down as something that's relatively lightweight. And this is exactly, so effectively most bridges are implemented as light clients on the destination chain. If you have a very light client, then that can be a very powerful tool that, again, Mina, again, or the O of One folks kind of came up with this concept. Others, including Cello, we also have a kind of a recursive light client that we use at Aleo, but I think in general this is a concept that can be adopted, and I think is the future for bridging across the space, is using this compressing property of zero knowledge proofs to potentially make it easier to run full light clients on, as destinations of whatever bridge.
My confession is that I was listening and then forgot the question.
The question was, how are you connected to Cosmos? But for you, it's pretty easy.
Yeah, I think for us it's fairly straightforward. I think that part of the kind of like meta there is that...
Not Meta, the company.
No.
Okay. We can't use that word anymore, by the way.
I've actually succeeded in not having that be part of my brain.
Okay.
So
I wish I was so lucky.
Yeah. So part of the thought there is like about, how do we sort of have like a small scope that we think we could like definitely build. And I think part of the reason, like I mentioned a little while ago, is like the idea that if you have really pervasive bridging, you can intentionally like specialize and like narrow the scope that like one project needs to do. And so for us, I think sort of like how do we, like what is our relationship with sort of like everything else in Cosmos? It's like, okay, well, like everything except for like the 4 like bullet points that were on one of my slides of like stake, transact, swap, and market make. Like literally everything except for that, you should go and use another chain. And that strategy only works because of sort of intentionally conceptualizing ourselves as part of this like interchain ecosystem, rather than being like we're not trying to build an ecosystem, we're just living in one.
Cool. All right, I feel like I've taken up a lot of time with these panelists. I do want to open it up to the floor. I don't know if anyone has any other questions. I do have more stuff if you don't, but I wanted to share the option. So yeah, this is questions for our ZK and privacy experts.
Hey guys, good panel. Sorry, a couple of questions. I guess first, I'm curious what % of applications do you think will end up being privacy preserving in a blockchain or Web3 ecosystem, right? Because traditionally, like in Web2, it's been an uphill battle and the percent is actually pretty low. Kind of curious from the demand that you're seeing, just give me a number and kind of think through this. And I think a second question that I have is around security and how you think about it. Kind of, ZK privacy preserving tech in general is very complex, right? And like a lot of credit to a lot of the builders. Curious how you approach security, how you think about, audits and things like that, and how do you think about catastrophic kind of failures when privacy or when there is a bug, when the privacy is leaked and compromised, kind of how you think through those things. Thank you.
Yeah.
Percentage is the first one.
Yes. So you mentioned the example of Web 2, and not a lot of things are privacy preserving in Web 2. I would actually push back against this and say the model is different, right? Because your bank is private to 99.999% of the world population. It is public to the organization. The same is true for Twitter, Facebook. Pretty much all Web 2 things are privacy preserving against the general public, unless you're like a nation state. Like if you're the NSA, then you're not private against the NSA, but pretty much against everyone else, you're fully private. And I think as a result, if we want to build Web 3, we really have to think, how do we get to a similar model where very, very few people have access to all the data? Because currently the model we have is Ethereum and everything is public. And just think for a moment that like world finance moves to Ethereum tomorrow, and everyone is fully public. Like this is not like that it's Web 2 public. It's like, no, everything is completely public on every human on Earth. And the next day, someone sort of in the middle of nowhere with internet connection can run a global financial mass surveillance program by having an internet connection. It is like we have to be way more privacy conscious in Web 3 than in Web 2 because we don't have a bunch of institutions that effectively guarantee our privacy for most parts against the rest of the world. So I would say like we probably need, I don't know, practically speaking, 99% of all applications on Web3 eventually need to be private, because otherwise this is like a significantly worse security guarantee and privacy guarantee than Web 2 for most normal users of these systems.
I was going to say the exact same thing. Well, not the exact same. No. I mean, but what I would add to that is, like, at the end of the day, blockchains are a global state layer, right? That's what they are, and not everything needs, a global state layer either, right? So it's in my opinion, it's going to be a part of, the internet And if you cannot somehow preserve your privacy within this spectrum, then you may not need to be using a sort of a Web3 landscape. But then also on top of it, what percentage of Web3, if we ask it that way, I think it also depends. An average user, I would say, yeah, like definitely 95% of it will end up being private, because I don't see anyone in their right mind sharing this much information, on an ongoing basis. But maybe as a, in a TVL sense, maybe it's less than that, because ultimately, if you kind of, as a user, you interact with some private layer, and then that settles down to, again, maybe Ethereum ends up being this global settlement layer for all the value, and it's not private, and that's fine, because what you're seeing on Ethereum doesn't give you information on a per user basis. It's aggregated, so that might end up being not private by definition, but also private in some other sense.
Not linkable.
Yeah, I think the first two. So I agree with what these two gentlemen said on the kind of importance of privacy. I think you asked a second question though, which is around complexity. I think it's a great point, and remember, one of the hard things about private protocols is that if something goes wrong, sometimes you can never know. I mean, Zcash very famously had a bug, and was it ever exploited? Do we know? I mean, probably not. But
we
again,
know it hasn't been exploited yet.
Okay, we know that
the turnstile hasn't been broken.
So, but the point is, like, these things could go undiscovered, and that's a little bit dangerous.
Yeah.
But on the other hand, I think in some ways it's more secure, because you're putting more assumptions on cryptography. Whereas if you look at like a lot of Web3, there's so much. I mean, one of the greatest innovations, or arguably the innovation of that enabled Web3, is this game theoretic security, right? But when you start layering game theory on game theory, at some point the assumptions, you have to question whether or not it will actually work, right? I mean, there's this concept that's kind of been around for a long time, thinking about, like Ethereum validators are all supposed to rerun every state transition exactly step by step by step. But do they? Or do they just take whatever node they got it from's word for it, right? If they're like, okay, this block came through, do I really need to re-execute these transactions? I mean, they're kind of not really incentivized to. So I guess if you're thinking about, does Ethereum provide me as much, or does any model that relies on game theoretic consensus actually provide me the security I'm thinking I'm getting? I don't know. I think it's a much less definitive answer than a cryptographic proof, right? Where, I mean, the idea is if you believe the math, of course there's flaws found in these things all the time, but fundamentally it's a much, much smaller window if you can design it right. Now, these systems are brand new, and of course, because, ask any cryptographer, they'll be like, if it hasn't existed for 50 years, it's broken. You know what I mean? That's just the attitude, and that's an attitude for a reason, but, I think we're going to get there. And I think the fundamental assumptions that these are resting on, I think in some ways are stronger.
I think on point 2, we should be doing way more formal verification of cryptographic protocols, because they give us fairly high assurances that these systems are correct. I think we shouldn't. This is sort of why I'm terrified of this one chain to rule them all narrative, especially around Ethereum, right? That we should design these systems that are interconnected where components can fail independently. We shouldn't build one global financial system on Ethereum or on any other blockchain for that matter. We should have many different blockchains, and they should all be able to catastrophically fail, but when they fail, they only kill themselves. They don't kill everything else. Whereas if you have imagine a model where everything is settled on one security model, you all of a sudden have this problem that the security model may fail due to cryptographic assumptions. And all of a sudden, global the financial system just breaks. This is not how we should be building. Way more for resilience, and that necessarily means that we need interconnected systems that can fail independently.
Whoa.
And sadly, most of the ways that most money is lost in Web3 today are just way more benign than that. I mean, it's almost a good problem if we get to the point where someone's exploiting this deep down dark fissure of a protocol, because there's so much low hanging fruit, unfortunately. But yeah, no, I think it's a reasonable concern.
Yeah, I think I kind of laughed a little bit when Adrian mentioned the sort of if we imagine tomorrow the entire world financial system is on Ethereum, if you think about how that ecosystem actually works, that concept is really hilarious. But to the first part about privacy, because of that baseline of public blockchains just being this complete like information free-for-all. I think that the kind of the bar has gone a lot lower than it even was in Web 2. And so with respect to the privacy aspect, I think that as the deployment of ZK systems matures, we're going to have to start getting into more nuance about, like, okay, private to whom, right? If you have a model like Mina or Alio, you could actually imagine like doing a lot of like the kind of Web 2 level of privacy, but just with this extra assurance that actually all of the data was like executed correctly, because you can commit that onto this chain and use that as the settlement layer. And I think we're going to sort of see this like spectrum of different like levels of privacy, where maybe in some cases, there's someone who's like relatively trusted. Maybe in other cases, there's attempts to try to minimize that through engineering. On the second point about the kind of assurance of the cryptography, this is something that I'm actually very optimistic about, but not for any kind of technical reason. It's actually a social reason. And that reason is that if you look, right, like the bug in Zcash, right? Like, that bug was not exploited because at the time that it existed, there were like 12 people in the entire world who like even understood that could happen,
and they all
worked on Zcash, right?
Like, it's both reassuring and not assuring, but yeah.
Right, but if you look at what's happened in the last, say like 4 or 5 years, and in large part because of like the leadership of Zcash, right? Like now you have this whole ecosystem of all these people who are developing like really, really good production quality implementations of quite complex cryptography, right? Like the fact that Mina exists is just like incredible, right? And it's not because there's some like technical advance that's driving that. It's because there is now this like production of people who do really serious real world ZK stuff. And that is only gonna keep growing. And so I think like that like force is gonna like wash out like all of the technical details, the formal verification, like people are gonna build the tools, like it's gonna happen because there's just
the momentum.
It's there.
And it's the power of open source.
Last point, because we're...
One very quick thing. When I explain like why I'm excited about Web3 to other tech people, non-Web3 tech people, I agree with like the point about like more cryptography professionals and more better cryptography. But also like this whole space is an amazing Trojan horse to get cryptography into the hands of everyday people, right? Like no one in Web 2 has very few people have a public-private key pair in their hands. But anyone with a MetaMask, extension because they want to buy some NFT, they get this public-private key pair, and they can then use it for other things, which I think is amazing.
Amazing. All right. Sorry. Yeah, this was amazing. Thank you so much for doing the panel. I hope you guys enjoyed it. I know we're a little bit late, but yeah, thanks so much.
Thank you for having us.
I think if anyone is interested in learning more about these teams, you will be sticking around, I hope. I do want to let everyone know, especially those who came later, we're actually doing a dinner later tonight here. So this event ends around 5:20 now because I think we're 20 minutes late or 30 minutes late, 5:30. And then at 7, we're also doing a dinner here and you're all invited. So I just want to make sure you know that. It would be very cool to hang out and we might try to do karaoke. Do you know this? Okay, some people weren't here for the intro, so I thought I should let you know. Okay, cool. Thanks a lot.
Please don't leave the room because we still have one more talk, so there is no break.
No break.
Yeah, no break. We're still staying here, so please take your seats. And I'm inviting Carlos Rodriguez Vega to give the last talk, and after that, yeah, we're going to wrap up. Thank you.
sorry. Oh. Thank you. Hello. Yeah, thank you. So, yeah, hello everyone. My name is Carlos. I'm the IBC Engineering Manager at Interchain GmbH. And today I'm going to be talking about one of the most important, but sometimes difficult to understand, core building blocks of IBC, which is the light clients. Yeah, I'm going to talk about what they are, why they are one of the differentiating factors of IBC. I will talk a bit also about the vision for IBC and what part zero knowledge proofs could play in the future. So, okay. So probably everybody is familiar with IBC, but for those that are not, yeah, just very briefly, IBC stands for Interblockchain Communication Protocol. Interblockchain Communication is a protocol that allows sovereign, independent chains to communicate with each other. So yeah, this picture at a very high level shows the main actors engaged in interblockchain communication. We have the nodes participating in two chains, chain A and chain B, and we have some off-chain processes called relayers that are able to submit transactions on each chain. IBC relies very heavily on light clients to guarantee the correctness and the security of the protocol. And this is one of the differentiating, very distinctive factors of IBC comparing with other bridge or interoperability solutions. In general, a light client is a client that connects to a full node, requests new headers, is able to verify by checking hashes and signatures that those headers are trusted and are generated by the underlying blockchain. And in the context of IBC, chains run a light client of the counterparty chain with which they communicate. So in this case, chain A runs a light client for chain B, and chain B runs a light client for chain A. The light client on each chain tracks the consensus state of the counterparty, and it knows how to verify proofs against that consensus state. So for example, if we talk about a very concrete example of token transfers, for example, if I want to send tokens from chain A to chain B, there would be a transaction in chain A that stores in a state a commitment for sending those tokens. That commitment, a proof of that commitment, together with a block header, is relayed by the relayer to chain B. And there, the light client for chain A can verify that that commitment for sending tokens is actually stored and the tokens can be received. And yeah, this is the reason why we say that the design of IBC is trustless, because there's no need to trust any other party except the two chains that are involved in the communication. We don't even need to trust on the relayers. We only need them for liveness. We need them to submit messages to update the light clients, to transfer data packets from one chain to another, but we don't need to place any extra trust on them for the security of the protocol. Yeah. Yeah. Now, if we compare with bridges and other interoperability solutions, one of the other solutions, yeah, there is an extra trust layer. We need to trust the bridge validator set. And yeah, what happens if you cannot trust the validator set of the bridge? Yeah, we have seen in the last months several high-profile hacks, like the wormhole attack. Yeah, where the attacker was able to submit transactions with valid signatures from the validators of the bridge. Yeah, withdrawing basically the wrapped ETH on Solana and then exchanging it for ETH in Ethereum. This was actually the main problem was that there was a smart contract exploit, to be fair, but recently we also had the Ronin hack, where the attacker, yeah, Ronin is an Ethereum sidechain, but it was one that was very centralized, so there were only 9 validators, and the attacker managed to take control of the private keys of 5 of those validators to fake forged withdrawals of the funds in the breach. So yeah, as more and more value flows through cross-chain breaches, these become a more attractive target for the hackers. So yeah, cross-chain breaches and protocols are critical infrastructure, and any successful attack has cascading effects. At the moment, yeah, the 3 largest by dollar volume hacks are attacks on breaches. So that's why, yeah, it's a critical infrastructure at the moment, and yeah, deserves special attention. So if we talk about the vision for IBC, yeah, IBC launched last year with one application with fungible token transfers. We released interchain accounts recently, and it went live on the hub this week. We're going to release related incentivization very soon, and we have in the pipeline some very exciting features. Yeah, some teams in the IBC community are working on IBC queries, which will allow chains to query the state of their counterparties. Also teams are working on NFT transfers. We also have in the pipeline features to make IBC more sustainable and scalable, like connection and channel upgradability. This will allow chains to take advantage of new features without having to create new connections and channels. And we also have multi-hop routing. This is a feature that will allow to send data packets from a source chain to a destination, but hopping through an intermediary chains. And yeah, at the moment, yeah, the Cosmos ecosystem consists of more than 40 zones, all of those interconnected with IBC. These chains are built with the Cosmos SDK. They are using the Tendermint consensus algorithm. But the vision of IBC is to make it a universal standard protocol for inter-blockchain communication. So we want to expand beyond the Cosmos. We want IBC to be used in other ecosystems. And yeah, for that reason, we also need light clients for the consensus algorithms of those other blockchain ecosystems. And yeah, there are efforts going on that front. So, for example, there is work being done on a Beefy light client in Go. So this would be the light client that Cosmos SDK chains can run to verify a state of chains built on Substrate. There's also work being done to develop IBC and a Tendermint light client in Rust. So Substrate chains can run the Tendermint light client and verify the state of Cosmos SDK chains. For EVM compatible chains that run the IBFT 2.0 consensus algorithm, there's also work going on to implement IBC and the IBFT light client in Solidity. This implementation of IBC in Solidity is also being used for a Tendermint light client for the Cello EVM. And there's also an implementation of the Cello light client that is targeted to run as a WASM binary in Cosmos chains. And beyond this, there's also there would be also in the future work to implement light clients in other blockchain ecosystems like Near or Algorand. And yeah, another potential area of research that it will eventually probably come to our roadmap is the use of zero-knowledge proofs. Yeah, we consider at the moment like 2 use cases. One of them is related to computation optimization or compression. Yeah, there are 2 places where this can be applied. One of them is when updating light clients. This is one of the most expensive operations because we need to verify the signatures of the validators that have signed the block header that is going to be used to update the light client. And also, when verifying the state transitions of a chain, there needs to be a Merkle-proof computation to compute a root hash. And as state trees becomes larger, the computation becomes more expensive. So one possible optimization there is to wrap or convert the Merkle-proof into a CK snark that is verifiable in constant time, independently of how large the state tree grows. This imposes extra complexity on the prover to generate the CK snark, but the verification becomes cheaper for the verifier. And the second area of use is obviously privacy. So as more chains or zones are joining that have shielded features, then it would make also sense to be able to send or receive packets in a private way. So basically to have shielded transactions over IBC. And yeah, I would like to thank also the folks at Zcash, Socrates, and Anoma for the time that they spent with us discussing these ideas and sharing their ideas on this topic. And that's the end of my presentation. So if you have any questions, I will be happy to answer.
Hey, hello? Oh. Hello? No, just use this. All right. I want to apologize. I actually missed the beginning of your presentation, but with what you just shared, what's the roadmap or timeline for this?
For the zero knowledge?
Yeah.
Yeah, this is difficult to say. It's really very early stage kind of research idea. We have other things still in the pipeline, like upgradability, multi-hop routing, other features, but this is something that can come at some point. At the moment, we don't see bottlenecks on for example, updating clients or computation of Merkle proofs. But as the usage of IBC exponentially grows, hopefully, these are areas that could be affected performance-wise, and then zero-knowledge proofs could offer some solution there.
And the first one, the sort of light client, is that using that kind of compression technique? Is that the idea there, that you would make it like a smaller light client?
Yeah,
like using recursion?
That's the idea, yeah. Mm-hmm.
Cool. Is it influenced by Plumo?
Sorry?
Is it influenced by Plumo, the Cello light client at all?
I don't know.
Okay, well, I'll tell you about it after.
Okay, yeah.
Sure. Cool.
Yeah.
Any other questions? All right. Thanks.
Thank you.
So that wraps us up, right? Yep. Okay. So I don't know if I don't think we really told them which slide. We had a slide,
yeah,
but we forgot to say which one it is. So I guess that ends this. Oh yeah, there it is. Great. Fantastic.
Yeah, so I think just to say basically big thank you for everyone for coming, especially all the speakers. I think it's been an amazing day. We're going to be sending out a feedback form, and we'd love to hear your thoughts. And if you want to learn more about other things that we're doing as ZKValidator, you can find them on our blog and our website, and also support us by delegating your atoms or Osmo. Yeah, thank you very much.
And eventually Evmos.
and hopefully
right?
very soon Evmos.
I want to just, there's an event coming up, a Cosmos event, and David was about to tell us a little bit about it, so just if you want to just come up here really quickly.
Hi, everyone. I just want to invite you to the next Cosmos event that is happening in Prague on 16th to 17th of May. So that's Monday and Tuesday. So you can come on Saturday, explore the city, and then go to the conference. The conference is developer focused, and it will be in a similar way as Cosmoverse was in Lisbon, if you were there. So like everyone is coming, Sunny from Osmosis, Zaki, Dean, Sergey as well, Billy, and guys from Informal Interchain. So it will be a cool event. You can just take your laptop there, do some coding, get some bounties, and then enjoy some party on Monday. It will be a cool party, so I hope to see you there.
Thanks. Do you want to do? Okay, so one small note is we have a member of our team who's sadly leaving the ZKV org to actually go deeper into the Cosmos ecosystem. So Susanna, thanks so much for your work on this event and generally, and yeah. Woohoo! All right, so that wraps us up. As I mentioned, stick around. We're going to do some food at 7. Oh, we're going to leave here. We can go downstairs and hang out where the beanbags are and the little space star stuff and the fireplace. Yeah, and please do get in touch with us, hang out. And actually, I guess maybe on the privacy front, continue to explore with us this idea of how we can bring privacy into Cosmos. We think this is important. We hope you do too. Cool. Thanks.